people's opinions. You don't actually care about what people have to say. You just want to insult people.
Now, honestly, you sound sick in the head. You sound like you have a mental illness. That's what I hear from you.
We're trying to calmly explain to you. We're trying to calmly explain to you
have the mental capacity to tell me anything I don't already know.
Electric, what's your education? What's your education on this? What do you have?
I'm way smarter than you. You're
higher
very
education in physics?
and you're not making sense. You tried to explain perspective.
Have you taken a university level course in physics?
What does that have to do with the conversation, dude? What do you think you're talking about?
What does optics have to do with perspective and measuring angles of perspective? Is that what you're asking me?
All right, so this has
everything to do with it. In fact, it is the foremost expertise on the subject. The study of reality with respect to visual mediums, light.
You know, it doesn't matter what university you attended. Your pace is indicative of a mental retardation. You don't know how to convey your
taking
thoughts correctly.
The time
and
to
it's
choose my words.
There's a language barrier.
Because I'm taking time to choose my words,
and you failed your education.
You just choose to insult people.
You don't know about
and then
perspective.
You're telling me that I'm uneducated on the topic is interesting, considering that you haven't taken a single.
Failed you. You paid all that.
You didn't take a single university level course
and you still
on the subject.
So I didn't waste my money, and I know how it works better than you. How funny is that?
You did waste you've wasted basically like this conversation because you're choosing to stay on a high horse of intelligence and education, right?
Yeah,
you're telling me that I'm slow, but for some reason,
you don't know what you're talking about.
I actually have the education and credentials.
You don't sound educated. You sound very
dumb.
Up. You sound like you have brain damage. Dude.
I think he explained it pretty well, though. Electric.
Hey, what's up? Who's that?
You know who this is.
Hey, what's up? Yeah. Hey.
What's up? I think he explained it pretty well, man. Come on, you're not giving him the benefit of the doubt.
Dude, you got these freaking globetards thinking they're making sense. They're slow ass pace. They just pulled up from.
So basically, what I'm hearing, Electric, is that. The reason that you think that I'm wrong and stupid, right? Let me just steel man you.
All right, so the reason you think that I'm wrong and stupid.
Also, I can't steel man you. I can't even try to understand what you're saying, Electric.
Electric, please let him at least finish, man.
No, I don't care what he's talking about. He's very slow paced.
Right, so you just want to mentally masturbate. That's all you want to do. You just want to throw insults and mentally masturbate in people's ears.
There is no.
You don't care about anybody else. You don't care what anybody has things to say.
And they don't.
You chose the topic, and then you want to go la 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 la. I can't hear you.
Gentlemen,
yeah, Mogi, shut the fuck up, you idiot.
No. Mogi, just give him like a minute to say something, right? And then Electric, when he starts talking, please give him the same respect.
Yeah, who said that I wasn't going to do that? Now tell this socially.
You weren't doing that.
Shut his dumb ass up. Mute your mic when I'm talking, you dumb fuck. Anyway,
you weren't doing that.
This is what I'm saying. This guy, I asked him, what is perspective? What is causing the ground to appear near eye level? And what he said was that things below eye level do not raise towards the vantage point. That was the first thing that he said. So I know that there's some language barrier. I can disregard everything this jabbed up moron wants to say because he doesn't conceptualize perspective correctly because he's presuming he's on a globe before he makes any fucking sense of the argument that
Let me know when you're done. Are you done? Hold on one second. Hold on one second.
That's called clarity. Since you don't like clarity, you like globe nonsense. Now you're gonna let this idiot talk, right?
Okay. Hold on. All right. So did he say that things below will go above eye level?
Yeah, nobody was paying attention to what he said because it's not worth listening to this idiot.
Did he say that?
I didn't say that.
Okay, so he didn't say that. Because I think everyone will agree that things below will go towards eye level.
Yeah, why do you think I was correcting him?
I honestly don't think that he would say that.
Nobody knows what he even said. I was the one intently listening to him
You
get
didn't give
things
him a
wrong.
chance to clarify. Did you give him a chance to clarify before you jumped all over and
Yeah, let's
started
let him
talking and didn't
drivel
stop?
on and be incorrect. Yeah, let's listen to the
All right,
idiot just
now
drivel.
allow him to. Okay, now allow him to finish and don't cut in. Go ahead, Mogi. Clarify what you said.
Fuck this retard.
All right. So when you
he ran
say
away.
he just rage quits.
Yeah, go ahead. Go ahead. You can still explain what you were trying to say. I understood what you were saying.
I don't know if there's anything meaningful to say there, right? So he's just saying about the he's interesting that he talks about the vantage point, right? When the vantage is the eye that is looking at some point, right? If you want to talk about something else, that's a different angle. That's something else you're looking at a different angle. Right. And he was getting very pissy about measurements when we were actually trying to measure things and explain angles and eye levels. And I provided a pertinent experiment where we could actually measure angles and eye levels.
Right. I have a pretty good diagram that I always use to explain this to flat earthers, right? If you look in the chat, this is like a perspective hallway. And that red line, and if you can see that, and that red line is the eye level. Right? So nothing that is below that eye level is ever going to come up above eye level.
Which chat?
It's omnipresence text chat.
Oh, this is what people post.
Yeah. And Echoplex just posted something which is pretty similar also.
Yeah, but I think this is a strange example because it's not showing the same object at different distances, which I think would be worthwhile.
Well, the thing about it is that they're all the same height, right? All the objects are the same height, and as they move away, they will never go above eye level.
Well, again, it's
and this is what we would expect.
I feel like I feel like this is only telling like half of a story, as opposed to when you have like a side profile and you can just you can just ray trace from your eyes to the thing that you're looking at.
Well, yeah, I have this in 3D
and you can
also.
see a couple of additions. I think that would give it a lot.
Right. I have. You know what? I probably will do that. I'll do that because I have this since someone made this for me. Well, made a similar thing like this in Blender, where it's actually in 3D. So I can go to the side and see that it's actually a long hallway. And this is exactly what we would expect. I'm sorry. Go ahead. Someone said something?
No, what I was saying is that he doesn't know the concepts that govern these things. He's having the summarized version that he's debating. He doesn't know the technical intricacies. He doesn't know the scaffolding. He doesn't know the architecture, the layer. He doesn't know it at all. Flat earthers are arrogant, conceited people who think they know everything. You know what I'm saying?
Right.
That is the problem with them. You know those know-it-alls. You know those know-it-alls. Like know-it-alls will walk into a conversation and just say, "Oh yeah," they have no idea. They're using their discernment, right? They think they can apply discernment to everything, so they're like, "Oh, I'm gonna give you my opinion." That's what flat earthers are doing, dude. They are out of their league.
Right, but the thing is, you have to the thing that you have to do, right? You have to just allow them to paint themselves into that corner. You can't. I mean, you can't just kind of like bulldoze the conversation and tell them they're wrong and they're stupid. You have to allow them to try and think, and as soon as you do that, that's when they'll break down themselves. and they'll be the ones, running away and crying, and you have to allow them to paint themselves into that corner, and all you just do that by agreeing with them. Okay, okay, well, you say if what you say is true, then this is what happened. You demonstrate that. Okay, well, if things were to go above eye level, then this would happen, and I've given that to them in so many different examples.
No, I agree. I agree with you. I do that a lot. But yeah, you're right. We need to be consistent. I'm not going to call myself consistent. You know,
Look,
you
here's the thing though, Oyster.
So
You are pretty straightforward, but Jesse was saying stuff like, get out of my country, which is so tacky and
yeah,
childish. And it means he's lost. Like saying that sort of shit, he's only putting himself out as a dickhead. But to say that, I just thought, fuck, dude, you've lost it there. You don't need it. He's actually not that dumb. He's just not very wise, I think. Cheers, guys.
yeah. Jesse's just, I don't know why he's so upset.
true. Well, it goes to it's an example, or it gives you a window into their level of intelligence when they have
It
to
does.
interject that kind of vitriolic talk. That I'm just letting you know they are not smart.
Well, I think some of them, I wouldn't say that they're not smart, right? Now, I wouldn't say I wouldn't go that far and say they're not smart. There are some that are pretty low on that totem pole, though. I think they're just kind of misled, and they think what they say is the truth, and they're gonna fight. And anything that goes against that is some sort of lie or some sort of controlled opposition or something, right? Because what they're saying, they 100% think is true. Just like on our side, we know that everything we say is pretty much 100% true. But they think it's like some sort of, I don't know, some sort of lie or this deception or something. That's kind of why, like, I don't ever get into arguments about like gravity and all that stuff, about orbital mechanics. I mean, I guess you can have an argument about orbital mechanics, but like gravity and things like that, and like space time. I don't ever engage in arguments like that. You know, let's stay on the ground. Easy things that you and I can both go out and do right now that would give us more evidence that the Earth is a globe, right? We can both go out and look at the sun right now. Okay, we can both go out and take an angle to the sun. Okay, if it's a flat plane, it should be a specific angle. Oh, guess what? It's not. Okay, well, that should tell you something, right? I go to the beach. I watch the sun literally go down below the horizon. We can both go look at that, and you can tell me, okay, well, which direction does it go after it goes below the horizon? And they kind of they'll say things like, oh, well, it just goes away. And then you can be like, okay, well, if it just goes away, which direction does it go after it goes away? And that kind of puts them in a position where they really don't want to answer that, because you have to agree. We can see the sun going in a specific path all day until it gets down to the horizon, and we know it's gonna go on the same path right down below your feet. Right, at midnight it's gonna be right below you, and it's gonna rise up the next day on the other side, right behind you.
Well, I've got one for you. In Melbourne, when we were about 14 or 15, this was at school. There's a pole that we knew was standing, and the teacher had marked it as north because I had the compass out. Now the funny thing is, when the midday sun came over, it wasn't directly lined up. It was a little bit ahead, and it took till about 12:26 or something, nearly 12:30, for it to line up and be true north. And the teacher asked us to explain what could cause that. Now, here's the thing. Melbourne is Eastern Standard Time, which is also Sydney and Brisbane. If you know Australia, you'll know Melbourne is actually, when you look at the map, it's in considerably. It's 7 degrees, which is actually half an hour. So the local solar noon for us is half an hour ahead because we use Sydney and Brisbane Standard Time. So really, we should be half an hour out to get proper solar noon, and Adelaide should be an hour, but they don't. But we were shown this by a teacher. He said, why is it wrong? He made us work out where the fault was. Because, yeah, local 12 o'clock is 11, is not directly overhead here. And he made us fix it. And I was fucking kind of rapt about that. Because we found a fault, we fixed it. What do you think, guys? That's cool when you get that experience.
Yeah, that is pretty cool. I'm trying to get Apocryphon over here. That'd be an interesting conversation.
Apocryphon. Oh, dear.
Yeah, he's over in Earth Awakenings.
Is Jez Conda there? That'll be interesting. Him and Jez Conda.
Mhm. Dan, did we kill the conversation?
I'm just trying to do a ray tracing diagram. And you can tell me how badly I'm doing, if I can even screen share.
Are you doing it in CAD or are you doing it in Blender?
I'm using some shitty free software.
Well, you could you see what I was trying to explain, right? With the perspective hallway.
Yeah, and so here I'm trying to do like the ray tracing, and so we've got like the two positions for the person on this left side of this mirror. And then we have the reflection, and then here, I don't know if I can make this like dashed or something. This would be the eye level.
So do they think that the horizon actually comes up to your eye level? Is that what their conflated point is?
Well, I think the issue is that they just want to be able to look at other stuff and then not justify any specific observation.
Well, you realize that when you draw perspective lines out, let's say if you have a reference on the ground, like let's I use several runways, right? You take those runways, you draw perspective lines from them. They never converge at the horizon. They always converge above the horizon.
Well,
And
I'm
we know
more
those
thinking
lines are parallel. Go ahead.
right. If it's a railway line, if you're standing on the railway line that's straight and you look out to the horizon, as you look down at the railway line, yeah, they will get the higher you get. The further away they get, the higher they are. But it doesn't come up to eye level, though, does it? That's what they get wrong. It goes up to near eye level, but depends on your elevation, doesn't it?
Right.
Well, it's like this angle, like if you look at the person that's further from the mirror, yeah, the angle here is smaller from eye level compared to if they're closer to the mirror.
Yeah, well,
right? But it's like at no point will this be zero, this angle,
right?
Even if they're
Yeah.
hundreds of thousands of miles away, right? But they're saying it rises to eye level, and this rising to that they're describing as you look at your feet and you look forward, I guess you look up eventually, but it's like where your eyes are looking isn't really going to give us meaningful description of like optical effects, I don't think.
Right. The angle's never going to go positive. It's always going to be the same. You're always going to be if something is at your exact height, let's say 10 feet. No matter how far away you go, it's still going to be 10 feet, and you're still going to be looking pretty much level. Now, the cool thing is we have examples of things that are like things that are known to be well above our eye level, right? But we have to look slightly down. Let's say mountains or buildings, things that are at eye level that literally drop below eye level.
I think I know what the confusion is. I'm sorry, go ahead.
Oh, hey, is that Extra J? I know that voice. How are you? No, you go, man.
Yeah. So I think what the confusion is when they always talk about how, like, oh, the surface rises to eye level. I mean, I think what they don't realize is that the vertical height between a straight eye level, a level line of sight, that vertical height between the surface and that line of sight, that also diminishes in angular size as distance increases. Hence, the surface appears to rise towards eye level.
Wait, say that again?
The vertical distance between the surface and your straight line of sight, that distance also decreases in angular size the farther away it is. And the curvature is not, extreme enough. So the farther away the surface gets, you still have that vertical distance between the surface and your level line of sight. Well, that vertical distance, due to perspective, also decreases in angular size. Hence, the surface appears to rise towards eye level.
Yeah, you need a smaller arc length since the radius is bigger. If your eye is the focal point, and that's the radius.
See if I can't get APOC over here.
The bottom line is flat earth is a direct line to poor education. Poorly educated people. That's what it is.
No, man, it's gullibility, man. It's not. I guess in some cases you could say that, but I think it's more along the lines of being gullible.
I don't know. A little bit of that. I think Neil deGrasse Tyson, he said it. He says it's based in poor education and freedom of speech. Those are the two things give rise to these delusional thoughts. That's what he said. Yeah.
Right.
I think we need better social programs. I think people want to feel like they belong.
Because I mean, sometimes I don't understand how you could look at some of these examples that we provide, and you can't simply just look at them and be like, oh, you know what? Yeah, that kind of does make sense. If I'm at the equator and I'm looking at the sun and it's going straight down on the horizon, I should ask, if I'm a flat earther, I should ask myself, okay, how does it? If we say that the sun and everything goes east to west, okay, well, how does it get back to the east? Why in the southern hemisphere does the sky rotate a different way? You can watch a sunset in Australia and it sets going like it has an angle going from like north to south as it sets.
Yeah, when it's morning here, why is it bedtime somewhere else?
Man, we need Gary Wybanga to show up again. When you start talking about the hemisphere and the sunrise and sunset directions, that is so much fun.
Yeah, I'm sure the TFE took out a lot of flat earthers. They ran away. Gary's one of them. Brian's another. Brian
Which
Brian
one?
Leakey.
Oh,
Damn you, Will Duffy! You took away our chew toys.
I mean, also there's probably a ton of flat earthers that were Jeranism fans that are not flat earthers anymore.
Exactly. Because the bet was in. It was, hey, there's no 24-hour sun there. It's impossible. You know how many flat earthers told me that?
Oh, all of them.
Oh, I've heard a lot. Yeah.
All of them. Even Gio's like, oh no, I never said that. I never said there was no 24-hour sun.
Well, didn't Dubay have it in his proofs that the 24-hour sun would disprove
He
the
sure
flat
did.
Earth? Yeah, he said that in 200 proofs. Or shall we say 199 proofs because of that one.
They could probably say more like 20 proofs since he does like 10 or 13 of them. They're all the same thing.
Okay,
Right.
well, we could say 0 proofs because none of them are actually proofs.
Yeah,
Yeah.
technically, yeah, you're right there too.
Yeah, it eroded from 200 to 0 in about 30 seconds. Yeah, okay.
Yeah, on Geo's deal about the Antarctic sun, he got a real strong heads up before it actually happened. You know, everybody was wishy-washy, is it or isn't it?
Right.
They were told it's there, they're gonna see it. You better get ready for it and try to figure something out rather than because it's gonna happen and they're gonna see
I
it.
did that. I said
But
that.
left lane. I was telling them that years ago.
Yes, I
Years
did it.
ago. I still have that conversation. But they were saying, "Oh no, it's just the sunlight. It's not the 24-hour sun. It's just 24 hours of sunlight, not the actual sun." Remember that?
Oh yeah,
Yeah,
that
you
was
know,
the
I
coffee
told
cup
them that
concept.
too. Yeah, no, I told them that too. The first time I got introduced to flat Earth with my naive self, I was like, they were like, "Hey, give me some evidence of the globe," and I'm like, "Well, you know, I can tell you about some observations, and you know, one of them is the 24-hour sun at the Arctic," and they're like, "Oh, that's on our map too." I'm like, "Oh, that map." I'm like, "Well, it's also at the South Antarctica," and they're like, "No, absolutely not." I'm like, "What are you talking about?" I was shocked. I was very naive. I was shocked why they were saying no. And
Oh,
you know,
because they were saying the coffee cup caustic. That's why.
Ah, that was good, wasn't it? I like that. That actually showed a bit of effort. That had a little bit of thinkiness about it.
Yeah, where the sun would have to be like a big triangle in the sky.
I was like, "Guys,
Or that was
it's
just
there." I was pleading with them. I'm like, "Guys, it's there. It's in the South. I'm telling you. Here are some videos," and they're like, "No, that's fake." I'm like, "What? What are you talking?" So you know, when the FE came up, I was like, "Okay, here we go. Here we go. I guarantee you, they are going to see the 24-hour sun.
Yep.
I guarantee. I even put money on the line. I was on Clubhouse. They came into the room on Monday, and I said, "Guys, who wants to take a bet with me? I will put money on the line. I'll give you every dime I have. This is how certain I am." And they're like, "No, we're not going to take that. It's just not there." I'm like,
Yeah.
"Okay."
Yeah, they weren't going to take that because I think deep down, a lot of flat earthers knew we were going to see it. They knew because we had been giving them evidence for years. I had found a channel that would post like videos of it for a few years. But the problem with those videos was that it wasn't actually tracking the sun. It was just the camera was focused in a specific direction, and you would just see the sun go around. It would go behind the camera, and it would come back around
Right,
again. Yeah.
right.
It's just sunlight. It's not the actual sun. Okay, well, all right, you can say that, but I don't know what else would be in the sky lighting up the ground, something other than the sun.
It's just funny
And
that
then,
you can measure the zenith angles and then just like drive 20 miles and then just get another data point. And then you could just do 5 or 6 of those. And then, yeah, there you go. There's the shape of a globe a little bit.
yeah, those would have to be really small angles though. That would kind of be tough to measure.
It's like if you've got the doodad, whatever that ancient, what do they call it?
Oh,
The
the
protractor
Eratosthenes.
looking thing.
Eratosthenes.
A sextant will do it.
Sextant. Yeah. Just get a sextant and then it should do the trick.
Yeah, that's a pretty big. I mean, 20 miles gives you almost the size of the sun or the moon in diameter and angular. So that's pretty big. I mean, that's hardly not visible.
So north south, I think will give you quite some definitive stuff, and then the east west, you'll have to do a little bit of timing shenanigans. Maybe get a watch.
Yeah,
Or
one of
what
the
you could
biggest
do-
problems is just that the sky moves while you're moving, right? So you need to have two people in places at the same time or something.
Right.
I think
Or what you could
I think you with a watch should be enough.
Or what you could do is you could wait for it to be like noon in California, and have everyone else in the United States get an angle to the sun. Everyone, right? Everyone will go out like at the same exact time. And if it's flat, everyone would get the same exact height of the sun.
Yeah, because your compass pointing north. Look
Well, the
at the
flat
sky.
people wouldn't say that you get the same because it's local, right? What you should get is a certain kind of a thing. What you see then, I mean, the nice thing on the globe is that when you take, if you get everybody to get the azimuth and angle of the sun at any given time, and then you figure out what that is, everybody is looking in exactly the same direction, right?
Right.
It translates to different things, but if you put all those vectors, they're all pointing in exactly the same direction.
Right. And over a flat plane, you'd be able to predict that angle, and then the angle would be the height of that triangle, right? Because it'd be a right triangle since the sun is above California. It'd be a right triangle. So over a flat plane, you'd be able to.
Are you doing north south or east to west right now?
No, east to west. So everyone in the United States, right, would measure an angle to the sun at the same exact time when it's noon in California, right? If it's a flat plane, that would make a right angle triangle because the sun will be above California, down to the ground in California, and then the base would be a distance to somebody in, I don't know, New York or Kansas.
Oh, I think you should just measure like how far you are from north on your compass, and that should be sufficient.
Well, the point is if you do that, if you just figure out how far you are from the point that's overhead, it's a right triangle for everybody, but it's a different right. It's a right triangle that has a different height for everybody gets a different height for their triangle. That's the problem.
Exactly. And if it's flat Earth, everyone should get the same exact height. That's the test. Because you know how they'll say, oh, it's 3,000 miles, 5,000 miles, whatever. Okay, well, it should be the same everywhere. Unless the sun somehow changes height for everybody on Earth. Which,
Dude, 3,000 miles is wild to me. People think the thing is 3,000 miles away.
You know why they get that? Yeah, I mean, 4,000 is really maybe in some ways better, but 3,000 is really a good number for flat earthers. Because if you do the triangulation thing from two places that are very close with the sun, basically, you do the Eratosthenes experiment on a flat Earth, you get that the height of the sun is the radius of the Earth. That's just a geometrical fact. And so if you do it from places that are further apart than Eratosthenes, you get a little less than 4,000. 3,000 is just a good number.
Method good? Those two poles that were kind of not too far away from each other.
Yeah.
When you do that, you get if you just work that out geometrically, you're going to get a height. If you assume the sun is local, you're going to find that its height is the radius of the Earth.
Correct.
And so 3,000 miles is kind of the sweet spot, right? You can other places. It's never going to be more than 4,000. It's generally less. 3,000 is kind of the sweet spot because it gets kind of right for a lot of distances.
Right.
Yeah. Well, I gotta go for a bike ride. It's hot and the river's calling my name. So.
Yep. Take it easy. They also like to say that Eratosthenes would work on flat Earth for some reason.
Well, it's just that they say the sun could be local. I mean, the one thing they don't really, I think a lot of people don't know, is the Greeks knew for sure that the sun was really far away. They knew with the distance to the moon, and they knew that the sun was enormously further away than that. So local sun simply wasn't an option.
If you look at the Carl Sagan one on the Eratosthenes, he does it in such a way that he shows you the two upright poles and then says, up until here, it would work on a flat Earth or something like that, and they chop it off there. But then he goes on to explain why a third point will guarantee it's curved. But the flat earthers always edit that section out in order to keep it their way. So they kind of doctored the evidence just a little bit.
So I'm trying to get Apocryphon over here, but it seems like he's writing a novel over in in Earth Awakenings because he's been typing for a long time. So I think it's writing a novel. He won't. I told him to check his DM. I sent him a link, but he's probably not going to come because he's writing a novel.
Hey, if you want an interesting little tidbit back in the Aristophanes days, one of his offsiders, who was over in Africa, actually noticed that the African elephants were migrating in a westerly direction. And of course, about 6 months later, someone was over in India and noticed the Indian elephants were migrating in the easterly direction. And they put together that, hey, the elephants are going around the world and going to some big elephant party and having a rave. So, and of course, not true. But it just happened to be the timing that this one guy was in India at one point and in Africa at the other, that he put two and two together and came up with, well, the shape of the earth was right, but the evidence he used was totally, yeah, the elephants weren't having a party. But isn't that cool? Like, that sort of strange stuff they observed. I think I got that off Gem Panda. I can't remember my exact source.
Oh, Gemsy.
He gets his morning cardio yelling at flat earthers.
People who still goes over there? What flat earthers are in there?
I got no idea. That'd be Pete O'Shea, I'm guessing.
Oh, Pete Shea, of course. But is he still a flat earther though?
He's a whatever. He's just whatever's not right. So yeah, I don't know.
Yeah, I don't see any flat earthers over there.
It's like it builds up, and then every so often a few of them all hate each other, and then they'll go off and start different servers elsewhere. Then it just builds up again until a few more hate each other, and it does that. Oh, it's an amazing server, that one. It just keeps, it won't stop.
No. Well, I don't know. Where are all the flat earthers at? None of them are in none of them are in Earth Awakenings right now. It's like dead.
Anyone got caught today?
Where are all the flat earthers? What's going on? Have we finally won?
Oh no.
Drunk debunk.
I just want to kind of reiterate that, like, you're putting a lot of credence with this whole rising to eye level thing, right? Because the vantage point, like in the example, who was posting it? Was it you, Earth's Life, that was posting that image?
Yeah.
With the things that are like, hey, these are all the same height, right?
Right.
And then no matter how close or far you're going there, it's always at that same height. I think if you also record the bottom view of those things, you'll notice that they're also the same height, right? So it's like when you use that mirror example, you're like, hey, when I look at this mirror and I see where my focal points are for the top of my head and the bottom, it's 3 inches. And so no matter how far away I'm going, I'm still 3 inches tall.
Correct.
Which is, which I think is, which makes the term rising to eye level for me, I don't know, I don't want to say vapid in nature, but incoherent, let's say, as a term for something that is meaningful to say, especially when you're trying to like determine a specific viewpoint. When it's like, if you're just talking about rising to eye level, yeah, sometimes we look at eye level, cool. Sometimes we look at our feet and then we look forward. And it takes,
here's a good example.
It takes time for our eyes to rise.
If you're sitting on one of those little rail handcars, you know, the railway thing that you pumps like a bike, you're probably 3 feet off the ground. So nothing above the ground level will rise up to it, but the signals will, won't they? Because they're above eye level to start with. So they'll always be it, but the rail will always be relative to you, won't it? Like the rails will never be above your eye level, but the signals and the bridges over the top and the electric wires, I guess, everything like that, anything that's inherently above eye level will eventually appear at or above eye level.
Well, they
But even
start
they
above
start
eye
from below,
level.
don't they? They start below, though. Yeah, so there you go.
No, they don't start below. That's the whole point.
Well, no, but I say a signal gantry, 10 miles away or whatever you can see, does that start below? That would start below, wouldn't it?
No, it would start above.
Where the rails virtually converged? Oh, okay.
I can't post screenshots of my image, but
Hold
Yeah,
on.
that's
but you
the
know
whole
what I
point.
mean,
If you
though.
look at
I'll
the
give
top of
you-
your head, right, and you look at a mirror, doesn't matter how far you go away, the angle is still going to be above eye level at all
Wait,
times.
type something in the chat and I'll give you posting perms. That way
Um,
you can post a screenshot.
the last post is mine, and the
Wait, you're
wait a
not
minute,
in
not the text chat
Omnipresent.
here. I'll put in the boop.
There we go. There you
Did I
go. Now you
save
got
that
image
thing?
perms.
Shoot,
You got
do I have
image
to
perms.
redraw the whole thing? Please no.
And you're talking about the thing you were
I was
you were sharing
doodling.
earlier.
Yeah.
Yeah, I could see why that might like something like that might be a little confusing for a flat earther to understand because they don't,
I think I think if somebody has like a phone and a bathroom mirror, it's so easy to replicate. You're like, here's me. Here's a couple of magnets. Here's the top and bottom of my head. Here's me going back and forth. Wow, look.
So I gave you image perms that you can post it, take a screenshot and post
Yeah,
it.
I think I lost it. I'll have to draw it again.
Oh,
But thank you, appreciate it.
like here I made
Okay,
these.
I'll draw more doodles in the future.
Here's the flat one, and then here's a curved one. Like I was asking our old friend Horizontal isn't sloped in the chat, like because he likes to say, "Oh, things get smaller with distance." I'm like, okay. Well, if you look at that thing that says flat, that blue line in the distance is taller than all the other lines, but it's visibly smaller. But we know it's taller because it goes all the way to the ceiling. And in the curved one, it's obviously below eye level now. So now it's definitely lower than the rest of them, which is what we would expect on a curved surface. I need to get a higher.
I just think measuring the feet is a game changer. Right, because they're so focused on this, like he was describing the vantage point, things going up to the vantage point. And then when you have the boundaries already identified, right, the vantage point for the top and the vantage point for the bottom, there is no coming up to eye level anymore problem.
Right, here's another example. So I remember I was talking about the runways. I took a picture of this runway in Hawaii. And if you take those perspective lines out to the horizon, they always converge above the horizon. I have a few other examples of this. I'd have to find them.
How is Hawaii? I used to live in the Big Island when I was younger.
Tony V, what's up, Tony V?
What's up, man?
I missed you.
So
You've
you
been
still
gone
doing?
for a while.
Yeah. Well, I do what I do.
Yep. Yeah, I know that you kind of had a situation last time, but yeah, I'm still here, still kicking
I
around.
played a show at a
Cool.
place called Tony V's.
What's up?
Yeah, I forget who made that for me. Someone in Jem's room made that avatar thing for me.
Oh yeah.
Yeah, it's like a dive bar. in this state.
That must be it then. I don't know. All I know is I've had it for a few years.
They do some pretty good shows. It's close. Let me see if I could find the front door. It's a little uncanny.
It must have been from that. I don't know. Like, yeah. He's like, here,
I
man.
guess it looks a little different.
I did. But I don't if you guys talking and stuff. But,
I guess
yeah. Because you guys were getting.
I'll use my image rights to post irrelevant content. Sorry.
No, it's fine.
It's all good.
As long as it's not
That's
memes.
what it looks like. The menu's like.
Here
I think
are-
I think they redid it. Because it used to have that 50s diners look a lot closer to what you got.
Yeah, I don't know where he got that from. He didn't tell me. He just so it probably means something crazy, and I don't even know it.
Yeah, the stage looks really
Like
cool
the
too.
five little like things at the bottom probably mean something. Like I'm part of the Illuminati or some shit.
Here's a good one.
Where are you guys putting stuff in? Because I'm like at OmniText or which one?
Omnipresence text chat. Oh yeah, that's a good one. What is that vehicle?
It's a boat.
That's wild.
So this is from a guy there. I always forget his name. Bobby Shafto. So
is
he
that like
filmed
a
this
tornado
boat-
thing, or is that like a freaking minesweeper?
I'm sorry?
I can't tell if that's like a military minesweeper or just like a
No, it's
NOAA
just a
vehicle for going into hurricanes.
No, I think it's just a boat. Just going away from from the guy who was filming it. I think there's a video actually from I forget what his Bobby Shafto. He's got a YouTube channel.
If you look at the stage in the back, they got this like front of this like old, I can't tell what it is, like an old ass Camaro or Chevy or something like that. Just
yeah,
like
the bumper?
mounted in the back.
The front bumper? Yeah, I see that. That's cool.
It's a cool venue.
Those lasers are cool. I mean, you actually have like, they look like they have sharp angles to it. That's pretty cool.
Yo, did you guys
Yeah,
see?
I worked
there's
at a
there's
recording
video-
studio a few blocks away.
There's a video where a guy is dancing, and there's like laser beams around him, and he does this thing where he looks like he's literally grabbing the laser and like doing like
yeah. He's doing
you
like a
see that?
sword fight with it. He's doing a sword.
Yeah.
He's fighting another guy, and he has like the lasers are like swords. Yeah.
Yes, and the lasers are like they're on the ceiling, like doing for the light show. But then he grabs it because I guess he has like a laser pointer in his hand, but it makes it look like he's actually grabbing the laser and doing. Yeah, that shit's cool as hell.
Yeah, it's pretty cool. Yeah, it's opening up like a satanic portal. Actually, no. I've been watching these Egyptian like what's really going on there. They just found like these shafts going underneath there. I'm digging in, man. I'm in it. I like it. I am down with this whole like. We might have been around here for a long time before they said we have been.
Maybe.
Still doesn't make the Earth flat though.
Yep. Unfortunately, there are people that are still clinging to it.
One thing is like the main argument right now in flat Earth is just the whole perception. They're like just the distance and the way things disappear in distance, and that's just the only thing that seems like they have of any substance. Everything else we have like 20 other things.
Yeah, but the thing is like the argument hasn't really changed. There's certain things they don't talk about much until we actually bring it up, right? Like flight, like flights in the southern hemisphere. They don't talk about that. They don't never bring it up. They only want to talk about like stuff at the horizon. Like
Yeah, someone
refraction.
last night was talking about Rayleigh's criteria and making it sound like flat Earth is the one that came up with it. And anyone who knows that Rumpus brought it up first at that Isle of Man debate at Oakley's debate channel. It was like his 100th episode. That's when he came up with it. And everyone's like, "What the fuck?" Trying to argue it. But now, like, they're trying to hijack it. Like they came up with it. Oh, it's really funny.
I remember old Rumpus. I wonder how he's doing.
Yeah, I don't know. He's probably still trying to do that one experiment he said he was going to do. I don't know.
No, man, he's been gone for like a long time, just like Lemon Bird.
Oh shit! Hopefully he's okay.
I don't know, man. I haven't heard him for a long time.
You know why Rumpus left?
Why?
Because he knew the so-called experiment that he wanted to do. He knew he couldn't do it. He knew he was not gonna find drop, so he disappeared. He was promising it for 3 years, by the way. 3 years.
Yeah. But his shit was so complicated. It was so convoluted and so complicated. There's no way he would have actually been able to do it to where he'd have to have people. He was asking for flat earthers to help him, but no one came and helped him. They're like, "Hey, for me to do this, I need some flat earthers to come help me," and that never happened.
No, hold on, that's false information because there were people offering. No, negative.
No, that's not true, man. The only person that helped him was Farmer's Boy, and I think
I know, but he was asking for it.
When I actually went out there, I think Bev and them were there.
That's right. They offered to help, and they kind of saw that as a hostile act. That was really funny.
Oh, so is Rumpus really just a dickhead? I can see that.
I wouldn't call him a dickhead, but
it's an English thing. It's an American thing. I'll call him a dickhead then.
Call him whatever you want, but he just chickened out. He knew he made false promises. And he knew that he couldn't do it, so he skipped. He's gone.
I don't think that's true. I think it's just. I think something else happened to him in his life. That's why
nothing happened to him, bro. Come on.
Because he's not going to back off from that shit. Know that. He's pretty much the one. He's the grandfather of you guys in this distance in Rayleigh's criteria. You guys wouldn't have had that unless it was for him. Like seeing your ass and all that stuff. Like you guys use that now. You guys use that as evidence for flat Earth, and he gave that to you guys.
Well, he gave us a lot of laughs and a lot of dumb shit, also. So
of course he did.
Played his role, but yeah, we had a lot of good laughs with him.
Yeah, that was fun back then.
Yeah, but I mean, something like that, it takes a lot of a group of people to do it. He only had one other person, and I think he actually got hurt. Or was it Farmer's Boy that got hurt when they went out there?
Nobody got hurt, man. He had all the people. He got the ministers.
Farmer's Boy fell or something, and I think he got hurt or something like that.
He just chickened out. He knew that he wasn't going to find drop. He was looking for drop, by the way. From one end to the canal to the other, he wanted, I think, a 6-foot drop he was looking for.
Yeah, but I mean, we all know that there's other examples of this drop.
Yeah, Soundly did it. Soundly did it. And he had something to do with Soundly's experiment, and that Soundly's experiment had the whole internet. Everyone that was on it, everyone that was interested in it, at least, because you could control his camera. That's what's cool about Soundly's experiment, because you could control his camera. You pay $10, you can control his camera and move it around, and you can see that. That's when he got that picture of the hump there at Pontchartrain.
The hump, yeah, that was another fart. I'm so glad you said that.
That was real.
That's right.
Did they have that hung up at Pontchartrain, the Pontchartrain, whatever? Good.
Yeah, the hump, bro. Yeah, he brought up the hump, and I bring up the hump all the time, man. It seems to have fooled a lot of people. Even some flat earthers were telling me, "See, you're straw manning the argument." But no. In their model, they have a hump in the middle. So thank you for bringing that up. Yeah, it was a fart.
Obviously, there's Apex.
It was a comedy, I'm still laughing at that.
Well,
there's Apex. There's going to be Apex in anything you see. If you see something in the distance, there's going to be an Apex where it rose, and then there's Apex. So if something's 10 miles away, it's 5 miles up to the tip and then 5 miles down to the object.
Well, the argument is that there shouldn't be a hump at all. There shouldn't be anything. It should just be straight.
That is correct.
flat.
There's
If
no
it's flat,
such
it shouldn't
thing.
be, but there is.
Yep. See, B-ball finally got it.
Yeah,
there shouldn't
your
be a
guys'
hump at all.
argument is
So your famous picture then, B-ball, in Hawaii, what's blocking the view of the buildings there? How many?
It's the
15
water.
stories, I believe you said?
Yeah, it's the water, man. So I've been trying to say for
it's-
years, but
it's the
nobody
water.
wants to believe me. Everyone
it's
wants to say
apex.
something else. It's something else. It's not the water. It's
You just said
refraction.
the water was flat, no, and level? Didn't you just say
No,
that?
I said it's not supposed to. There's not supposed to be a hump or quote
There's not
unquote.
supposed. So then, if there's not supposed to be a hump, then how come the water is blocking 15 stories? How does that work out?
It's because there is a hump.
You guys heard it. It's
There is
because there
Because
is a hump.
there is a
Thank you.
drop.
Look, the flat earthers are listening to this, right? Who kept saying I'm straw manning their model. I hope you're tuned in and you guys are listening to this.
Yeah. We can see it. We can see the drop. So I mean, yeah, it shouldn't be there if the Earth is flat.
I hope Extremistis is listening to this. And all the boys, the flat earthers that told me once I was straw manning their model. Oops. Looks like you were wrong.
I don't know. There's probably not many people listening, but yeah. I mean, if it's flat, then that hump or drop you want to claim is not. It shouldn't be there, but we see it.
No, I had the top flat earthers at one point telling me that I'm straw manning the model. Who was it? Witsit? Who else?
I don't know.
Some,
You guys-
yeah.
I don't think
Crazy.
Richard can steel man any model.
I love it. Like he was like your guys' god at one point. Like seriously, like if you interrupted him, you guys would get pissed off. Even you, SE, like all you guys, like he was like the man. Then all of a sudden, whoop! But you guys have done that with all the people that have.
Nobody was ever the man for me, though. Speak for yourself.
Oh, he was.
I remember the conversation.
Witsit was the
You
man.
had it.
Absolutely, man.
I was arguing against them. So nobody was ever the man for me. Let's get that clear.
Okay.
Oh, I would love to
He's always
see a
so happy
video
to
of you
say, "I
arguing
don't
against
do
him. I
math."
bet you $100 you can't find a video of you and him in the same room and you arguing against him.
Well, yeah, ask him next time Extremistis comes in. He clipped that video.
Dude, I
Ask
can
him
can vouch for that.
show you that clip. Yeah,
If
where
you
I was
arguing all the
arguing with,
time.
Wait, hold on.
with
Someone else.
Witsit and a few other flat earthers about the hump and the drop.
Hold on. Rex is trying to say something. Go ahead, Rex.
Oh yeah, no. I was just saying, man. Up in Earth Awakenings, they would argue all the time.
That's
I don't
right.
doubt that. I don't doubt that.
Yeah, no.
They were telling me that I'm making flat Earth look bad by that argument, and I'm telling them, look, man, I don't give a shit what you guys say. First of all, I don't identify as a flat earther. Number one, and number two, I make my own arguments, right?
I know
And
most
they were
flat
telling
earthers
me
say that.
they were telling me that I'm straw manning your model, and I'm telling them, no, man, that's their model. Their model. There's humps and there's drops.
Yeah, but I think when you say that, you're trying to either say that there's two different things, which is pretty much the same thing. Well, so a hump would characterize that as like a bump or like a hill, right? And a drop would be like over a curve, which we would see, gradually on the surface of the Earth.
Yeah, it would be like if there's something 10 miles away, there's an apex, there's a hump, and at that 5th mile mark, everything from that point on is the down.
Right, like a
Right.
change in elevation would be like a hump. Change in elevation would be like a hump.
See, this is the beauty of it. After all these years, right? Some people still don't get it, right? It's so easy, It's so easy to understand. There is no hump and there is no freaking drop. Capiche?
There is.
no hump.
There is.
no
Obviously,
drop.
there is. I mean, didn't B-Ball just give you a video that like that boat going on the distance? There's water starting to get in the way there. That's the hump. Call it whatever you want. I don't care what you call it. It's just there's an apex. There's a gradual up and then down.
Right. That's it. They just keep talking about it. I love it. This is beautiful. This is where it's
Do you
at.
think like it's just going to be like
This is
straight
where
down?
it's
Like
at,
there's
the
not going to
model.
be any like? Do we think that it's okay? So if it's going down, it's just going to be straight. There's not going to be nothing in the way. It's just. But then how would you have that angle down? No. If something's in the distance, there's going to be a hump in the way, or they fucking rise and then fall. They're apex, rise, apex, then fall.
Well, look, let me ask you this, and I asked this to a Montreal surveyor just a few days ago. Let's say you have a canal, right? You have a 5-mile long canal. The doors are closed on either side. It's still, completely still. And you're on one side, you have a little dinghy boat on one side, and there's another person on the other side at the ends, the two doors, right? How does the water appear between you?
Well, didn't Soundly do the same thing? Like, yeah, he had put all the lights down on it. Like he put all the lights, and you could see there was a arc.
There was an
So
arc,
I'd
your
say
hump,
that
right?
there's an arc.
Your hump.
Yeah.
So in
My
other
hump.
words, let's go on.
Just my hump because I don't have a better word for it, so I'm calling it a hump. Other people are like it's not a hump, it's whatever. It's a rise, apex, then a fall.
Well, there's a new word I found out. Blue came up with cap, I believe, like a cap, like a like the Hamulka or the Pope's cap. There's a new term apparently.
I didn't know that. Yeah, cap. That doesn't make sense to me. I guess I don't know. Unless there's like one of those like in the dictionary, where you have like 27 different definitions, and it's like the last one.
So there's the picture in the chat, SC, if you want to take a look at it. The boat's
Right,
coming.
that would be the drop. What
Yes,
would you
that's
call that?
dropping. Yeah, that's dropping.
That's the drop. So there you go. See, not straw manning the model. Hope everyone's listening.
But that shouldn't happen if it's flat. That shouldn't happen.
Ships going over the over the curve is not strawmanning the model. I don't understand.
Well, some flat earthers were telling me like there's no curve, there's no. I'm straw manning the model.
Yeah, I got that, but I mean, what do you think the ship disappearing over the curve means?
What I think it means, it's a visual effect. It ain't disappearing.
No, I mean, I understand you can think that it's due to perspective or something, but what do you think that the globe people mean when they say that's happening?
What I think they mean, yeah, that the boat is going gradually over the curved surface
So
of
you
your
can
globe.
consider that a hump, but it's the same elevation as in the globe model. It's the same elevation at each point, assuming the water's still. So,
All right,
Yeah.
But like,
so
okay,
okay,
I get that, Omni. But when I ask the question, then let's say the canal, right? It would be the same thing in the canal, right?
yes.
So according to your model, call it a hump, call it whatever you want, right? Well, let me ask you the question first, though. If you were in that canal, 5-mile long, and you were each on the boat, one is on one side of the dock, one is on the other, both doors closed, calm, and you were to go like on your knees, both of you on your knees or on your stomach of the boat and look at each other, would you be able to see each other according to your model?
No.
No. And the reason for that is?
Under normal refractive conditions, no.
And the reason for that is?
Because 5 miles under normal refractive conditions, your view would be blocked by the curvature of the Earth.
How high
By
are
the
the
water.
two observers?
The water, correct?
Apparently they're at close to water level, is what I'm getting.
Oh, yeah. Okay.
So your answer would be the water is blocking the view.
Yes.
Okay, there you go.
So you could consider that a hump. You could describe it as a hump, but remember, in the globe model, it is the same elevation all the way along that 5-mile canal.
Oh, I understand that. Yeah. But nevertheless, in the model, if there's two boats that far apart, they are lower in respect to that hump, no? because you're on the purge
no,
surface, obviously,
not
right?
really. No, they're not lower in
You
respect
see,
to the
that's where the problem comes in. Yeah.
So let me explain. Let me explain why. Remember, I said note that they're at the same elevation.
Right.
Okay.
They are at the same elevation. I give
Yes.
you that. As respect to, let's say, what mean sea level.
So if I have a circle, right, and I have a little person icon on one point of the circle at around 9 o'clock, and I have another little person on the circle at 3 o'clock, right? You follow what I'm saying? Like a clock face.
Yeah.
So
You're both on the same elevation.
From looking at it from the side and saying, well, with respect to the circle, these guys are not lower than each other. They're both at the same level, but they are unable to see over the curve of the circle.
Right, because there's a hump of water in between them.
Well, it's because there's a curve of the circle between them. So if you put a guy on top of that circle, so one's at 9, one's at 12, and one's at 3. Both of them can theoretically see the guy at 12.
Right.
Okay.
But not each other.
But they won't see the guy at the other other point. So
correct.
That is the globe model. Now, the way that you describe it as a hump is fine. I don't think it's disingenuous for you to say that. But I want to note that a hill is not the same thing.
Right. The reason I say that is to reduce the argument to ad absurdum, right?
Yeah. Well, that is.
My next question would be, if you were to look at it from the side view, right? Now we got a guy on the 12, we got a guy on 3 and 9, right? If we were to go to the side, what would we see? How would we see the water from a side view?
So you wouldn't. So that's what Dimmock constantly says. I think that's what he's talking about. He doesn't really explain it, but so first off, it's not a circle, right? In three-dimensional spatial coordinates, it is a sphere. Yeah, it's like a ball. So standing, and also wherever you stand on a circle that's drawn on paper, the bottom of the paper is down and the top of the paper is up. But in the globe model, down is the center of the circle and up is away from the center of the circle. Okay? So what that means is if you had some universal up and down, like the North Pole is universal up and the South Pole is universal down, and somehow gravity, worked under those rules, then yeah, you would have like Australians falling off the bottom. But that's not how the globe model understands those things. So the guy who's standing from the side will see a curve, we'll see what at the sides of the earth will look like a flat plane to him that goes until the horizon, which is presumably like right at the canal. So he'll see like a slice of the center of the canal, and everything else.
Will the center be slightly higher in respect to the 9 and the 3
always
o'clock?
appear to be lower.
The center would appear to be lower from a guy looking at it from a side view?
Yes. Well, from wherever you're standing, the other person appears to be lower. If you point two auto levels at each other, 100 yards or 1,000 yards apart, and you point them right at each other, each auto level will see the other auto level as a little bit below it.
So a little bit below it. So you're talking about both drops between.
Yes.
So that's the double. Then that's the double drop hump. Oh, well, thank you for that one.
I get it.
Do you hear what you're saying, though? Do you hear what you're saying?
Yes, I do. Because I'm trying to. So, do you understand what I said about the auto levels?
Yeah.
Okay, so do you think that that's true? That if I point the auto levels at each other, I'll see I'll see each of them at below the other, even though they're both auto levels and they're both pointed at each other.
I've never done it, so I
know. You're right. I'm not saying have you done it. I haven't done that either. But it's the same thing with reciprocal zenith angles. It's not identical. It's a different test, but it's essentially the same principle.
Well, I get your reciprocal zenith angles because the way the model describes it, right? It's like a spoke of a wheel, right?
Yep.
So I renamed that single point geometry. In other words, wherever you are, that's your vertical, right?
Yes, correct.
I get how you see that. Yeah, I understand.
Yeah. So we have lots of examples of reciprocal zenith angles behaving the way that I just described. We don't.
How would you measure that, though? That's like, how would you measure the difference there?
How would I say? I'm sorry. Say again.
Let's say you have two plumb bobs, right? And they're like, I don't know, 100 feet apart, right?
Yeah.
Now, in your model, they're not the same, right?
They're not parallel.
One of them, right?
Right. That's correct.
You know, how would you go about measuring that, though?
So with plumb bobs at 100 yards, the amount that they are not parallel by is probably less than an arc second. I'd have to go do the math, but there's 3,600 arc seconds in in 1 degree, right? So if you have those things that are not parallel by just about an arc second, I don't know how you'd measure that at 100 yards. Like I'm not sure what that true, but
let's say a mile.
At a mile, the way that you measure it is with theodolites, because theodolites will absolutely, and they don't have a plumb bob, but they have a bubble level, which is doing the same thing. It's giving you plumb. So, and you could attach a plumb bob to each theodolite. They have an attachment point for it. So you can attach a plumb bob to each theodolite, so you can verify that the bubble level is the same as the plumb bob at that point, and then you can use the sensitivity of the theodolite to see how many arc seconds your arc minutes you're off, and it will be 1 degree per 60 miles. So if you're 1 mile apart, it will be as one arc minute.
Yeah, a visual thing at a mile. Yeah, that's
well.
Kind of...
So you can. I understand. I understand the position that it's just some visual effect. However, my response to that is that's not a visual effect we recognize. Like, we don't know what that visual effect is. Like, that's not a recognized visual effect.
Right. So just to get it clear for the people, right? You're and I get what you're saying, but I just want to repeat it so people could hear it, right? On your globe model, if I'm in Canada, right?
Mm-hmm.
And I have my plumb bob, right? Or I'm at the north. Say I'm at the North Pole and I have my plumb bob and I have a God's eye view of the globe, right? I'm Thanos and I zoom out. Now I'm in space, right?
Okay.
So if I see one plumb bob pointing downwards, let's say to the center, like with respect to north, right? And if someone's on the equator and has a plumb bob, I'm going to see it shooting straight out, right? Like the equator line. That's your model, correct?
I think so. Yeah. If I'm picturing it the right way, yes.
So each plumb bob is pointing to the center, even though they're like...
Yes. Even though they're at different points, like two people on directly apart, antipodal to each other, their plumb bobs will be pointing right at each other.
Antipodal. Okay, perfect. Yeah. All right. Yeah.
So I can accept that you find that view to be absurd. I don't have that's your view of it. I'm not arguing with that. But that is the model, and there's a great deal, frankly, a very great deal of evidence for this. So, the question that I would pose to somebody who thinks it's absurd is, okay, you view it as absurd, but why shouldn't I believe that evidence? Why shouldn't I, what reason would somebody who looks at the evidence for gravity and says, yeah, there's very good evidence for gravity working the way we say it works? Like, we have tons of tests, we have tons of data, we've done all sorts of things, And yeah, some of it's pretty counterintuitive, not as bad as quantum mechanics, but it's not, a lot of it seems, alien to our daily life. But what reason shouldn't I have to believe the evidence? And the general, I'm not your answer. I'm not at all trying to speak for you, but the general answer from Flat Earth is you shouldn't believe the evidence because the evidence is either fake or because the evidence is being improperly interpreted, and the way it should be interpreted is would lead to some other conclusion other than what, the conventional science interprets it. Now,
Well, yeah, there's no argument if we go by your model. That's why I named it single point geometry.
I understand.
There's
a lot of evidence for that model. That's all I'm saying.
Well, when it comes to gravity, that's a whole different ball game, right? But the way your model describes it, you're on a ball, gravity pulls to the center. So wherever you're at, your plumb bob will be like, think of it as a magnet pulling it inward, right?
Yes,
that's your model.
exactly.
It's easy to to steal, man.
Yeah. That I would describe it as a magnet. That would be probably the easiest way for somebody who's familiar with magnets to think about it.
Exactly. But now when we go into what gravity is, it's a whole different ball game, right? That's where the model starts breaking down, right? If we're talking about mass attracting mass, then we can go into the curvature and the bending of space-time. And then we go into fantasy land, right? That's where absurd. Yeah.
Yeah, I can agree that it's that you can say that, man, that's pretty fantastic sounding, or I don't buy how that sounds. However, I still would say that the evidence that we've got, even though it sounds really bizarre in the context, the way that you're looking at it, it still seems to me that the interpretation of that evidence, checks out. Like the bending of space-time checks out because we see those Einstein rings where light is being warped around supermassive objects. And because we see, the difference in atomic clocks. I get that, it's a super fine distinction. And, we're not, you can say, well, I don't think the clocks can be that precise. And that's fine. But if I think the clocks can be that precise, and I think that the test for it not only shows the change in time, but the change in time that is what the theory, the specific change in time of what the theory predicts, I see that as pretty good evidence. So I'm not, I still don't see a good reason other than that. You can say it sounds really odd to me, or it sounds really incredible to me, and that's fine. But if it doesn't sound as incredible to me, then why would I choose that there's some unknown optical effect that nobody has experienced, that nobody's ever detected? Like, how would I, why would I gravitate towards that?
Well, no, I understand how you're looking at it. You're looking at it from the standard view. They look out there, and the lensing that you're talking about, or the curvature of space-time, or that one brother ages slower. That I'm familiar with these stories, right? But
the one brother ages slow is a thought experiment. I'm talking about there's lots of actual evidence. You can look at the white papers, and if you don't believe the white papers are being fake, then in theory they did this experiment. Okay, fine. And then how did they? Why shouldn't I interpret the experiment the way they did? we don't, I don't see a good answer for that. And I'm not expecting you to come up with one in the discussion right now. I just, that's kind of like where my thinking goes is, people tell me I shouldn't accept it that way. And I don't mean you. I'm generally talking about people who are having a less reasonable conversation.
Oh, no, I get that, and I get the
personal standpoint. That's fine. I can't speak to that, but when somebody tells me I shouldn't accept it that way because it sounds so bizarre, it doesn't sound that bizarre to me. That's it.
No, I would never tell you how to look at it. I always speak for myself, like how I see it, right? Yeah.
Right.
And I can tell you about the new findings that they found, and it's not good, Omni. I mean, your model, well, I don't want to say your model, but the cosmological model is like literally falling apart.
Okay.
Yeah, like.
Okay, well, I mean, I think that's. I mean, I think that's worth discussing. Like, I think that's that's worthy of talking about. I question.
Well, as it should.
Yeah.
It should fall apart. Like we should never actually know exactly what's going on. It should always be changing.
Yeah. I mean, we would expect there to be changes in the in our understanding of cosmology. Like, yeah, I think we would expect that.
Well, yeah, but I admire you guys saying that, right? Like if we find something that changing, but this is big, guys, right? This is really huge because like your whole model depends on predictions, like you were saying, the rings and that predictions and checking them out and see what happens, right? And that solidifies or strengthens your model or weakens your model.
Yeah,
but what they're finding recently, like it's really weakening your model, like oversized, like mature galaxies.
So okay, so in order for that to weaken the model, we have a model that explains everything inside our solar system, right? I mean, it explains the orbit of Mercury. It explains the orbits of the planets. It predicts accurately the difference of an atomic clock from the bottom of Pikes Peak to the top. So it predicts a lot of things. And then in the outside of our solar system, the predictions are not accurate. But in order to replace that with something else, with a new theory, that new theory has to also get all of the predictions that relativity makes correct. And so like electrostatics doesn't do that. Right? Electrostatics won't doesn't get all of that stuff right.
Yeah, electrostatics is based on charges.
I'm just saying, it doesn't. Yeah, electrostatics isn't going to replace that in a valuable fashion, and ether isn't going to replace that in a valuable fashion. Because
but neither is quantum foam. I mean, if you want to argue ether,
well, right? Yeah, well, quantum. We don't have a theory of quantum gravity.
Exactly.
Right? So,
exactly. Yeah.
Well, but I mean, but that's all. Yeah, but that's not like people look at that and don't say, "Oh, that's the weakness of the." That's a terrible.
It's not weakness of anything.
That is the weakness of the theory of everything. Yeah, that is the main. Yeah.
No, the theory of everything is not really relevant to the subject. We don't really care. What we care about is what we have verified. What we
there
have
goes
verified.
The combo, bro. There goes the combo, Omni. It was nice talking with you, bro. We'll bring it up another time.
What we have verified is the shape of the Earth. It's a globe. That's what has been verified. 100%. Right? And so we're not going to fear. We're not going to frame quantum fields and quantum theory and quantum gravity in the shape of the Earth. We're not going to do that. You're a flat earther. You understand me? So what flat earthers are doing is conflating. They are mixing up all of these theories and hypotheses and suggestions about different things in physics in the framework of the shape of the earth to cast doubt about the shape of the earth. That's what flat earthers are doing. We're on to you. We're on to your game. We're on to your game. We know what you're doing.
Like I said, Omni was nice while it lasted. We'll keep it. We'll bring it up another time.
Okay. All right.
Yeah, I'm way too good for these.
That ain't gonna happen with our brother here.
Yeah, no, because I keep it dry, I keep it raw, I destroy flat earthers very easily. I know what you guys doing, and a lot of people like to engage with you guys inside of these intricacies and these webs. I don't. I keep you on the subject. The subject is flat Earth versus the reality of a globe. I like to keep you there, and you guys don't like it. That's why you despise.
All you did was destroy a conversation so you can monologue.
Monologue.
Just looping back to the. I pulled up the data for the flat earthers who's and their political leanings, and it looks like there's about double the chance that they're a Trump supporter compared to otherwise.
Oh, absolutely, 100%. And by the way, you whenever somebody's speaking a long time, you guys call it monologue. That's a lot of people do that. It's like a lecture when you're sitting in a class.
Well, what you did is you killed a conversation between two people, so you can only hear yourself talk.
Do you wave to the professor and say, "Professor, you're monologuing about
I'm
chapter
surprised
5."
it's allowed.
You don't do that.
That's crazy.
The reason why you say monologue
you're like the globe. You're like the globe
reason
demo.
why you say monologue is your lack of respect for me. That's simply it. I never do that.
No. The lack of respect for the conversation. No, it's your lack of respect.
Let me tell you something.
It's your lack of respect. It's your lack of respect for other people talking.
I want you to do this.
And you wanting to say what you only want to say.
I want you to do this, brother. And I'm going to say this. When John starts speaking, or Omni starts speaking, they're speaking for longer than a minute, you will shut your mouth. You know why? Because you respect them. You do not have any respect for me. Please give me a break, brother Sean.
No, the difference is if you were trying to have a conversation. If you're gonna let me talk, motherfucker.
John.
If you're trying to have, let him
let John respond.
Dude, shut the fuck up.
I'm gonna mind you. Stop talking, John.
Jesus.
Robert, go ahead.
No, you don't have no.
You're showing it right now. Jesus Christ, shut the fuck up.
Dude, I am not speaking in the way they speak. They're not.
Shut up.
I do not
Just
use.
stop talking.
I don't use the big words.
Shut the fuck up.
I don't use the big words, Sean. And
Jesus
that's why you don't have no
fucking Christ, man. You need to shut up. The reason I say you monologue is because you don't want to hear anybody talk. You don't want to hear one person talk. You just want to hear you. Two people were talking civilly, and you literally stopped it to say, shut the fuck up. Only I want to talk. That's disrespectful to the conversation. And then when I'm saying this, you wouldn't let me talk. You funny new people. Just shut the fuck up. No one wants to hear you monologue.
You hear that, Robert? Like, how many times do you gotta hear that, man, so it could go in your head, bro? How many times?
No, brother. No, something. No, Essie.
You didn't listen to it at all.
Essie, brother.
No.
I do not speak in the terminologies that these guys speak with very technical. They use what you call
ignored everything.
Words. Hold on. They use terminology that you find in the dictionary, deep in the dictionary, and you joker.
Monologue about nothing of the topic.
You people love to hear those words. I don't use those words. That is the reason
Then
why you
don't have
guys
the
don't like what I
conversation.
say. You don't like what I say.
Damn.
You know what I'm saying, dog?
No, I don't
You
like
don't
that you just don't shut the fuck up and you
Listen,
don't let
you know what
conversation happen
SC
because
just said?
you
SC
decide.
just
Who
said.
the fuck are you? This ain't your server. You don't get to decide that a conversation doesn't happen because you don't want it to. Fuck you. Who the fuck are you? You're nobody.
Okay, yeah, I muted him because it's not gonna work out. Every time he comes in, unless you guys want me to unmute him, you tell me. It's up to you guys.
If you want to hear just a lecture, unmute them. Otherwise, I wish you and Omnivore could keep having that conversation.
Yeah, Omni left. But I wish we can have that conversation because it was going pretty good, as a matter of fact. But yeah, that's what Robert does, man. Every time he comes in, man. I mean, I like the guy, but he just won't stop talking.
Well, I'll kind of have it. I didn't want to pipe in, but I didn't want to fuck up the conversation. But we've had this conversation about the hump Montreal. I hate when you do that. The only way you can define it as a hump is if it has a change in elevation. And the reference point is always on Earth. So it would only have to be defined that way. So under our understanding of it, it's not a hump because there's no change in elevation.
I couldn't agree with you more. There is no hump. Are you operating that dozer, by the way?
Excavator, yeah.
That's pretty cool, man. You know, I asked the crew the other day. I don't know if you heard this, Sean. They were doing exactly what you're doing. And I asked the guy, you know, the guy that levels the stones? What do you call that dude?
It would be just depend on what equipment he's on. But were they grading it like to an elevation, like road or something?
Yeah, he was grading it exactly. He had a spinning thing. It looked like an auto level, but it was spinning.
Oh, okay. Okay. Grade checker.
Yeah, laser
and
level?
probably had an auto level. It's a laser level basically. It's a laser.
And I asked him that very same question, bro. Exactly what we're talking about now. And at first he told me, yeah, there's a curve, you know? And then, like, when I was walking on the way back, he goes, hey, he called me back. He goes, you know what? I was thinking of what you asked me. He goes, can you repeat what you asked me? And I told him, I go, sure. I told him about the canal, 5 miles apart. You heard that before, so I don't repeat it, right?
Yeah.
Okay, and I asked him, you know, and I told him, you know, the water, there's two boats. How does the water appear? At first, he told me a curve. And then when he came back, he goes to me, no. There's no rise in the water. The water is level all the way through. And he showed me a piece of stone that, you know, when you do a walkway, it separates the grass from the gravel. And he pointed to that. And I go, from this point to that point, he goes, yep, the water is completely level, flat. That's what he told me, bro.
Now you added something in Montreal. He didn't say flat. He said level. But that level would not indicate a rise in elevation, and it wouldn't dictate whether or not the curvature is there. Curvature is
I asked him about
void of
flat
elevation.
He was pointing. John, let me cut you off. Sorry.
Yeah,
he was pointing to the separation thing, right? And I go to him, flat level, and he goes, yeah. He said yes. Now, mind you, he told me before. Let me just say this out, like on the other side, because I don't want to seem that one-sided. He told me before that level and horizontal are different. So let me put that out right away. Yeah.
Yes. This is the time of the day where you show that you don't understand what level is, as always.
Oh, Jesus.
This is a guy. I'm asking for moderation.
You actually checked Robert, so you can keep pretending.
Fuck! Is that imagine?
Fuck, fuck.
That likes
Hey,
to
hey,
talk shit
Sean.
as they find
Hey,
life?
All
be
the time.
careful. Be
Fuck,
careful
man.
now. You need to
I ain't gonna be
drive the
careful about
truck.
shit.
Be
Suck a dick.
careful,
Yeah.
loser. You need to
Suck
drive
Yeah,
the
a dick.
truck.
M-Agent, you gotta
Wait, I'm the loser, but you came in here just to talk shit to people. You have no life that you want to just
I
criticize
just
people all
muted
day.
him. I just
And you're
muted him.
calling me a fucking loser? Go fuck yourself.
Well, M-Agent,
Your
he's
internet
actually
persona.
he's
Time
That's
on.
the
to
best
kid the
fucking
people.
part.
Don't let him
That's
get
the
you.
best fucking you in real life, you would never act like that. In real life, you'd be fucking sucking people's dick, acting fucking being nice to them because you wouldn't want to get beat
Yeah,
up. Don't become an
true.
internet
That's
warrior because you're on the fucking internet.
Yeah, nobody
Yeah,
agrees
poophead.
with anything M-Agent says. Even if he was correct, you disagree and better steel man, whatever these things he says.
Yeah, so I muted him. Like, I mean, I have to do it. We can't have that, right? So, I mean, yeah. So we can continue, guys.
What were y'all talking about before the stupid guy said stuff?
Well, we were talking about a surveyor that I asked a question about water, and he told me two things. He told me, well, first of all, I asked him if level and horizontal are the same. He said no. Then I asked him, I told him, like, I'm in a group of people and they talk about flat earth politics. And you know what he told me? He goes to me, flat earthers are stupid, like with a passion, like stupid people, like that. That's how the combo started. So then I asked him, well, okay, well, sure, okay, it's a globe. And you know what he told me as a proof of a globe? He pointed to a plane. He goes, look, there's proof. When you see a plane flying, you see it curving, right? And I'm like, obviously not. And I go, yeah. I was like playing along with him.
You kind of do, Montreal.
You gotta think when
Trying
you're
to get
putting
him
up a
on this
picture on the wall,
debate.
like you've never been like, hey, I need a horizontal this picture. So there is a difference, but what the difference is,
Yeah, so this is the same guy, though, that came, like, when I was walking back from the construction site, right? He goes to me, well, hey, he goes, hold on. I was thinking about what you asked me about the canal. Can you repeat it? And I told him again, right? And he goes to me, no, there's no hump, there's no curve there. It's completely level. And he pointed to the thing, and I go flat like the stone, and he goes, yes. So I'm just reporting back to what a professional surveyor told me.
But he's also a planar surveyor, so he's not going to have the same skill set. But that's just an FYI. It's not a defeat to your argument.
Yeah, I'm just saying what he told me. You know, I'm not saying that you know.
I get it.
But I think the guy did a Scooby Doo. You know.
As you said it, I imagined it.
Don't forget, he was calling flat earthers stupid with a passion, right? With a passion, like it's like I triggered him. It was all I heard of those guys, and they're stupid. Don't listen to them. They're dumb, stupid. Like with a passion, like. So I go, oh, okay, I found the right guy now.
Don't you think that most people feel that way?
Yeah, of course, especially you, John.
Do you really feel the need to express it? Does it make you feel good? Does it give you a mini hard on?
Well, no, I mean, it's just funny to me that Essie's told that story a few times because it's as if it surprises him that this guy said that. It's weird.
No, it doesn't surprise me because he said two things. First, he said there's a hump of water. And then he thought about it and he came back and he asked me to be sure. And he said, no, I'm merely telling you what he said. Now you make up what you want of it. Me, I know water doesn't hump or drop. I know that.
Yeah, it's all the water's always at the same elevation. That doesn't mean that it doesn't block the view of somebody, of two people who are at higher elevations if they're far enough apart.
So they're both at the same elevation, right? So they start moving apart from each other. But because they're on you have to presume they're on a ball, right? So from that starting point, they start dropping in respect to the apex if you look at them from the side. But if equal elevation, the way you guys think of it, they don't. Yeah, this is not rocket science.
Yeah, I mean, I put the diagram. You understand. I when you were talking with Omni, I had the sense that you didn't understand the diagram I just put in the chat. Is that right, or was I just misunderstanding you? I mean, you understand that diagram, right?
Absolutely, yeah.
Okay, good.
I love that diagram, as a matter of fact. Beautiful. Oh, those two dots are at the same elevation according to your model, right?
Well, they don't have to be, but that was kind of my intent. They're at the same elevation, and the blue is all the same elevation. That's water, right?
Right. And the reason you can't see each other because the water is blocking you, right?
Right.
Okay.
Yeah. So I mean, somehow I had the sense that you didn't understand that. I wasn't sure what the argument
I get your model fully.
Okay, good.
It's just that it's going to take you a while to understand what I'm saying, but if you ever get it.
That's the difference between flat Earth and we just haven't figured out that flat Earth is right yet. You guys are just above us in some kind of mental. I don't know. You guys are in a different realm than us, I guess. Damn. Boy, I wish I could wake up and be in your guys' realm. No, actually, do I?
Yeah. It's all good.
I think I feel good being stupid right in my own realm.
Yeah.
Look, it's all good. We can all believe what we believe. That's the way it goes.
People are people, so why should it be?
Unfortunately, when you get on an airplane for a 10-hour flight, it has been figured out by those who need to figure it out. And you can sit in your seat and have your cocktail and you have no doubt that plane knows exactly where it's going, exactly how long it's going to take. And it's a great circle route and satellite navigated.
Well, it's funny. That's what the surveyor used as an example of a globe. Instead of talking about his craft, the first thing he told me is, look at a plane. When a plane flies over you, you see it curving, right?
That's weird.
First thing he told me.
I mean, I don't know what he's talking about there.
He drew a sketch on the lamppost where he drew the circle and the horizontal went off into space.
What does it mean when a fighter jet says we're flying under the radar?
Hold on, bro. Two guys came in there. We didn't hear either one of them. That was Sean and somebody else.
Well, I was just saying that's weird. I don't understand the plane example. That's a weird thing to bring up.
I know. I couldn't believe it. That's what he told me.
And I was saying, what does it mean when a plane says, it's like a fighter jet is saying, we have to fly underneath the radar? What does that mean?
Fly underneath the radar.
Yeah,
the radar has a certain altitude that it could detect, right?
Well, it's like a cone, though. I mean, it's going to encompass everything that it's pointing at. I mean, from what they say, it's because you can hide from, as long as you're like far away, you can hide from the radar as long as you're underneath the curve of the Earth. But there's a point where you pop out of that curve, and then they see you. I mean, that's documented.
Well, you take the case of the Falkland Islands, where the Argentine jets were flying along at like 300 or 400 meters. They could not see the target. They popped up to about 2,000 meters, acquired the target, and then dipped back down and continued on their way.
That was because of the curvature of the Earth, right?
Yeah, the radar horizon, yeah.
Okay.
And then the Exocet missiles were launched at that low altitude, skimming the water, and could get very close to the Sheffield before it was detected, and it was too late.
We got spanked by Exocet missiles during that war.
And military, military, particularly naval aviation, and the curve of the Earth. I mean, absolute. That is absolute.
And it seems like if it was just like, oh, well, radar can only sense things at a certain altitude. It seems like you just point the beam down a little bit so you'd get everything coming at you. Otherwise, everything could come at you from low. You know,
Which is why they.
the reason why
Which is why they
do
have.
that. Yeah.
Which is why they have AWACS. When they talk about, some of these radar guided missiles, oh, that has a 200-mile range and it's radar guided. Well, the radar's in AWACS and it's sending information, navigation information to the cruise missile.
Yeah.
By the way, Mav, the skateboard paradox and the twin board paradox is to make fun of the drop in the globe. I want you to understand that it's to reduce it to ad absurdum. You understand that, right? I hope you got it, but after all these years. Just saying.
Yeah, we got it.
Oh, another thing that the surveyor told me while I was leaving? He was yelling, "Water on a ball! Water on a ball! Ha, 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 water on a ball!" I swear to God, may lightning strike me.
You're fibbing now.
Yeah.
So it sounds like he's talked with flat earthers before. Is that right?
Well,
it was weird.
Of the several times I've heard you go through that story, this is the first time I've heard these last two addendums.
Yeah, that seems weird because up till then it seems like a guy who maybe hasn't talked to flat earthers. But you'd only say that if you had, right?
Yeah, I mean, let's be honest. No one says water on a ball other than these
believe it, honestly, from the bottom of my heart, I could care less.
Sure, but no one outside this community says things like water on a ball, do they?
That's what the surveyor told me. As God as my witness, as I'll swear on whatever you want, that's what the man told me. You don't have to believe it.
So do you believe in heaven and hell?
He was laughing like a madman almost. Water on a ball.
Do you believe in heaven and hell? Do you believe that you would go to hell if you were lying just then?
Well, I don't believe in that, so...
Okay, yeah, fair. That's kind of what I thought.
So you think I made that up, John, or what are you saying?
Yeah, I do kind of. I mean, I'll just be honest. I do kind of think you made it up.
Yeah, no, I don't think so.
Well, I put it on my first gerbil, Aloysius. God rest his soul.
Yeah.
Or gerbil rest his soul. Sorry.
Did you hear about the first one I asked years ago, John? And he drew. What would you say if I were to produce you a drawing from another Montreal surveyor a couple of years back? When I asked him if you can extend a straight line segment and how long, and he told me indefinitely. And I said it would extend to space, and he said, "Yeah, let me draw you a thing." Would you think I was lying there too?
Well, I don't really understand that, so I don't know. I don't think you're lying. I would need to understand a little better what you're talking about.
Yeah. That was the story you had relayed, and then this latest addendum, I hadn't heard that before.
Well, that's because this happened just a few days ago. Maybe about a week max, not even. So these are two separate encounters with Montreal surveyors.
Had you been talking to him more? Is there conversation left out? Because the whole water on a ball sounds like something that could only come up if you had somehow talked about that or something. I mean, I just think that's weird that he would say that.
Or maybe you didn't hear that I told him I'm in some forum that we talk about flat earth, religion, politics.
Oh, so he was talking shit then.
Yeah, I mean, maybe he's been in those forums too. I mean, but he would have to have been, right? There's no way anybody would say that who hadn't had some significant contact with flat earthers.
Well, he also told me that you're talking to the right guy because I've heard of that before. Maybe you missed that the first time I explained it. So it wasn't his first. He's heard about that before.
Okay, well then, fair enough. I believe you.
There's no. Why would I lie? First of all, the first thing I said about him is that he said level is not horizontal, and I believe the complete opposite. So, I mean, if I was to lie, I wouldn't say that. And he also said flat earthers are stupid, the stupidest people. That's what he was saying.
Yeah. I don't understand the coming back and kind of withdrawing his. I mean, I don't know what it might have been the hump thing, what Omni was talking about. It's not really a hump in the sense of being higher elevation, but it is a hump in terms of blocking your view. So maybe, I don't know what he was thinking about that, but the plane example is just weird. I mean, I don't know why he would think that looking at a plane fly above you gives you any indication of the shape of the Earth.
I agree, but that's the first thing he said after flat earthers are stupid. That's the first example he gave me. And then I brought up the canal, the hump came up, and that's why I think he was thinking about it. And then he said, wait a minute, did I tell this guy there's a hump of water there? And then he said, no, it's completely level from one end to the other. And he showed me
that's right.
of cement, whatever you want to call it.
Right. Lots of, as I said in the chat, lots of globe earthers say dumb things from time to time, and my friend Rob is certainly a prime example.
SC, you know how they got lids on pans and they have like a piece of glass or like a steel, like a little thin like plate of metal. Like my son works and does like these welding things, all this shit, and they have these little thin plates of metal, kind of like a lid, right? So if water was higher than the thing in it, couldn't we have the little lid just slide all the way down? And if it cuts the water in half or gets wet, then it is curved. But if that lid stays above the water the whole way, the whole time, no matter what, then the
See,
water
Dima,
can't.
you're thinking logically, right? You gotta take that away from your head. You gotta think of the hump that is not actually there. If you can do that in your head, you're good.
Oh no, I can't think about stuff that doesn't physically really exist. And I can't do it.
Same here, brother. Same here. But for their model has to exist, right? That's why. Yeah,
An impossibility has to be real for them. They have to accept an impossibility. They have
Look,
to accept that
Shubil.
something, yeah.
Look, Dimak, Shubil just posted a picture, right? And to them, that's the curve of the Earth, bro. The bridge is curving around the curve. That to them, that's it. That's their model. There's no way talking them out of it.
They think that a man-made bridge is Earth curve.
Yes, sir.
Don't they think that Earth curve would be an original spot on Earth in somebody's yard somewhere out of every spot on Earth? Don't you think Earth would be curved itself?
Well, it does, but they say there's hills in Earth. That's why water is the best, right? Water is the best.
No. Stick with me on this one. Dirt is supposed to be curving. The whole planet is supposed to be a dirt ball. So somewhere on this planet, the water has to match the dirt somewhere. Somewhere the hill in your backyard has to match. You know what I mean? It has to.
Well, they'll make the argument that their hill could rise above the water, right? They could stack some dirt. Yeah.
Yeah, that's what I'm saying. Like a physical thing that they make into a curve, they can show that's curved because that has solidity to it and it's going to stack upon itself and not ride that way. The water can only stack upon something that puts on the bottom of it. It can only stack on a material up on itself on a material. So if you put water on the top of a hill, it's not going to stack. It's going to roll down. It only stacks for the geometrical thing that you place it. It can only stack according to that. You know what I mean? And then even then, the very top of it is going to be horizontal and not resemble no horse's tail, foot, nose, anything. It'll just be horizontal. Water doesn't make a shape unless you freeze it.
Well, that's why I brought up the skateboard paradox and the twin boat paradox to make fun of it, right? But it's not sinking in. It's nice. It's not working.
Oh, it's working.
Yeah, it's not working because it's showing your guys' lack of knowing what's going on.
like I said,
No,
the reason
there's no lack of reality here. We believe in
I
one
didn't say
reality
reality.
that can only be one thing. A curve
I
can't
didn't
be
say reality.
straight. A curve cannot be a horizontal straight curve. You're
Good, then it's
lacking
not then.
reality. And as
Then it's
soon as
not
you
then.
guys understand that you can't have something
But you
doing
guys are the only ones saying that.
as soon as you understand you can't have a round straight thing, then you'll be back to reality, Globers.
As soon as you realize that you're the only one saying that, we'll be back to
Saying
reality.
what? That you don't have a ball of water?
A straight curved thing. No one's saying that on the side.
So you think that a straight horizontal thing curves? I'm the only one that
Well,
thinks
when
it's
you
not
hang up, when
curving.
you hang a picture,
I'm
do
the
you
only
go, "Hey,
human
I'm
you
trying to
said
get
that
this
thinks
picture
a
horizontal"?
horizontal straight thing. Will you shut the fuck up, idiot? You ain't stopped talking
You've
yet.
been done talking, dipshit.
You don't even make any fucking sense, weirdo. Where do you have a
I'm not
straight
saying
curve?
shit.
Show me your straight curve,
Straight
bitch.
curve. I'm not telling you to just straight curve,
Shut the
dipshit.
fuck up, Narnia.
Fucking retard.
Narnia.
Dimmock, everybody, tone it down, or I'm gonna mute you.
Yeah, Dimmock, everybody.
Or you're gonna horizontal me. Don't horizontal me.
No, you yell that guy's name right there. What's that guy's name talking?
Tony.
Talking, he doesn't got no curves. He's only got
Yeah,
straight
we've
water.
only talked how many times, you fucking
Where's your
retard.
magical straight curved water, liar?
Tony, calm it down. Come on.
Where is this curved water, Omni?
You see pictures of it in the chat.
No, where's curved water?
Everywhere.
Everywhere you look, Emma.
I don't want pictures of your grandma's dick. I want curved water.
Every surface of
Turn
water.
Does your grandma have a dick?
Curved.
Slide,
Okay.
slide the lid over the aquarium and prove it, lying bitch.
Okay, let's ask
You're
a
not
real
gonna
question.
be fucking lying, cunt. You're gonna stop
Yeah,
the
whose
lying
grandma
right
has a
now.
dick?
So
You're gonna stop the lying right now, bitches.
So spewing the insults, Dimmock,
Bitches.
you know what's going
Do
to
you know how to
happen.
stop lying?
Did you just
Omni.
decide? Did you just decide you wanted me to mute you? Is that what happened? You were spewing the insults, and you decided, that it was you wanted to get muted.
He does that anytime he gets backed in a corner.
Yeah, it's called suicide by mod.
Yeah.
Yeah, I have to think. So every surface of water is curved. The amount of water in a fish tank is curved so little that you would be very hard pressed to detect it. But on a larger scale, as boats go over the horizon, we can see that yes, there is curvature. So that's your answer.
Well, like the picture I just posted, the funnel on that cruise liner is 240 feet above the water at all times. So is it going down? No. The water line on that ship is at sea level, whether it's at the dock or whether or not we can, it's gone out of view and we can only see the top of the funnel. The funnel is still 240 feet above the water. So going down doesn't really make sense if its elevation is not changing. It's departure from tangent. If you had an auto level set up and the crosshair was somewhere on an observation deck as it's going away, that crosshair would be on the top of the funnel. And then the funnel would start to disappear and the crosshair would be going straight over the top. Yeah. It ain't rocket science. It's just like SC said. The guy drew a little circle, drew the horizontal, drew it off into space. And that causeway bridge, yeah, the water is level. Everybody agrees. Water is, equipotential. It's reached its own level. The bridge is a uniform, like 20 feet above the water, and just goes straight on. But the bridge is concentric to the water surface and a uniform height above it, and it disappears, in short order, and gradually just, I don't know. They always say we see too far on a globe. We see too far. Well, if the Earth were flat, we'd see farther than that. I mean, I'm not going to try to, with this, how far? No, farther than we see on a sphere. So if we see too far on a sphere, we don't see far enough on flat.
Soundly told us that there's a 90-foot pump of water from one end.
And Jesse Kozlowski measured that too.
That's
Yeah,
right.
it's called the
He
cord,
measured it.
90 feet above the chord. So if you go from bridge abutment to bridge abutment, which are at the same elevations, 28 miles apart, the chord or the sagita to the bridge deck, yeah, it's 90 feet because the bridge is at a constant elevation, a constant height above the water. And you're not going to tell me the water's, anything but level, constant elevation. If it's at, if the tide or whatever is at 3 feet, that's the elevation of the water the whole time.
So you agree, 90 foot, like Soundly said.
At the distance from the cord to the deck. Yeah, you
Now,
understand.
you
You
remember
understand
the picture
a cord.
you drew? The picture
The
you
cord,
drew?
the cord where you get the sagita, right?
Right. Now, if we were to zoom out, that's why, like I say, you guys, like, you're not really catching on here, right? If we were to zoom out from the side of the bridge, what will we see? Would we see that 90-foot hump?
To the cord line, yes.
If you could see the cord line.
If you
Now,
could
I
see
said
it.
when you come around, what, to look at it, side on, orthogonal? Well, then you'd have to get far enough away to get it all in view. And now you're so far away, you might, there's going to be, maybe you can't even see the bridge.
But again, the cord line's under the water, SE. You can't see the cord line.
Right. So both people at the shore, Blue, if you were to draw a line between them, right, it would be under the water, right? Perfect.
Yeah, it would started out at the level of the lake, okay, and it will go under the water, yes. And at the center, the water will be 90 feet above that line if it's a straight line between the two ends.
And it's the perfect water level. It is absolutely the same elevation at all times through the entire 28-mile length. You know that.
No, I understand your model, but I'm just I want to have some clarity, right? So, but you guys are saying if we go from the side, if we have a side view, an orthographic view, let's say, you wouldn't be able to see that hump, right? That 90-foot hump.
Well, it depends on what you mean by see, because if you're going to pull out a camera, you'd have to have, some 100-degree field of view.
Well, let's say you were to look from one end where the bridge starts and from the other end where the bridge starts, and looking at it from the side, would the apex look higher than either end, or how would it look?
Well, keep in mind, the bridge is 147,000 feet long.
Right.
And 90 feet above its chord line, that's going to look like, a pretty good looking 2x4 at Home Depot until you look edge on.
So your answer is you wouldn't be able to see it.
It would be very difficult to perceive that if you're going to photograph it or just eyeball it.
Okay. So
That's why we don't rely.
You wouldn't be able to see it or photograph it. You're saying.
That's why we don't rely on photography in geodesy.
Okay, I mean, I don't know if there's anything further that we can discuss on the issue. I mean, yeah, you're going by the model, like full tilt ahead.
And meticulously measured.
Well, who meticulously measured it?
Kozlowski.
Soundly?
With Kozlowski.
Jesse measured it.
Yeah, the boys, yeah. And where are these guys now? It's funny that they've disappeared, huh?
Well, they haven't disappeared. Jesse's still making videos.
He is?
Yeah. Made one a few months ago. He doesn't make very many, but...
And he decided not to sit in on this crowd because he's got a real life. And he's, tied up at work and he's enjoying his professional land surveying career.
Well, Soundly came around. I've spoken to Soundly. But, I mean, these guys should be around more, no? They pulled a rumpus.
Well, with the likes of DMOC around and Electric, yeah, I'm surprised I'm still here.
There's a lot.
I'm here for the other people.
I left for a long time because of all the racist rhetoric. I'm sure other people were fucking tired of that too.
Racist? I haven't heard much racist stuff.
Not for a little while, but for like a couple of weeks there, it was fucking brutal. And I bailed out because I was gonna blow my fucking top.
You mean in here?
It was mostly in the text chat, but there was some of those people were getting time on the voice, and they were saying
there was
really stupid shit there. It was really, really toxic bullshit.
That's why Professor Parks left. So
yep. Rob was pissed. I was pissed. Coco was pissed. We all had a little conversation about it, and I really respect Omni and consider him a friend. I wanted to come back and see what was going on if things had gotten better, and they seem to have. And so I've been enjoying coming in and having some chats about flat earth shit. But I think a lot of people bailed on this place because of that. Despite the fact that we do get a few good conversations mixed in with some nonsense. And I don't want to talk about the meta. I just want to say the people that have left weren't scared of flirts. They were just tired of bullshit.
I wrote an entire thread about it, about platforming races on the server. It is in the suggestion spot, and yeah, like a few weeks back, it was pretty fucking bad. Like, you had people going on for hours while the mods were in here talking about the most, like, insane racist shit.
I know I wasn't in here because I wouldn't stand for that.
Other mods were.
You were not a perpetrator of it, and I've never been a mod that I know of. If I had been, I would have shut up about 6 people. But I do have too much of a temper to be a mod, I think. And I also have.
You need a very thin skin, yeah.
I do. Yeah.
I mean thick. Did I say thin? Yeah.
My brain might be thick, but you know what? I do have a bit of a thick skin after living the life I've lived. And what it's taught me is that some people have been beat down so fucking hard they can't stand up anymore. So if I got to stand up for them, I fucking will. And if people don't like it, they can fucking take it up with me in person. I'm fucking willing to have the conversation.
I like that a lot. There's no need for animosity, swearing, and all this shit. No need for that.
Well, I don't give a fucking shit about swearing. I'm a goddamn trucker. And so I swear a lot. But I don't use pejorative insults.
Unless the swearing too. I mean, I grew up on the street. Yeah. But if we insult each other, then it's going to turn to a shit show.
Yeah, I mean, there's no question. There's no question we're going to have some of that. But swearing doesn't bother me in the least. I'm much more worried about people using racial epithets and pejorative terms against people with different levels of mental capacity and stuff like that. And I do use the term flirt, but I don't mean it badly, and if people don't like it, I'll try to stop using it.
Doesn't bother me.
And it's a mixed bag, right? Some people are offended by it or choose to be offended by it. I'm offended by the R slur. I don't like it. I find it extremely offensive. But other people seem to think it's like a go-to around here. There's people on the globe side that think it's a perfectly good word to use. I find it to be a disgusting word, and there's far better ways to talk about what it is people are thinking. And for the most part, what flat earthers are talking about are really stupid ideas. They're not necessarily stupid people because a lot of them are applying logic to something they don't understand properly. But because they don't understand the concept properly, their minds aren't broken. They're just using them on bad information. And that will lead to that. It's like kind of like a foregone conclusion.
Yeah, too bad Professor Parks left because I like Professor Parks. I hope he's listening. I hope he comes back. That's unfortunate.
Rob's a great guy. He has his own channel. There's not a lot of voice chat over there, but it's an excellent community. I remember there. I enjoy it there. I enjoy talking to Rob. He's got some good people there.
Yeah, I like him too, and I would like to have him back.
Yeah, I've had some good cosmological combos with him, like really good. doesn't swear, he doesn't yell. If I ask him a question that goes against the model, he'll admit it. Like he's, for me, like one of the best that I've talked to about cosmology.
Well, and I've tried to talk to you about that subject too, and I really would like to talk to you about it again, because you seem to think that because there are things that we just don't know yet, even though we've made many strides over many decades towards knowing more and more, it seems like you think because we've reached impasses in our current understanding that we will never develop the technology or the ability to see more, even though we're seeing more right now. Like the new technology we have is opening our eyes to things we didn't know about. And I really wanted to ask you the other day, is your intention that we should give up and stop exploring cosmology because there are questions we haven't yet answered? Or should we keep trying to answer them? Because I was really concerned about what it is you were trying to say there. And I would like to have that conversation. It doesn't have to be now.
Oh yeah, I could give you a brief explanation. To the contraire, right? Au contraire, as they say. Completely opposite. What I think we should do, as a matter of fact, this is the greatest opportunity we've had in cosmology, because we literally have to remake cosmology from the ground up. So no, to answer your question is no. Not only should we not be looking at it, but we should be looking at it more intensely, because we have to redo it. And I'm not saying that. This is the findings of the current astrophysicists, right? It's so, the findings are so out of whack with predictions that we're going to have to start from scratch. So this is actually an exciting field for new people to get into.
And the one thing about cosmology is when you get deep space and dark energy, dark matter, expansion of the universe, any of that, Einstein's in, Einstein's out, Mond is in, Mond is out, all kinds of things. No matter what they hypothesize, theorize, revise, invent, it won't change the solar system. Everything they come up with will still comport with our solar system, our rotating planet, our orbiting planet, and the other orbiting planets, because they're nearby enough that we got that figured out. In all of nature, the shape, size, dimension, and motion of the Earth is the most well known.
Okay, let's say that what you just said, that's all true, right? Let's just say that's all true. They got the solar system figured out. Say I give you that. Aren't you concerned that the Big Bang, the formation of galaxies, expansion, all that is bring to question the whole model? All that is all it's just not true. Aren't you concerned about that?
And but none of that affects the Earth, because whatever they come up with, it doesn't matter. We're in the reality we're in right now, where it's tactile and measurable. We get on our 10-hour plane flights, and there's no question about the distances, the navigation. It's going to be satellite driven. We have orbiting satellites. We have weather satellites, navigation satellites, communication satellites. I mean, they're putting them up like 50 and 80, 50 to 100 a month. And what about the South Pole? I mean, there is a South Pole, and we have not just orbiting satellites, but polar orbiting satellites. So we got the shape of the Earth kind of figured out enough to where we're using it. And a flat Earth paradigm cannot produce anything that's useful.
You're missing the point.
We're also successfully sending things to other parts of our solar system on a regular basis, including probes to the Sun and to Venus and to Mars. And even though those environments are really, really hostile and some things have crashed and they've done this, that, and the other, they've still communicated back to us useful information. And so our understanding of mechanics at this, at solar system distances, is definitely right. And so finding out that there's things we don't know about with things that are really far away and things that are really hard to find out information about despite our best efforts, it's not surprising that we're learning new things as we develop better technology. But those new things will cause us to rethink parts of it, but they won't get rid of those fundamentals, which I think is what you're getting at. The fundamentals will still be true.
The Parker Solar Probe is a good example, because we still have that 8-minute delay when it's at elongation.
Yeah, so C holds up even at that distance. So one astronomical unit is 8 light minutes. And that's another test. So that also gives us that distance to the sun that some flat earthers claim we can't ever know, despite the fact it's been measured multiple times by multiple methods.
Yeah,
and they all work with one another.
Yeah, someone's saying, well, Steelman the flat earth. Okay. One of the versions I've heard is no model, no idea, whatever the sun is, we don't know, don't care. Might be 3,000 miles, might be 5,000 miles. That's my flat earth, Steelman.
You
Yeah,
forgot it looks flat.
It looks flat, but it just doesn't look flat. Everywhere I
Well-
drive on the globe, I see all sorts of bodies of water. I live near a lot of really large bodies of water, and many of my runs take me to them. And I've been to the places on the other side of those bodies of water. Sometimes I'm driving around them to get to a place where there's no ferry, or it wouldn't be practical to take things by boat. And I look back across, I can't see where I came from, and I'm fucking positive it's there because I was just there 5 hours ago.
I think you guys are missing the big picture. What I'm trying to say, like I'm not trying to take away your solar system or your globe, right? I'm not doing that. I'm merely asking you to look at the big picture. It's like your house is burning. Oh no, not your house. Your house is okay. Your city is okay. Let's say your city's okay, but the whole country is burning. Right? That's your model, and you're saying
that is true for us right now, as is it not?
You understand what I'm saying?
Yeah, it's literally true for us right this minute. Look at the fire map of our country. It's literally happening. I've literally had days where I can barely breathe when I step out of the truck because of how smoky it is. I can't see. I can't see down. Like when I go down to Toronto, and I come down off the escarpment, I can see the smoke haze over Toronto and over Lake Ontario. And when I go up to Lake Huron, I go up to Lake Superior, it's much clearer. But then you get into a section where you're close to a fire and it's brutal up there. And yet, where the fuck did Michigan go? How the fuck did they hide Michigan on the other side of Lake Huron? What the fuck happened?
Yeah, it's been really bad.
But as far as like the Big Bang, I think that's the one thing which is most vulnerable to be revised or abandoned.
It could be, because we'll find out. JWST will tell us more. SE, do you ever watch Dr. Becky Smethurst, who's an astrophysicist?
Oh yeah.
She's really good, and she gets into a lot of pretty good lay explanations of the different theories that they're working on to try and answer some of the questions we have. But she makes it clear that we haven't reached a point where we're throwing out everything. We've reached a point where we know some things still hold up and some things need major investigation and just a whole lot more information. And one of the things she brings up constantly is the applications for time on things like Hubble and JWST, and having scientists that come up with good enough experiments that they're accepted because they're likely to give good information. So they ask for data from certain regions. So they ask to have the telescope pointed for a certain number of minutes or hours or days in a certain direction to try and get something out of it, or find out that another group is doing it and try to also get information from that because they've come up with a unique way to apply that information. That type of collaborative science work is something we should be pushing for, instead of saying, hey, your whole thing's fucked. Because that's demonstrably not true. The whole thing isn't fucked, but there are big parts of it that, and in a lot of ways, those big parts of it are things we don't know about. So the reason they've been called things like dark matter and dark energy is because we're in the dark about them. Not that they are dark, or that they, have no color or no light or whatever. We just can't see them, but we see what they do to things in the universe, and so we therefore know something's doing something. We know that for certain, and so we then have to take that and apply that to the other information we have and see where that brings us. And that's not an unfair thing to do.
Yeah, but you have to understand that it's not me that's saying that there's problems, right? I'm just echoing the words of these astrophysicists. I don't know if you've looked into this, right?
I have, yeah. I have looked into it, and I don't know which astrophysicist in particular, but what I hear almost all of them saying is, at least for the ones that are speaking to people on my level, and my level is a pretty much as a layperson, who has a tremendous interest. But my understanding is we have new information that doesn't tell us things we thought we would see, and that's awesome because now we can start looking at what does that actually mean then.
Well, yeah, that's the way to go about it, exactly. But first, you have to understand and admit that they got it wrong. Once you go from there, then you can start finding the solutions. But it seems to me you're not at that point yet.
But you're saying they got no. I'm not at that point because they demonstrably did not get lots of things wrong. There are some things that weren't what we were expecting, but most of those things, like dark matter and dark energy, were never put forth as finished science. So they didn't get anything wrong. They put in placeholders saying, hey, we know something's going on here. We see it doing something. We know something is happening. We need to look at that. So like for those things, that's true. There's also things in the universe that are further away and therefore older than we thought things were in the universe. That's a weird thing. What causes that to happen? Is that because we were totally wrong about how long the universe has been expanding for, or is it because of some other effect that we don't know about yet? We've only had these images for a couple of years coming in. Like there's not enough known to make a determination about it. And so I'm not willing to say anything is wrong, but what we do know about all science is that it's always a little bit wrong, even for the things we think we know 100% about. Additional precision can always be gained, and oftentimes that doesn't change what we know, but it changes how useful something is to us.
Like I said, bro, I don't want to insult you, right? What I'm going to say now is going to maybe sound insulting, but I don't think you fully understand or are fully up to date with the latest findings and what these scientists are actually saying. Like, I'll give you one example, okay? You heard of Roger Penrose? Yes. The famous guy, Penrose? Well, he said recently that quantum physics is wrong. Not incomplete, wrong. Do you understand? Like, that's just one example.
Okay, is Roger Penrose the god of science? Or is he one person with
Yes, he is. As a matter of fact, he is a god of science. I'm glad you said it that way.
He's a fucking smart guy with a platform. I don't think that it is possible to say unequivocally that quantum physics is wrong. But I think there's lots of things we know about quantum physics and lots of things we don't know about quantum physics. And so, depending on the context of that, I'd like to know what exactly he said about that, because that sounds like a clickbait soundbite and not like a well-reasoned science explaining why everything that's ever been determined about quantum physics is wrong, and why it is that so many parts of quantum physics work perfectly when under experiment. And in day-to-day life, because quantum physics is why we're having this we are having this conversation right this second, thanks to quantum physics.
These are all talking points that you're saying, bro. Like, I mean, come on.
It's not a talking point.
Talking about Penrose.
So
big fucking deal.
So I'm a huge fan of Penrose. I know precisely, and I've read some of his books. So I think
he's a smart guy.
Yeah. I just want to make it clear that for someone to say quantum physics is categorically wrong, you would have to that the context for that is not quantum physics doesn't work. It has to be something else, because we have all sorts of working. I mean, Trucker isn't wrong. It sounds hyperbolic, but the Nobel Prize was given to guys who figured out how to avoid a quantum effect of tunneling through very small transistors. Okay, which allowed us to make the smaller microchips that we have in a lot of our devices. So whatever context he's using to say it's wrong, it's all got to be redone. I don't see how it can be that it's just like none of it works, because we know a bunch of it works.
Like if Vandy was here right now, he could speak to multiple parts of it that work perfectly, at least at the atomic level. and he does experimentation on this all the damn time. So
yeah, he works in he's a working quantum physicist. I mean,
yeah,
it's
yeah, he literally gets this done.
Yeah. So I don't see how we can come up with I don't see how we can hold that the whole thing is just wrong.
We just I'd be interested to see what it is Penrose actually said, but I am 98% positive that he didn't say the entirety of the field of quantum physics is 100% wrong in every way, shape, and form. But I wouldn't be surprised if he said that the information that we found means that we have to reevaluate a great deal of it.
Instead of just thinking and wishing what he said,
I don't wish
anything. For you. I posted it for you. Have a look and
I'll have
see
to
for
look
yourself.
when I'm driving, of course, but yes, I will have a look. I'm happy to.
Look, I'm not making this stuff up, man. I mean, you guys got to look into your model like that.
I don't think you're making it up. I think that this is actually said. So he's saying what collapses the wave function. So, what we have heard is that observation collapses the wave function. And that is usually taken by non-quantum physicists to mean like having eyes on something.
Yeah, recording it, seeing it. Yeah, observing it.
But that's not actually what happens. So I talked through this with Tapioca. I brought the video up. I'll watch it in a second. But that what they mean by observation is you have a wave plate, which is something that the light passes through, and it doesn't polarize it, but does something else that tags it. So it's a measurement. It's a way of detecting the photon going through the wave plate or not going through the wave plate. If it goes through the wave plate, when it reaches its final destination, it has a slightly different characteristic than if it does not go through the wave plate. And the presence of that is what changes whether or not you get the distribution, the wave effect, or the particle effect. And
right, the collapse or not. They call it the collapse.
Yeah, that's really freaking weird. But it doesn't imply that the consciousness of a person is required to collapse wave functions, whether or not that piece of hardware is triggered by the light or not. Now, the quantum eraser, not the idiot, the actual experiment, is where you set it up so it goes through the wave plate, but then you have another wave plate that undoes the change. So you tag the photon, and then you erase the tag, and that, for some bizarre ass reason, gives you the wave function back. So it's really freaking weird, but it is what happens. I mean, apparently they test this, and when they test it, this is what they find out. So I don't know what Penrose is saying, but if he's saying we're wrong about how the wave function collapsed, that wouldn't surprise me.
I think that is his argument. It's been a while since I saw it. I forgot. It has to do with the wave function, but I forgot what he said. Did he
I'll check it out. But I'm just saying that there's probably a lot of context that's in there that would be very difficult, for us to understand.
Yeah, but nevertheless, he says it's dead wrong, right?
Well,
is that what he said, though?
And he even says it's not that they got it slightly incorrect. He says that's the polite way. No. It's wrong. He says it clearly like that.
Well,
that doesn't sound like all of quantum physics is wrong. That sounds like this one type of understanding of what this measurement is about has been misunderstood for a long time.
Well,
you said all
I need to listen to this. But okay, well, I'll listen to it. But I'm telling you that
I'll listen to it too. Is it a program or a paper to read?
It's a YouTube.
It's a YouTube video. Okay.
Yeah.
So it's pretty accessible for me while I'm driving. I'll listen to it. It's in the Omni text chat, like the main one, not the weird one no one uses. Okay.
Yeah.
All right. I've never understood that aspect of how Discord works.
Well, they say if you understand it, then you don't understand it. That's another stupid thing they say about quantum
That is
physics.
true about that is true about Discord. I don't know if that's true about quantum physics.
No, that is true, and I can tell you who said it. Feynman.
Yeah, I think that it is true that anybody who said they understood quantum physics in the day of Feynman was 100% wrong that they understood it, because it was in its very early days. I think a lot of people know many things about it. I do not, for one, think there's ever a point at which we know everything about any topic. I think you can be very well read. You can be extremely erudite in a topic, but there's always more to learn. And I think that's the best attitude to have. And that's what good science does. Good science doesn't presume it's correct. It presumes it could be overturned at any point and works to try and overturn itself or discover something new. And as long as it continues to do that, it will be valuable to human civilization.
I couldn't agree with you more. That's what I'm trying to tell you. But you guys seem to be clinging on to this old cosmological model.
You're accusing me of something I'm not doing.
You're interrupting me again, bro. Please don't do that.
I am for sure.
Please don't interrupt me.
Okay, get away from the meta and go on. Just go on.
No, listen, man. Just keep your mouth shut and don't tell me how to talk or what to say. Okay? Thank you.
Oh, for fuck's sake.
I mean, we don't got to do this. We don't got to go down this level, bro. Just shut up. Don't interrupt me. Don't try to get above me, bro. It ain't gonna work.
I'm not. I just want you to fucking say what you were saying.
Okay, so keep your mouth shut and let me talk and say whatever I wish, however I wish to say it. Is that okay with you?
That's all you're gonna say? No. If that's all you're gonna say, fuck off. Say something pertinent to the conversation.
No, you fuck off, bro. You keep your mouth shut. I was talking. You're interrupting me. Maybe I triggered you. That's your problem.
Hey guys, can we reset? Can we reset?
Control your
emotions. You fight me on this, and I'm trying to back off and let you say what you were saying.
Can we just both reset?
Now I just forgot what I was saying. Just forget about it, man. I'm gonna have supper soon, anyways. Whatever.
That's fine. Go have supper. You think that I'm clinging on to something I'm not clinging on to. Thank you. I got the point.
All you had to do was keep your mouth shut, don't trigger me, and this wouldn't have happened.
But I like triggering you, SE. It's fucking fun.
You see? He's doing it on purpose.
No, I'm not. I was just, why are you going down this road about asking me to shut up when I already backed off and said go ahead? I don't fucking get it. Why would
It's the way you said it. It's the way you said it, bro. It's like you're trying to control what I'm trying to say, and I don't like that.
I was trying to clarify I'm not clinging on to anything. I'm specifically not doing that. But yes, I jumped in the middle of you accusing me of something I'm not doing. So please go ahead and finish your accusation so I can...
Yeah, why is it you think that you don't understand quantum mechanics? Why not?
Quantum mechanics is a very large topic. But I haven't enough of it.
Trucker, you're
I understand all of
in
it.
and out.
I don't think. Yeah, I'm out in the sticks here. But yeah, it's a big topic. I don't think I'll ever understand all of it. I'm already almost 50 years old. I don't have enough time to learn it all.
Anyways, I'm gonna break for supper. I'll catch you guys later.
Really quick, SC, I didn't realize one thing, that the SC in your name stood for stationary Earth. I found that out a few days back.
Yeah. SP stands for stationary Earth. Yeah.
Yep. I learned something.
I thought it stood for Syrup durable.
Some guys were saying Southeast Montreal, but no, stationary Earth.
That's what I thought it was. I thought like you're from like Southeast Montreal. Like that's literally what I thought it was.
That's what all Americans think. Yeah. Yeah.
Yeah, but what,
we don't.
What part
it's
of,
hard for us
part
to
of the
think.
swamp
I
are you
see.
from?
Come on.
Montreal. There's no southeast. Well, there is, but I mean,
there's the island. There's the island. There's Pointe Claire. There's the little there's what is the name of that stupid place where all the fucking Costco's and shit are on the bottom side of the
Yo, Al Trucker, what if the problem isn't you? What if the problem is how they try to explain quantum mechanics? Maybe that's why you don't understand it, because it's not yet refined into a real
You guys have
comprehensible
a
model.
good day.
Yeah,
I think
you know what I mean?
it's a developing field of science for sure. It isn't all known yet. I think that's part of it, but there are so many things that happen on a quantum level that are tested and known, combined with all the things we do not yet know about what's going on, and it's also appears to be exceedingly difficult to experiment on these tiny little particles without smashing them together really, really fast and hard, and that takes a lot of infrastructure, which is very costly to build and run. So I think the field itself is somewhat hamstrung by costs and unknown benefits, even though there likely are some. We don't know what they are. We don't know how it'll pan out. And
You just described the Hadron Collider, right? The people that are trying to find the Higgs boson.
That's one. Yeah, the Large Hadron Collider.
All that money doesn't provide them any information about quantum mechanics. That's to try to find out if there was a cataclysmic event that caused the Big Bang. Like, they're literally trying to blow up the universe.
I think
you can understand quantum mechanics with a quantum tunneling microscope. You don't really need
well, you can
a Hadron
understand.
Collider.
I think quantum mechanics also includes the behavior of subatomic particles and what they do, how they interact with one another in an atom, and also when they are blasted out of it. And that does help understand about earlier universe states, because the understanding of how much heat and density were there at the time necessitates that no atoms were present at that time. Everything.
How do they know that?
Right?
How do you know that the universe was in that state that long ago?
It's a mathematical model, and the CMBR is evidence of it. But there's like I've said before, in science, nothing is known as an absolute. Really, things have been postulated, tested, and when they're tested to the point that we can't find another reasonable answer, and the answer we think we've found seems entirely reasonable, it stands as a theory until disproven later. That's how it works. Good science works that way anyway. So.
Yeah, you can't manipulate any of the variables in your observation of the cosmic microwave background. So that's not science. It's observational science. You're making calculations.
It is fucking science.
You can't really.
It isn't a fucking chemistry experiment.
It's an observation. That's one part of an experiment. But once you actually manipulate the variables, now you're doing an experiment.
But if you take enough measurements in enough places, and the variable is how many places you take the measurements, you've manipulated a variable.
All right, so you could go around the entire Earth and take pictures of the cosmic microwave background, and whatever variations in the positions of stars is not going to tell you anything about the early universe either way.
Yeah, but the variation of positions of the stars isn't really germane to what goes on with CMBR. CMBR is something we measure in all directions, and that's what's interesting about it, is that we see it in just about every direction, and it seems to be everywhere we look, all the time, no matter where we point our equipment. And so that's what's interesting about it, is that it isn't like an anomaly here or there. There are differences in it here and there, so it's not perfectly isotropic, but it is a really good indication that the Big Bang modeling of the I think they call it the recombination event, that was some hundreds of thousands of years after the initial expansion. And I don't have all of this stuff at hand. I have read up on this in the past, but that's really good indication that we have something that makes sense. It works, and there's some proof of it.
When you say that, what do you think is making sense?
What's making sense is that the fact that we find the CMBR at the temperature that it is in all directions everywhere in the universe all at once, no matter what, no matter where we look, no matter how we look, that is really good evidence for the prediction they made about the expansion and then the contraction that was on a universal time scale pretty soon after, although it was hundreds of thousands of Earth years. I think maybe 300 to 400,000 Earth years later, then everything sort of fell back in, and that is a point in the time scale beyond which into the past we don't seem to be able to look. There's a wall up in the past that we can't see past, which is interesting.
Yeah, so what they're discovering is like these galaxies that they tried to put them in a certain distance, which would be indicative of, that it was created in the early stages of the universe.
Yeah.
They're finding that light within those regions is not redshifted how they would predict. That's what they're finding. So their prediction's wrong. I'm sure you know that, though.
Yeah, sure. And then so they're finding new information. It wasn't what they were expecting. Now what?
So making presumptions about why the light is redshifted should be a thing you don't do.
No, that's what we should do. We should form a hypothesis which involves that presumption and test it. See if it makes sense.
Yeah, you can't test anything about this picture. You can't go to the star and find out the medium that the light is passing.
That's not a base requirement for a successful observation of cosmology. That's not a requirement.
Yeah, but that's not. You're not testing anything. You're taking an observation.
You are. Yeah, no, you are. You can. There's a lot of things you can find out with a lot of different equipment. It's very expensive and very labor intensive and very cost intensive to put these things together, and some of it requires inventing things.
Like what? You
like
took a picture. You took a picture with the Hubble telescope. Now, what are you doing?
Now, the Hubble telescope is coming to its retirement phase, and we've made the JWST. So we develop another way at looking at things, and so perhaps the JWST or some of its successors will give us more information. But we don't.
They presume that the reason that the light is apparently redshifted to the longer wavelength is because of when the light was emitted and how long it's been moving away from the Earth. Right? They say it's redshifted, therefore it's far away. What if it's redshifting due to attenuation? Do you still think that's a possibility?
I think lots of things are possible. I don't know about this specific thing you're talking about, and so I'm probably not the best person to have this conversation with at this point. But I'm more than willing to find out more about it and then have a conversation about it. But this isn't something I'm well read on at this moment. So yeah, like do I think attenuation could be the reason? I don't know. I'd have to understand what attenuation means in this context. I know what the word attenuation means, but I also know that words like that often mean something very specific when it comes to a specific branch of science. And I don't know its context here. So I'm not going to.
Attenuation doesn't produce redshift. It just produces reduction in intensity.
Okay, wow. So charged particles don't. My bad. Charged particles don't scatter the light.
Yeah, charged particles scatter light. Yes.
Right. So this will actually change the wavelength.
Well, yeah, it could. Right. I mean, you can. Yes, you have. It's. Well, okay. We have to back up a little bit. You don't get a systematic redshift. For instance, in when we talk about redshifts in general with stars, etc., we see spectroscopic features redshifted. Scattering would obliterate spectroscopic features if that were the primary cause of the redshift, and it wouldn't be. And it wouldn't be in general a redshift. It would be just a blurring, right? I mean, scattering off of things doesn't necessarily make them lower frequency. It can make them higher frequency too.
Okay, so this is what I'm saying. We're looking at the CMB, things appear redshifted. You guys claim that it's traveling through a vacuum, so it shouldn't really be shifted at all. But you need a reason for it to be shifted. So you say the reason is how long it's been traveling away from the observer point.
No, it's not really specifically how long, it's how much the universe has expanded since it was emitted, because the wavelength expands with the universe.
Yep. Right. So therefore, it would take it longer because it's literally farther away. It's the same thing.
Well, if you believe that the expansion of the universe is proceeding, in some way, then the more redshift, the longer it would be traveling would be the implication. But the point
And the
is that
reason
the
it's taking
redshift
longer to
isn't due to time;
the
it's
reason
due
it's
to the
taking
amount
longer
of
to travel
expansion.
is my bad, dude. The reason it's taking longer to travel is because of when the light was emitted. This is your supposed evidence that it's from the early stage of the universe.
Well, I don't know what you mean by the reason it's taking. I mean, all I'm saying is that we take the redshift to indicate how much the universe has expanded since the time of emission. That's the thesis.
Right, which comports with a distance, right? And a length of time that the light has been traveling.
Right. So if we, in the case of light from galaxies, unlike the cosmic microwave background, you have to make a few additional assumptions. But when we look at distant galaxies, the more they're redshifted, the more distant we assume they are, and B,
Thank you.
confirm they are with other methods.
So this is it then, right here. You guys say that light will just continue. It'll just propagate with no loss of intensity, no dispersion through a vacuum, that it'll just remain the same wavelength, right?
It does
And then you
lose
say,
intensity by inverse square law kinds of things.
great. Yeah, this is what I'm saying. I'm saying that the loss of intensity can cause it to redshift.
No, that's just wrong. I know you're saying that. It's wrong.
Wrong according to what?
Well, inverse square law attenuation is not redshift. That's just intensity reduction.
Why are you claiming it's redshifted from the early stages in the universe? Do we
So
have
the
to go over this
redshift
again?
is due to another thing. It's due to the fact that while it's traveling and losing intensity, the universe is expanding and taking the wavelength of the light with it.
What?
If light were simply traveling out in a non-expanding universe, it would simply get less intense. It does that even in an expanding universe, but in an expanding universe, it also redshifts.
So it would redshift if the universe wasn't expanding. That's what you just said.
I just said that it wouldn't, but I mean, you don't have to believe that, but that's the model.
The expansion you're describing, you're talking about the distances between the molecules in your gas cloud.
Well, no, I'm not really talking about that, although that kind of happens too, right? As the universe expands, the stuff in it that isn't gravitationally bound gets further apart as well, and so do wavelengths of light. I mean, be clear. I'm telling you what the model is. I'm not telling you what really happens. I'm telling you what the model is, and that model is pretty well borne out by observations.
So you're just criticizing me because I'm not reiterating your model's claims.
No, not really.
alluding
I'm
to-
criticizing you
Okay.
because you're not portraying the model correctly.
I'm not trying to. I'm trying to allude to a different reason it could appear redshift. You guys claim it's because of the early stages of the universe when the light was emitted. Over time, the light has lost its intensity. It's just saying distance.
But
It's the same thing.
well, but let's be clear. It's lost its intensity. It would lose its intensity in any event. Spreading light loses intensity.
Yes. So there's another reason.
So it has nothing to do with redshift.
What about the idea that there was a plasma physics model to the universe, And maybe the light is scattering due to some kind of plasma, rather than presuming a vacuum. That's the
Speculate
idea.
away. Yeah.
Well, yeah, that's the idea. Okay, cool. Thank you, John. Well, yeah, no, what you said is correct.
Everybody's free to speculate. It's just that people should, when they criticize the model, they should understand what the model says, and then talk about how observations either do or don't support it. There's plenty of reason to think that the current model is wrong in all sorts of ways. So you don't need to convince any physicist of that.
Yeah, dude, I have a problem with the vacuum. I think that there could be a material in space that they're not telling us about.
They're not. Nobody. There's no material that quote they're not telling you about. That I can say with relatively strong confidence.
Yeah, they claim quantum.
There may be material that we
These
don't
charged
know
particles.
about.
They say that there's charged particles over these vast distances in vacuums, right? There's an empty region of space. The only two particles within that region of space are quantum entangled. That they actually are creating resistance between their bonds, right? That's this quantum entanglement shit that they say. So you have resistance in a vacuum right there. What if it's never really a vacuum?
Well, I just don't know what you're talking about now, but you're free to speculate.
I know.
Vacuum.
You want there to be a vacuum bad.
You're talking about quantum entanglement, and you're saying that quantum entanglement can't exist if there's a very, 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 very low pressure system between matter out in space. What do you mean by that?
You guys claim that space is empty. I don't know if space is empty.
We don't
say space is empty.
What are you claiming? Not what we're claiming. What are you claiming?
Okay, I think that the globe model puts forth the idea that deep space is empty. This is what they say.
No, the globe model. The globe model The globe model is about the shape of the Earth and maybe the solar system. It has nothing to do with redshifts or quantum fluctuations or quantum entanglement or dark matter. It's about the directly observed fact that the Earth is a globe. That's what the globe model is.
Okay, and then your globe sits within a cosmological model where there is such thing as nothing. You have vast empty regions of space. Yes, you call them supervoids. Yes,
it's just not true. There's no place in the universe that is devoid of matter.
I wasn't done.
As far as we know,
listen to the double speak.
We don't know of any place in the universe
that
is
you're
a vacuum.
You don't like hearing something rebut your claim, right? I know.
Well, it's not true.
I was trying to tell you something. Listen.
Well, he's trying to tell you.
You just got done saying that yes, light will not lose intensity in a vacuum. Do you agree?
I just got done telling you why it always does.
There's nothing to scatter the light. What's causing it to lose its intensity?
Inverse square law. When light travels away from a source, it gets less intense.
This is
cool. But you're picturing you're in a vacuum. So you're saying that there's literally nothing in space that could also be affecting the intensity.
Well, first of all, there is no such thing as a vacuum. So carry on.
Yeah, exactly. But they said the globe model acts like there is.
The globe model has nothing to do with what. Why do you keep calling? If you want to talk about physics says something, you can say physics says something. The globe model has nothing to do with whether or not there's a vacuum. The globe model is about how things look from the globe Earth.
Your globe is surrounded by nothingness, bro.
On purpose.
You're mixing up what a vacuum is with a very, very low pressure system.
No, I'm not.
If there's a vacuum in deep space.
Hold on. Stop interrupting, John. I am not confusing anything. You guys claim there's such things as supervoids. These massively
not
spherical empty regions.
No,
in deep space.
They're not.
Oh,
empty
so a supervoid
regions.
is not an empty region anymore.
Right.
All right, let's hear your cosmological model and not the globe one.
It's a very large region that has very surprisingly low density, low concentration of galaxies, stars, whatever you want to say. It's not a vacuum.
What constitutes a vacuum?
Okay, if there is a vacuum at all, it's like what we have right in front of our nose when you look at places between molecules of nitrogen and oxygen. There's a lot more space like that out in interplanetary, intergalactic space. There's a lot more places where you don't find atoms than there are right here. But right here in front of your nose, there are places that don't right now have an oxygen atom or a nitrogen atom in them. It's the same thing. It's just less dense in interplanetary, intergalactic space.
That's
There's
actually
nothing qualitatively different about it. It's just a quantitative difference.
what you just said is incorrect. There is no vacuum in front of my nose. I don't know why you would say
There
something.
is.
That's so
Between
silly.
every two oxygen molecules, nitrogen molecules, whatever molecules of air, there's a vacuum. If that's the only sense in which there's a vacuum. There's no
You're
place
talking about
in
a
the
pressure
universe where
differential.
molecules aren't running around.
John, you're talking about a pressure differential. When I say the word vacuum, I'm talking about empty space. There's
Okay, there's
nothing
empty
out there.
space
Yeah.
between
So I have
places where there are molecules. If you want to call that a vacuum, that's fine. It's not what we usually call a vacuum because if there's stuff running around in that region, we simply say there's stuff running around
So
in that
therefore,
region. It's not a
with that
vacuum.
logic, I have a vacuum between like my toes and my ankles. Like, what's the point of? That's not what you
Well,
would call a
I
vacuum.
think it's stupid logic, but you're the one who
Yeah,
wants
because
to apply it.
you want me to appeal to
John,
that
check out my
definition of
explanation.
vacuum. Any difference in pressure is a vacuum. I have a vacuum between the floor and the ceiling. But that's not what I'm describing, dude. We're talking about deep space.
Okay, so tell me again what you think is different about deep space than the space right in front of your nose.
Yeah, deep space claims massive, large distances with nothing in between the particles.
Nope, not
That's what a
true.
supervoid is. Yes, it is.
Large,
Why are you
very
saying
large
no, not true?
distances.
Can you please Google
When you
supervoid?
say massive
Please
distances,
Google,
what do you mean?
dude.
What do you think the
Google.
average distance
I
between
want you to
particles?
look this up. I want you to look up the KB supervoid, and you tell me how many particles are within that region.
Well, if there's one, then it's void.
Yeah, one
If there's
particle.
one lone particle roaming through there, then it wouldn't be a complete
occupying
vacuum in your
millions of light
sense.
years. You have one
I sent
particle
an
occupying millions
explanation.
of light years, and that's not a vacuum, apparently.
I sent an explanation.
You know what?
So
You
you
guys
guys
don't
think
even know what your
you've been
model
out there,
says.
huh?
I don't know if John knows what a KB supervoid is. I don't know.
And I don't think you know what the difference between vacuum and deep space is. That's simple.
Okay, so I see that the KBC supervoid has a density that's about 20% that of the average density in the universe. That's a little bit lower density than we find everywhere else in the universe.
Everywhere else, you claim a vacuum. Everywhere else, you claim
No, there's
empty.
not a vacuum anywhere.
I never heard anyone say there's a vacuum.
Pressure anywhere.
As a
Which
vacuum.
definition of vacuum are you appealing to now when you say there's no such thing as vacuums, which you described as a difference in pressure like 5 minutes ago?
I never described it as a difference in pressure. Those are your words.
You said there's a vacuum in front of my nose.
Well, I said if you want to suggest that the places
I hear you,
between
Omnivore.
molecules are vacuums, okay. I mean, that's not what we usually do. There is no such thing as a vacuum when you look at regions. You say, what's the average density in this region? There's no place where the average density in that region is zero. No place.
So my question is this: what do you think is between particles of molecules of gas in the air? What would you say is between those? There's a question to electric.
I don't know.
A lot of people, when they're asked that question, say air is between the molecules.
Yeah, I
think
know.
that's
But you can't say that.
Are you
because-
trying to? So he's trying to mischaracterize me with other people's responses. That's
No,
fine.
no,
We don't know.
No,
Well,
So,
you guys
my
don't know
answer-
either. Wait, I got an answer. When I say I don't know, neither do you guys. You guys can't explain what space truly is. That's why you do all your dumb experiments.
Says, I'm sorry. You're saying that nobody knows what's between two atoms? Yes.
No, like you guys have trouble figuring out why there's such thing as, these what you're considering a void. I don't think there's a void there. I think
So-
everything has physical tangibility.
So between two gas molecules in air, there can't be air between them because that's just more molecules. There has to be either there's nothingness between them or like quantum foam or something, some non-nothing substrate, right?
Yeah, I was trying to describe that before with quantum entanglement. That
It's
there
not
is
quantum
resistance.
entanglement.
What?
It's not entanglement.
Let me
So-
just finish what I was saying instead of trying to immediately hand wave it.
No.
So I was trying to describe this before with quantum entanglement. When you guys claim that there is space between particles, and this is like, empty, this is like the real null void, that this is zero pressure. I think that there's still resistance happening. This is what you claim is happening with quantum entanglement, that there is a resistance between the two particles, even though it appears to be in a quote unquote vacuum.
I don't. Okay, so that's not how I understand it, but okay. But the point is, there is whatever the substrate is, whatever there is when there's not an identifiable particle. There's quantum foam, which is the periodic creation and destruction of particles for very short periods of time. There is, that produces the Casimir effect. And there may be, I'm not big on string theory. I'm certainly not qualified to discuss it, but it may be that there is a substrate of these micro strings, whatever. So, there's, I see the question, Asia, but I have to read that. I haven't read it. When we're talking about vacuums, so, instead of having an argument about it, because it doesn't get us anywhere. Saying space is a vacuum is something you can say as long as you're not being either incredibly technical and you're talking to somebody who's not going to be incredibly pedantic. Compared to sea level at Earth, where roughly I am right now, there is certainly a heck of a lot less pressure on the moon.
Yeah, we're one step closer to finding out who you really are.
Yeah.
I'm just kidding.
Close to sea level. Go nuts. So, certainly comparatively, we can say that an area with very low pressure is something that we would consider a vacuum, as in a vacuum chamber. It's not that you literally get every atom of air out of it, but you have many, many fewer atoms of air or molecules of air inside that chamber once you've pumped out as much gas as you could. All right. So if we're talking about vacuums in that respect, fine. But if we're just talking about, whatever it is that is between gas molecules in whatever pressure, the answer is still there's got to be either there's nothing there between them, or there's some quantum field, or a substrate of some sort between them that we don't, I don't really know.
Yeah. No, the second part of what you just said right there.
Yeah, but
Exactly.
I don't think we know how to characterize that, but I don't think we have to. So we know how light travels. We have extremely good reason to think that the redshift that we see from external, from distant stars and distant galaxies is in fact due to the Doppler effect of them moving away from us. We've got
I know. I know. That's what you guys claim is going on, so you can get your big vast universe theory across to people. I get it.
Yeah, but if you think we don't have good reasons to think that, and we should just say, well, because we can't go there and touch it, we can never know. That doesn't seem like a better answer.
Hey, that's not a steel man of what I said.
No, okay. Well, I mean, you said we can't go out there and touch it. I thought I heard you say that.
No, what I provided was another reason light can shift towards the red part of the spectrum.
So
what reason? It's the scattering of the light due to plasma, due to charged particles as it passes through your supposed vacuum.
Is that a thing?
Well, the idea is if there is just two lonely charged particles in a vacuum, is that going to change the intensity of the light when when it becomes a part of the field that's being altered because of the space between the two particles? Like, that's creating resistance. That's gonna lessen the intensity.
So I don't think so. I don't think that actually works. I think that this is, and I mean, typically, I don't know what you're referring to here, but typically, charge doesn't affect photons. That's number one. Like, you can't bend a laser with magnetism.
Well, hold on. I've heard this claim before. Hold on.
Yeah, there's something called the Hall effect, which is a very specific case.
Yeah, the Hall effect isn't about bending light. That's another thing.
I'm just saying that yeah. So right. So for the large part, no, I don't think charge can be responsible for the redshift. Or at least if it is, it's not. I don't know how. Somebody may have a better idea than I do, but
magneto-optical effects in materials. That's what they call it. Hold on, I'm gonna get an actual article about this. Oh, John knows about it.
That's right. I don't know much about it, but I think you're right.
Yeah, I really appreciate you too, John. You're kind of like top 5 to me right now. The way you're able to understand points immediately, I appreciate it.
Thanks.
Omnivore understands immediately, but he'll still fight with me about it.
I mean, typically speaking, I don't think there's a good reason to think that there's some sort of charged element in space that is creating this effect. And just keep in mind that we can always appeal to some unknown thing or some undetectable condition.
It's not unknown. So the Electric Universe guys, like what's his name? The guy that did Nicholson and the Morley thing, the interferometer stuff. His whole thing was about the luminiferous ether, that all the lights in the sky are due to plasma physics, and it's just like a big electrically charged field.
Yeah, I'm aware, but I think
I
don't think those Electric Universe guys have solutions for anything. I think, to me, it seems like
yeah, they ditched the effort, and I think that if we're going to actually move forward in our understanding of the cosmology, you shouldn't have ditched that effort entirely. Like, yeah, we observe things that appear to have charge in space. The sun is plasma. The sun creates a magnetic field. The stars are subject to all kinds of magnetic things at this point. Dude, I just read an article recently that tried to explain the rotation of galaxies using these galaxy-sized magnetic fields. So the leading physicists are not willing to ditch the idea that these things are, just in an empty vacuum and they have no charge.
That's fine. So maybe somebody can explain the rotation of galaxies with magnets. But usually, when I see these articles, and I'm on a list of, I don't know how I got on it, but I get sent white papers in my email from all kinds of ether physics and these weird papers. So somehow I got signed up for it. But the point is that every time I look at a paper for this, they're usually not good. They're usually the papers that are out there. I'm enough, like I can read through them and I can be pretty sure it's crank science. So my understanding of the electric universe, guys, is that it's it doesn't actually solve anything. So if somebody is doing good work in that dimension, in the electric dimension, then I haven't seen it, but more power to them. I just don't think right now, I don't think the evidence is there.
Well, this certainly went better than just a whole bunch of nut and what about sunsets? So that's cool. Typically good. The other thing, dude. All right, so we're talking about what if these points of light in the sky are due to some kind of like plasma? Like, can you apply Coulomb's law to explain the orbits?
Well,
do you think that might be a possibility since it is an equivalence principle?
So the star. No. I don't think.
No, not even a chance.
Yeah, not even a chance. I mean, that's my thought. I don't think there's even a chance.
We can detect magnetic fields. That's something that we have all kinds of tools to detect. So if there's these massive, super powerful magnetic fields that are somehow related to these orbiting, whatever they are, we can see it through a telescope. So it looks like a ball of gas, like Jupiter, right? So we can see it. We know what it looks like. It doesn't look like plasma. We know what plasma. We do have a pretty good idea of what plasma is going to look like. It doesn't look like that.
So, yeah, it does.
Okay.
Well, I mean, what are we talking about? Are we talking about stars or distant galaxies? What in particular? Just everything?
Stars are plasma. Jupiter is not a plasma.
Yeah, right.
Oh, I thought you were talking about the stars. No, Jupiter does not look like a plasma. My bad.
The moon.
Yeah, I didn't know you were talking about Jupiter.
The thing I think I would say we know for sure is that we know how stars work. We know what they are. We have a very detailed understanding of the life of stars. You're not going to come up with some alternate, explanation for stars being points of light or something that aren't the result of nuclear fusion and gravitationally collapsed balls of gases, basically.
Well, if you don't think it's possible to come up with any alternative theory, then
I say go ahead and try. I'm just I couldn't be more confident that we will never have a better theory than that. We may know more about them, but just like with Newtonian being eclipsed by quantum mechanics and relativity, it doesn't change the fact that the solar system is a bunch of planets orbiting the sun, all of which have gravitationally collapsed into spheres.
All right, so then you're admitting that what are we even talking to you about it for? You're not willing to entertain things.
Well,
I am. I'm totally willing to entertain things that are possible.
Oh, great. Oh, I'm so glad. Let's talk about it.
We have a good example of a star nearby, so that's a pretty good working skeleton of stars.
Was someone talking?
No theory is ever going to come up that makes us realize that the solar system isn't a bunch of planets that have gravitationally collapsed into spheres orbiting the sun. That's never going to happen. I would bet everything I own on that proposition.
And whatever they come up with in deep space, whatever they come up with in deep
stability,
and whatever they come up with in deep space cosmology will still comport with our
these
solar
are just
system.
bubbles? What if it's not mass coalescing into a sphere to create a point of attraction in the center, and this is what's bending space-time? What if it's a bubble? What if these forces of attraction are coming from the medium that the bubble is in,
knock
rather
yourself
than the
out.
bubble itself?
Yeah, knock yourself out.
I'm sure you would. If I paid you, you would know how to help me figure that out. I mean,
no, yeah,
yeah. There's a way to model this idea.
I wouldn't
we can
take the
certainly
money.
try. We can certainly try. Yeah.
I have a question. So, Electric, do you think that there is? I don't know how. I'm trying to figure out how to put this, but
the sun is a bubble. Yeah.
No, not that. No, I'm just saying that there are going to be, so when I was poking at Tapioca Weasel, and I was ordering him to get me a Bose-Einstein condensate, smuggle it out of his lab, and get me some of it. And
isn't that not real? Isn't that a concept?
No, it's real, but you can't get it out of the lab. It's super cold. It's like the eighth state of matter or some shit. And anyway, he did not even briefly entertain getting me a jar of Bose-Einstein condensate, the bastard. He's bogarting all of it.
What are you gonna do with that stuff? You sound like a mad evil villain right now.
It just didn't. Dude, I would just have it and be like, whoa, but I couldn't keep it because it would. As soon as it was subjected to anything outside of the lab, it would stop being a Bose-Einstein condensate. It probably wouldn't be very healthy to be right next to. I don't know, but I was trying to bullshit him that I wanted a micro black hole gun, and I was doing my best to try to make it sound scientific, and I could not. I don't think he was especially impressed with my line of bullshit. Now, obviously, I was joking, but I could not come up with remotely good bullshit that could stand up to somebody who actually knows quantum mechanics. Okay? I just couldn't do it. Like I couldn't say it in a way that I think was even especially interesting to him. So
yeah, this guy's like, you're kind of putting him in some kind of I don't know. Is he that special? What does he do? What does he do again?
He's a quantum physicist. He works with Bose-Einstein condensates. And super cooled atoms, using lasers to cool atoms, and
they drop atoms in these chambers to see the rate they would fall. They think they know the density of something. They think they know the pressure inside their vacuum.
Not really that, but yeah, okay. So he's trying to. Last I heard, he was trying to take the probability field of an atom and split it so it's literally meters apart. So the atom is in two places at once, meters apart. Anyway.
What?
Yeah, I know.
That's quantum entanglement, isn't it?
Yeah.
Ah, dude, we got to get him in here. I got a bunch of questions for him.
Yeah,
he's gonna confirm this plasma physics.
Well, anyway, okay. So my point is that there's going to be some theory that when you're talking to somebody who really actually holds a degree in this stuff, which John does, there's going to be a point where the person who actually knows this stuff is like, I don't think so. And just because you think it's a viable theory, like I thought my miniature black hole gun was a pretty cool idea, but I couldn't reach enough bullshit to make it stick.
Maybe you know something he doesn't know. Maybe he's so rigid.
Not about quantum mechanics. No, I don't think I do. And
these guys are indoctrinated into practicing their method of understanding the theory. That doesn't mean that he's gonna just be able to tell you whether or not you could have a mini black hole gun. What if he's exploring in the wrong area of the field?
Well, that wasn't.
Okay. I think it's possible. Hey, that might be a thing. I don't doubt it.
Yeah, no, sure. Look, all I'm saying is that I think the electric universe theory sounds good to people like us, but when you start getting into, the real astrophysics dudes, I don't think it holds up. I don't think that when you start going, like they know a lot more about the reasons why we think things are like they are than we do. Like I can't tell you all the reasons why we don't think there's this pervasive medium in space that is slowing down light.
So they talk about how there would be a three-body problem between the Earth, the Moon, and the Sun while it was forming in an accretion state, right?
Okay.
That the Moon never would have formed. It would have been pulled towards the Sun or the Earth at some point, rather than itself.
That right. As far as I know, we're thinking that the moon is
Right. So you guys are proposing an amount of mass within the sun and within the earth that would literally be tearing the moon apart. And that's not what happens. So what if it's not, what if it didn't form due to the mass inside the sun? What if there is no mass inside the sun and it's a bubble?
well.
Because that's the only way we've ever been able to demonstrate, spherical surfaces in nature is you need surface tension and bubbles. This model that you can have spheres form due to, gravitational wells is still yet to be truly confirmed to be the case. My bad, I trailed off. But yeah, that's the idea, dude. What if it's all bubbles? Simple stuff.
Okay, well, like I said, I don't know that I'm the guy to weigh in on that, but I think the people who would have a serious opinion on that may have already weighed in on it, and they don't think so. So I don't know. I know. I'm not sure.
Any paper you would submit about it, like trying to get it peer reviewed, the moment you say something like that, you're not getting published. You're just going to look like a cuckoo.
If what you're doing is just spouting what if it's a bubble, what if it's a bubble? Like that's not an operational hypothesis.
Well, yeah. This is where you start applying Coulomb's law. You invoke a amount of charge happening due to this, superfluid vacuum. You have a superfluid vacuum that's moving all these super cooled particles, creating the resistance, which is because of quantum entanglement. Now you don't need the entire medium to be particles.
But what's the motivation for? What's the motivating flaw that you are addressing with your new theory?
The flaw that nothingness can affect the path of light.
Well, I don't know what you mean by that. I mean, if there's you to get a paper published, you have to first kind of talk about, in an introduction, you set the stage, you explain things that we know, questions that remain about things that we know, in order to make clear, A, that you understand the current state of events. You're not just spouting off. And then number two, to set the stage for your new theory, and which will explain how it addresses some problem with the current status of our knowledge.
I admit, on Discord, just trying to talk to two people at once about it's going to sound like spouting off. I'm not presenting you a paper or any presentation. I just want you to think about it and speculate with me and see where this idea can possibly go if it were viable at all. Because I really think that the problem with dark matter, the problem with the supposed density of the suns, the density of the stars, is that that's not how really massive they are. I think that's one of the wrong presumptions we're making. We're presuming a formula is going to work with gravity. All right, you're giving a value to the mass of the sun, and it literally never works. So what if the mass of the sun is different? What if the force is acting?
Well, when you say it literally never works, that's just not true. I mean, it works. It works perfectly to within our accuracy to say anything in terms of how the solar system works, etc. So when you say it literally never works, I mean, that's nuts.
I think saying that it works perfectly is nuts, dude. They invoke dark matter at this point. It doesn't match their
No,
model.
they don't. There's never. You don't need to even talk about dark matter to understand everything about the solar system.
This has everything to do with dark matter. It's the amount of mass you think is in these points of light that you say are, galactic clusters. Anyway, I think you understand what I'm getting at. So
Yeah, no, I mean, it's kind of a MOND, about MOND, right? Modified Newtonian dynamics thing.
Yeah,
which basically just says no. It is just we're seeing all the mass. It's just that gravity doesn't work the same. You're kind of going a different way. You're saying no, it's not we think there's that mass, but it's not there. I mean, that's kind of silly, really. It's just saying the same thing, that the mass we see, that we evaluate, doesn't have as much gravitational effect or has more gravitational effect or whatever than we think it does. In other words, Newton's law of gravitation has to be modified, basically.
You know how binary star systems form? Like they say a star dies or something like that?
Well, binary systems form basically, they're just, if Jupiter were a little bigger, we'd be in a binary star system, right? It's just a matter of how much gas ends up in the central thing, how much ends up in the bigger gas giants around it or whatever. So binary stars are the most common kind of star. Most stars are binaries.
But one of the stars typically already went through some cataclysmic event, so they consider it like a dead star or a dwarf star, right?
Sometimes, not always. I mean, eventually that's
So
going to
here's the
happen.
crazy idea. My bad, I got excited. What'd you say?
Well, I was just saying that sometimes, I mean, it's often the case that the two stars have different, well, it's almost always the case that the stars have very different masses. A massive star doesn't live as long as a less massive star. And so, it'll turn into maybe a neutron star, maybe a white, anyway, the evolution is different for both the stars. So they'll be different.
Right, now imagine we're literally in the center between these two stars, this binary star system. You can picture that, right?
I guess. I don't know. You mean the center of mass or halfway
The sun
between
and
them?
the moon is our binary star, dude. You got to think about it. You got to look at it from this wild perspective to understand why people.
Well, you just said
don't
in
just.
between. You said in between. I didn't know if you wanted me to be at the center of mass of the two stars or halfway between them, or maybe it doesn't matter. But yeah, I can imagine being in between them.
What if the moon is our binary star?
Is our binary? What does that mean? I mean, I don't know what you mean by
We see the
that.
sun and the moon doing this perfect binary star system orbit around us.
We
We're a
do?
center point. What if
No, we
we're
don't.
the center of gravity? All right, I think you understand.
Well, I mean, I think I know what you're saying, but now you're just talking nonsense because we know about what the moon does. We know what the sun does. We send probes to them. Right? We know how far they are away. We know what our motion is with respect to them, etc. So all that stuff. I mean, if you're going to propose some theory where the sun is some distance different than what we know it to be, you're just wrong at this point. That's directly observed fact material there.
I'm not really trying to invoke any distance. I'm just saying, what if that the Earth is causing the orbit of the sun and the moon, and it's literally the same properties of a binary star system. Like the moon is the
Yeah.
binary star to the sun.
Yeah.
Something
Well, it
like
just isn't. I mean, that we know for sure.
Well, at least you were willing to listen and not just completely ignore it. So that's good. Look, I think about all this stuff. I know what the globe, likes to make people think about it, and I think there's definitely other options.
Well, I mean, I'll just point out one of the things that I always think is interesting is that if, we look at Jupiter and say, oh, it has the red spot, it's got striped planet, Saturn is the ringed planet, Mars is the red planet. If people on Mars or any other planet looked at the Earth, they might say it's the blue planet, but most likely they would say it's the double planet.
Well, it didn't sound like you flat out rejected it, so that's cool to me, man.
Well, I'll let you think that. Of course, all I'm saying is the moon is enormous compared to the Earth, compared with any of the other moons. No other planet. Well, that's not quite true. Pluto's moon is also enormous relative to Pluto, so we don't think about that so much. But the moon, being a quarter of the size of the Earth, can you imagine if Jupiter had a moon that was the quarter of the size of Jupiter? That would be pretty amazing.
And that's one thing that always kind of bothers me.
Yeah, that's something
hold
I've been
on,
meaning
hold
to
on.
look back
I was
into
mid
is
sentence.
how they actually
I was mid
measure
sentence.
parallax in relation to the moon.
Yeah,
Okay,
there's
you
Closer
talk.
than the
Never
sun.
mind.
There is like a parallax, yeah.
Well, I want to hear what you said. What you're saying, Shu Bill. Try again.
Yeah, the moon being a quarter size of the Earth. That's always bothered me because that means the moon is, 4 moons equals an Earth. When actually the moon is 2%, 1/50th of the volume of Earth.
Yeah. Well, so I mean, so being a quarter of the diameter means it's a 16th of the area and a 64th of the volume. So you'd expect it to be about a 64th of the mass, and it's actually more like 100th of the mass because it's not as dense as the Earth.
Yeah, the mass I don't know, but I went through the arithmetics, and yeah, it's with the exact rate diameters, and it was 1/50th of volume. So when they say a quarter
Right.
size, it sounds like 4 moons equals
Right.
an Earth. When actually, it's
Right.
if you were it's so and you think about it, it's like a basketball and a tennis ball. Now, yeah, that sounds like, oh, look, you can fit 4 tennis balls across a basketball. But if the tennis ball were made of like a billiard ball instead, a billiard ball, if you cut open that basketball and take 50 billiard balls and crush them to sand, you could pour it inside the basketball.
Yeah, right. That's a really nice thing to understand is surface volume size ratio things, right? Something that's half size is a quarter the area and an eighth the volume, right? You make
And
a
and it
scale
just
model. Yeah.
every time I hear quarter size, it's a 4 moons equals an Earth. I go, no.
Well, that kind of makes sense because you should really talk about either area or diameter. You're really not going to talk about volume because you don't see the volume. You see
Yeah,
the
and
area. Right?
and yeah, with no qualifiers when you say quarter size.
Right. Yeah, that's true.
And that was one of those really fucked up things. The TV show MythBusters, and the red-haired mustache guy. He's supposed to be the math guy, and they were making a mock-up, or they were going to fire a cannon into like a plank, of a hull of a ship. So they did a half size or a quarter size mock-up. Yeah, it was a quarter size mock-up, and so they had a 2-inch bore cannon, and they were firing into these oak planks. And they said the amount of destruction was horrific. And then they're going to go to the 8-inch bore of a real marine cannon, and he said, "Oh, think of that! That's 4 times bigger." I go, "Holy crap!" If you take a 2-inch cannonball and an 8-inch cannonball, that's not got a ratio of mass of 4 to 1, is it? And so it was just bothering that when he with all the confidence goes, "That's 4 times bigger."
Well, it's one of the things, I mean, in engineering, these things are really important. Like if you take a spider, you see these science fiction movies where you have spiders that are 100 feet across or something like that. You can't scale up. If you scale up a spider to be 10 feet, say, and across, it won't be able to walk. It'll break its legs the first time it tries to take a step because its legs wouldn't be nearly strong enough to support its body weight.
Yeah, the same thing with a fly and mosquitoes and gnats. I mean, at their mass, the air is like thicker than pool water. That's why they can stay up. So the air is not tough for them to maintain airborne because the viscosity of air compared to the mass of a fly or a gnat, yeah, it's like nothing. And so no matter how hard we flap our hands or hold paddles, there's no way we could get off the ground. Of course.
It's why an ant can fall from 100 feet and not hurt itself.
In high school, I worked at Red Lobster, and even back then, I would shake my head at the people who send back, like, they'd get king crab. And it'd be a pound and a half of king crab legs, but it'd be one leg, which means by volume, they're getting way more meat than if it was 3 small legs. But they would always send it back, like, nope, that's not enough. Like, you're sending back more than you're going to get in return by volume.
Pizzas, right? That's why you should always get. I'd never buy anything but an extra large pizza. Number one, because they're way better deals, and number two, because barbecued leftover pizza is the best, man. Better than when it came in.
All leftover pizza is the best. I don't know. Well,
not if you do it in the microwave.
Maybe anchovies would be gross.
You can't put it in the microwave. That's the thing. You have to barbecue it.
or at least under the broiler. That's how I rejuvenate
Yeah.
cold pizza.
You mean you don't just leave it on the counter to be room temperature the next day?
You know, I
That's
had
better than
I had to
microwave.
laugh. You know, Sunday is the big football, games, and then Monday they would have the recaps, and the name of the show for the football recaps was called Cold Pizza, and I go, of course.
You know how Norwegians heat up their pizza? They
No.
just put it in boiling water. Like submerge
What?
it in boiling water.
What? Wait, you mean in a bag? Or are you kidding?
No, not a bag. They just put the pizza in the water, in the boiling water.
Pizza soup.
At least that's how a Norwegian guy I know does it.
That's crazy.
Yeah,
That would just turn it to mush. That'd be like making pizza soup.
Yeah, but it doesn't dissolve or anything. It just
Well,
floats
that's
on
just
water.
wrong. Bacon, I had more respect for you than that.
Yeah, video or it never
Oh, he
happened.
showed me a video. Okay, let me ask him for the video again. And then
No,
I'll show
please
you.
no, please no. That we can't unsee that, so don't.
All right. You were talking about the like this ratio between surface area and volume, right? Is that why like clouds don't fall? Like the water droplets are denser than air, but I mean, I'm guessing they're so tiny that their surface area are just way
And you
more.
have, and there's convection currents. Yeah, so
Yeah, I
if
mean-
it's atomized, like out of like a perfume sprayer, yeah, the wind can carry that. It's not going to fall like a bowling ball because of aerodynamic drags and so little mass. Yeah, air is quite viscous and can easily carry them up, and so those convective currents and water droplets in a cloud, are dissipating and recreating all the time. So that's why you see, cloud, looks like the tops of the clouds are kind of like boiling up, but the bottoms, yeah, it's a very, clouds are complicated.
They're really, I was just going to say, they're really complicated, right? But the one thing you know is that there's always drops falling, smaller drops rising. Why do we always see, the rain that comes to Earth is just big enough that it can't be held anymore, right? So then
And
it
it's
drops.
That's how it was.
Uplift, it's that convective uplift, moving the droplets, and there's droplets coming down, droplets going up, and that's where you get the static electricity for lightning.
Right.
That's how I imagine the clouds worked, because at least since I heard that the air in between the water droplets is 100% humidity, that started to make more sense, because like if the cloud gets any colder, those droplets are going to get bigger, and it would fall.
Yeah, and they, what in the like tropical environs, you're in the very high humidities, and you still have crystal clear vision. But in a cloud, you can see it because they are condensed droplets, micro droplets, but condensed droplets, and that's what people don't really understand.
And
Like
if you
when
think
you see a steam engine, venting steam, you can see it. Well, that's because it's immediately condensed. But if you had a jet of superheated steam, it's as clear as can be. And if it's hot enough, you can put a match in it and it lights it.
Right. I was gonna ask where the flurbs are, but I think no thanks is here. Hey, no thanks.
You don't even know how clouds work, you fucking retard. Don't call me a flurf.
You see, they're again with the R word, Omni.
Did you guys hear about the? I tried to post a thing in the chat the other day, and it wouldn't post, and somebody finally saw that, I said, oh, I had in the thing I was trying to post, I said, when the star descends, and the robot saw the TARD, star descends, TARD, and it wouldn't post. It said, that's not
Yeah, it
allowed
does
here.
not like that syllable.
It wasn't even a syllable. There's a space between the R and the D, and an S in front of the TAR.
I know, and you try to lay something out, a little bit technical, where the strength is retarded. It's like, eh.
I mean, I don't know who Omni was there. I think when that happened, somebody figured out what had happened. I thought that was pretty amazing.
Yeah, you see these youngsters, they're ahead of the game, man. With all these, no cap, all this fucking, all these, they want their freedom.
Yeah.
They knew
So
it was coming.
anytime you have to use like retarding velocity, or something where that's the proper adjective, you just spell it turd.
I don't want to get too into it, Bacon, but you could I mean, the thing I thought that was interesting you said the other day is you said that the sun for a solenoid would both be refracted in all, in both positions, both directions, opposite of each other. And then I tried to imagine that, right? Like I tried to say, okay, I tried to think in my head, okay, now imagine.
What did I say?
You said, well, when the solenoid is refracted up, for somebody who's on the opposite, it's refracted down. It's in a refracted position.
I don't know. Was that? It might have been me. I don't know if Bacon
No, it
was
was Bacon.
here for that. Okay.
That the sun is
I
refracted
know that.
down?
I know that voice is Bacon.
I never claimed the sun was refracted down.
I asked you, and you said it would be refracted for both people. Right, so if somebody's watching it set, then the person who's watching it rise, it should be, remember the time zones, it should be in a different position, which would be the position, the sun on the ground, et cetera, et cetera.
Yeah, no, yeah. It in both cases the sun is refracted up, but that makes the sun rise a little faster and sets a little slower.
Earlier and later.
Exactly. So
Yeah, because it's identical.
Later.
It's identical.
Exactly. So you gain time in both directions of solar noon. So solar noon still happen at the same time, and even
Wouldn't
if
that
it didn't,
wouldn't that just make it no change then? Wouldn't that just put it in its actual position?
No. It's always refracted up.
No.
So if it's refracted up when it's setting, and it's refracted up when it's rising, then it rises earlier and it sets later, which makes so the solar noon position doesn't change. Of course, it changes vertically, but that's not like that doesn't change where solar noon is. Solar noon is already the highest position on the sun.
Now the part that I was but now the part that I was imagining is if somebody was lined up, different people at the same exact time, all the way across where the sun rises and sets, who's it going to be in the not correct position for?
If you had a row of people on the terminator line, the refraction for all of them is the same. And if it's very close to the horizon, in all cases, then it's going to be a half a degree for all of them and in the same direction.
Yeah, when does it come into play? Because it doesn't come in for the guy at noon. So you just line all these guys up. They're in a line. They're all staring at the sun. They freeze frame time. Who's it in the wrong position for, and when?
It happens when you're in a place where the sun is near the horizon.
Any celestial body near the horizon is refracted a half a degree. Any celestial body which is like above 40 degrees or something, the refraction is very, very slight. And if it's straight overhead, refraction is absolutely zero.
Yeah, I mean that's the claim, right? So now the guy
that's empirically determined. That's been empirically determined for centuries.
No, I mean that's the claim. That's just the claim.
Well, by every industrialized country and academic, for centuries.
Whatever, all of them. They all claim it. Yeah. So if you're just standing at wherever you're.
No, they all measure it.
That's it. No. Well, you're not. How you? Yeah, that's my point. How are you measuring it? So now, if you take 4 steps, forward, 5 steps forward, 6. How many steps forward until it's in its actual position? Now, for everybody who's standing on that terminator line, looking at the sun, is it jumping? Does it jump to 2 degrees at one point?
No. It's a
Think
gradual
about
thing. As the sun approaches the horizon in the evening, its bottom edge starts slowing down a little bit before its top edge does, because its bottom edge is closer to the horizon. It's getting refracted upward more than the top, and that makes the figure of the sun look slightly squashed into a horizontal ellipse. And that continues all the way down until it finally sets.
Yeah, I
But
know. That's
when
just the
it's
claim.
at the
I know the
horizon, it's a
claim,
half
but
a degree.
yeah.
That's
No,
not,
by the way,
I
I know
don't
the
know what you
claim.
mean by you know the claim. The point is that this is a very simple process, and it explains everything we see. Oh, I guess we lost
Yeah,
him.
the claim is it's
Oh
going
no,
down,
okay.
but being it's going down below you, but being refracted up. When you can simulate the same thing just going away, then it would linger in the air at
No,
sunrise
you
and sunset
can't. You
because it's
can't,
going
because
away.
if it
Yeah.
were going away, it would get radically
Yep.
smaller.
Yes. So all I'd have to show you is like a high altitude. I mean, listen, I don't want to debate it, but all I'd have to show you is a high altitude like drone footage watching the sun set into the atmosphere, not bottom up. Yeah, for you to agree that it's not going down.
No, if you
Tom,
take a
let
drone,
me just
if the
interject
drone,
here real quick. Let me just
if you have the
interject
drone
here
up
real quick.
there, if you have a drone up there to say 1,000 feet and it's just staying there, the sunset will look completely normal.
Yeah, it'll just stay there. The sun will just
No, it will the sunset
stay
will
there.
be completely normal.
I just wanted to quickly
What if I
introduce
show you the?
myself.
I mean,
I'm a
you got
representative of No Tank.
Yeah, the sun will
So
still
any
set and
questions
night
to
will
him,
still
please ask
follow.
me.
All right, listen, I can just show you the videos if you want them, but So that anyway, I know the claim. I know that's the claim. So like for for Bacon and whoever else are imagining that it's getting refracted at the horizon to appear like it's not going down. I just imagine these people standing along the line, staring at the sun. When is it? And if it's going both, for somebody who's one guy's facing west, one guy's facing east. I mean, when does it? They both see the sun. They just freeze frame time, and there it is. They see it in its position. I don't know how it's hopping up in the air for somebody.
What?
Well, the fact that you use the word hopping says, yeah, there's no point with talking about this.
Hopping.
Yeah, that's something you're just not understanding. This is not rocket science. This is really simple stuff.
Yeah, I'm not
Refraction
confused.
gets a
I
little
mean, I'm not
greater as
confused.
things approach the horizon. That means that as they approach the horizon, they start to slow down a little bit over what the constant rate that they've been showing all day. Their size, which remains constant all day horizontally, starts to get a little bit smaller vertically because the bottom part of the sun or the moon slows down before the top part does. That's not hard to understand. I mean, you just have to
What's funny, Bacon?
exercise a little bit of
What I
brain
never.
cells.
Yeah. You know what I realized, Bacon? With the the anti-flat earther, like you guys, right? The other day I was saying, we were talking about the solenoid. Not that I give a shit so much about any of it. I mean, but you guys haven't seen like what the flat earthers have seen or won't see it. It's like because like the thing like I had mentioned to you, Bacon, about obviously seeing solenoid eclipse where both the sun and the moon are above the horizon while the eclipse is occurring. All flat earthers have seen it, and you've been in this for years and never seen it.
Well,
That's
the
bullshit. You've never
the
seen
weird
it.
the weird
I've
thing.
seen
No,
it.
I think he's talking about like footage, but that's not an issue. Like if that was the issue, then it would be just very easy for any of you to share the video with me. Why that doesn't happen?
It's really
I mean, I
hard
did.
to share a
I sent,
video of a
yeah, I sent you the
solenoid
videos.
for the simple reason that the sun is in one place and the moon is diametrically opposite in your visual space, right? You have to turn around 180 degrees. And then I've seen one video that did a pretty good job of that, showing the moon setting as the sun is rising. That's really the way to do it. But even then you have to believe, right? Because you're not seeing the sun and the moon at the same time. You can't.
Well, you
Oh,
use two cameras.
Well, no, but you can just turn the camera like if you do that in
No, I
in
know,
2 seconds.
but I don't know
Yeah,
how
like the
many.
video I sent to
I have
Bacon, the guy just
literally
turned the camera.
seen
He just
one
turned around.
example of that. I think I've literally seen one video taken by a couple people who do show the sun and then show the moon.
Like
It's
you could
hard,
just Google whatever you can not Google it, but you could just search whatever I tagged you in Bacon, like and just be like, oh, where did no tanks tag me?
I
You'll
already
find it again.
searched Selenita many times, and most like all videos I found are just like, are there? It's just the moon.
Most of them, right? But I've seen plenty of videos that say, "Here's a selenelian eclipse," and it obviously isn't, because there'll be a city in the foreground that is all lit up with its night lights. It's night. It's not. It's not morning. It's night, and the moon is close to the horizon, but it's not at the horizon. It's not a selenelian eclipse.
Like I don't deny that you could see the sun and the moon at the same time. But I want to see one. Like if you want to see it's impossible to
Video
go,
of it.
then
Yeah, I
I'm
mean, just
gonna
look. Yeah, just look at the ones
just
I sent you the other day.
Obviously
oh,
possible. You can.
where?
They happen, and
I mean,
it's
just look up your
obvious
name.
how
I
they
think.
happen.
Yeah, but the thing is, if the sun and the moon are too high to be possible, even with refraction, I'm not gonna deny that. But I need to see the video so I can pull up some numbers and see if that's actually too much for the globe or if that's compatible with the globe. But I haven't seen one so far, so I can't pull up the numbers and claim that it matches or doesn't match the globe. Maybe I didn't dig too much, which is true. I haven't spent that much time looking into Selenium. But if you guys claim you've seen this many times, then just share it. It's not my job. You think it's a good argument. You claim to have seen many times, so just go ahead and pick one and share it with me. I mean, what's the deal?
Bacon,
I'm
why
not
not
even
just be
enough.
a flat earther? Why not? Just do it.
I tried.
Well, that was just to bring up.
They don't want to allow me.
That was really just to bring up Bacon. That was just to bring up Bacon. I shared that to you the other day, right, or whatever day that was, and it was around that area where I just tagged you, somewhere around there. And you're like, I never seen it, and then I only brought that up to bring up that the high altitude drone footage that every flat earther has seen of the sun setting into the atmosphere. You guys just claimed again that you've never seen such a thing, that it would just continue to go down. The sun would disappear bottom first. Again, you said it. It just sticks out to me.
It's because if you've ever actually watched a sunset, you know that sunsets involve a sun that is not changing its size except for a tiny little bit of vertical squash, maybe, as it sets from fully above the horizon to fully below the horizon. I mean, it's nice if you live at the ocean, as I do. I can do that every night. I can see that happen if it's a clear night. And it happens. I put a
but you see it on the
thing
opposite
there.
side of me. You have a different. You see the other. Wow, you only see the same. You see the same size of the sun, but you're on the other coast.
Doesn't matter which
beach,
coast you're on.
beach.
You see it rise. It's just the reverse of sunset. I put the little two sunset thing there in the chat a little while ago. Everybody knows that when the sun sets, it looks like the panel on the left. It does not look like the panel on the right. And if you adduce evidence that it does look like the panel on the right, you're just being a dishonest motherfucker, because you know what's going on there. It's attenuation, glare, that kind of thing. When the sun sets, it looks like the panel on the left, and the only way to explain that is that the distance to the sun is not changing.
I did not expect to hear
In reality, the distance is changing, obviously. But yeah, I mean, what do you think? Do you think it's CGI then? You think the videos are fake?
No, usually what they are is that they're done with overexposure. An overexposed sun is glary and looks big. If you want to take pictures like I've taken pictures of the sun every half hour from sunrise to sunset with a proper solar filter. You can see the sunspots. You can see the edge of the sun very crisply defined. And the size of the sun does not change by even 0.1% from dawn to dusk.
You mean horizontally, right? Because vertically, I'm pretty
Horizontally. Horizontally.
In width,
Right.
yes, in width, left to right, because refraction is only a vertical phenomenon.
Yeah.
And when I
doing
observe the sun many times for azimuth, and I always use the left edge of the sun, and I can use it any time of day. And there's only one solar diameter quoted in all of the ephemerides. Then I look it up per day because it'll be a couple of arc seconds different in overall diameter, because it's a full arc minute different from perihelion to aphelion, and of course that's 60 arc seconds over 6 months. But from day to day, or the course of the 12 hours of daylight, yeah, zero change.
What? Oh, come on, man.
Horizontally, yeah. There's. It's almost impossible to measure any horizontal difference in the angular size of the sun.
I just posted the latest results from my Sundays project. I'm taking pictures of the sun every Sunday, measuring its size and comparing it with the prediction from the heliocentric model, which has it maximum size of 0.542 degrees in early January, minimum size of 0.524 degrees in early July. And you can see there my eyeball estimates of the size of the sun from my pictures. That's like 2200, 2300, 2400 pixels in diameter. And then the green triangles are a friend of mine wrote a program to automatically determine those things. And he typically got values that are 1 or 2 pixels different from what I did by eyeball. And then the green line, there is the heliocentric prediction.
Yeah, it just amazes me. Like I tagged you in all that stuff, and I said, here you go, but you can go through the Flat Earth archive of David Weiss.
I'll check the video.
And you said nobody's ever cited this stuff, right? No, you don't have to check. You don't have to check it now.
No, I will. Let me just
You don't have
finish
to ever
my.
check it.
Well, anybody
I don't
quoting
have to. I'm just telling you, I will.
Anybody quoting David Weiss has a bone loose.
Well, David Weiss is quoting Taboo Conspiracies, and Taboo Conspiracies is quoting. Let me see who he's quoting. Another guy who's quoting another guy who's quoting another guy. So.
Well, how much more authenticity do you want?
And Taboo Conspiracy, he always comes up with these emails. Oh, somebody who wants to remain anonymous. Yeah, there you go.
One time.
No.
It's like when you go to the doctor and say, well, a friend of mine.
He wants to know, like, what do you do if you get something stuck in your, in your rear area? I'm asking for a friend,
It's not hamsters. What is guinea pigs? No, what is it?
Hamsters.
No, what was it? It wasn't hamsters, but it was something like hamsters. Oh, you know.
What are you talking
That
about?
really happened. Yeah, somebody went to the doctor. I can't remember.
Bacon was saying it's like when you go to the doctor and you say, hey, I'm asking for a friend, but what do you do if you got something stuck in your ass or, some weird ailment?
That's really what we were talking about?
Yes, that is the topic of the room. Please address it appropriately if you want to be involved in the conversation.
I'm sorry, I must have missed something.
And really, the topic was more. What I was pointing out was so like a few of the guys here on the globe side, they said they've never seen examples of discrepancies within the Selenolian eclipse or seen even a demonstration of it. Where it's the impossible eclipse that they claim is an impossible eclipse, but they say it's not. Now it never happens. They've never seen one. And then I said, maybe you guys have also not seen. What?
No thing. Why did I say I haven't seen?
You said you haven't seen one within the range that would debunk the globe for you.
No, I said I haven't seen one where it shows both the sun and the moon, right? And then you shared me a video where that doesn't happen. Thank you.
By the way,
a little list. That's a little list where you can get in. There was like 3 videos there, and what you can do is you can go into that, and it's just an archive where he archives other people archiving their experiences.
You gave me a YouTube. You gave me a YouTube link, and I watched the whole thing.
And
there's 2 moon
news,
settings, and one is repeated.
Gerbil, not hamster. Gerbil. Sorry.
Yeah, and then I was pointing out the other, but it was the point was also to point out that so now I don't know, maybe you've seen it before, Jesse Electric, right? Have you seen where somebody took a drone to a high altitude and they watched the sun disappear into the distance without setting bottom up? Have you ever seen that? Because the non-flat earthers have never seen a demonstration of this.
Well, I've seen the video. It's nonsense for the reasons that I said. The sun doesn't do that. You can get a video that's overexposed that shows that, but everybody knows that's not the way the sun sets.
Can you ask that question again, though, Tanks?
Yeah, have you ever seen a video where somebody took a drone to high altitude and you watch the sun kind of just disappear into the atmosphere without being obstructed bottom up?
I've seen that myself in real life. But the
Yeah.
argument is that you need a solar filter, and that the light from the sun is getting scattered in the atmosphere, so the solar filter would stop that.
Yeah, but at least you've seen it. Yeah.
Well,
These
that's not
guys
the
haven't
it's not
haven't
the
seen it.
argument. The solar filter doesn't stop light being scattered in the atmosphere. The problem is that when you take pictures of sun, overexposed pictures of the sun, you end up getting a glary, blurred out, much larger looking spherical kind of thing and you know that you're not getting the size of the sun because it doesn't have a crisp edge.
Yeah, the idea is that, in all instances that you're looking at the sun with a solar filter, that it's going to get obstructed by the horizon. And I don't think that's the
Well,
case.
that's not
I think the
necessarily
sun,
true either, right? Because I mean, there can be
right.
clouds
So
that
sometimes the sun
that's it.
fades out even with the solar filter. Yeah.
Yeah, that's right. That's right. I mean,
I've seen
when
that.
on a clear day, the sun always does what we all know that it does.
Right on, dude.
Yeah, when you see the sun sort of go, to attenuation by, the clouds and weather, it appears to, by the attenuation, it gets smaller to its true size, and then it becomes just obscured by clouds, and they go, oh, see, it didn't set, it just got smaller and went away.
Well, have you ever? And again, every flat earther has also seen this. I don't know if you guys have seen the sun disappear bottom up above the horizon. You guys have seen that, right?
Yeah, but once again, I mean, the point is these things only happen with tricks of some kinds, or just, somebody posts a video that has some clouds in the right arrangement. Every time you take a properly exposed video of the sun setting on a clear day, it does what you and I and everybody here knows the sun always does.
I think you guys need to watch a video of my flat Earth kitchen. I think that's what you guys need.
Well, and one thing's for sure, when we see the sun on a crystal clear day setting, gets cut, gets a little bit squashed by the refraction, hits the horizon, then gets cut in half by the horizon, then disappears, and night happens. When you see that, it's not like it only does that sometimes. And so you have marine layers and cloud layers, you see something a little different. Yeah, it's still doing the same thing every single day, and you have marine layers and cloud layers and all sorts of other atmospheric things. And I've seen, oh, David Attenborough is showing the sun getting smaller. No, he's showing the sun overexposed, going into a cloud layer where it's no longer overexposed, and it looks like it got smaller. Well, and then it didn't really set because it was just even more cloud layer. And they say, see? And I go, see what?
Well, that's what you would expect on a flat Earth. I mean, that's what you'd expect.
Yeah,
the prediction
but there again, if it doesn't happen on a clear day, where you're saying it only happens sometimes, it toggles in and out. Oh, it on a clear day it's a globe. On a cloudy day, it's flat Earth.
What? No, on whatever day is no atmosphere day, would be globe day, and every other day would be flat Earth day. You get holidays and every other weekend.
John, have you used a solar filter before? Did John leave? All right. I would ask Shubil, but Shubil's so fucking mad at me.
He's not mad at you, dude. He pretends he cares. He's not mad at anybody. He's mad at himself, to be honest. He's like, he's too deep in it. He's like, why didn't I just back it? If he could go back in time, he's told me. I feel like he's told me. If he could just go back in time and not consider this entire argument to consume his life, he would do it. But now he's like, I'm too deep in it. I've lost friends, by not paying attention to those relationships, and now all I have is the internet. And You know, he's confided in me about that, and it's tough. It's a tough spot.
Shubo, you've used solar filters to look at the sun, right?
Of course.
So what just got brought up is that it's not every instance using a solar filter that the sun gets obstructed by the horizon as it sets. You heard that part?
The sun always sets as it goes below the horizon, so solar filter or not, it's followed by night. So I give up.
All right. Well, that is what just got said. That even with a solar filter, the sun can appear to fade before it intersects the horizon.
Well, again, that would be marine layers and clouds.
All right. Well, I appreciate your honesty every time, dude. Thanks.
Listen, they got it. They believe all these years, and they still don't have like a 3 mile away marker of the sun intersecting that 3 mile marker for a 6 foot tall observer at the edge of calm water. You would think they would have it by now. They should have it. I mean, it would make sense to have it. Just, you know, I'm sure it all plays out, but you know,
Hey,
should
Deza.
have.
Somebody say my name?
I said Deza. I'm not sure if that's how.
Oh, that
his name
sounded
is
like
pronounced.
Jesse. Sorry.
Oh, I don't
Yo,
think he's-
Daza. Daza.
Daza. Daza.
Daza.
Daza.
Wake
Like
up.
this?
Daza.
Was I mispronouncing?
Yeah, you said it.
No,
you
I don't
said
know
it
how
right.
to pronounce it. I don't know.
My bet is he's AFK.
You want to talk to him about GPS?
I wanted to nerd out with him a little bit on linear algebra, but maybe it's for the best that he isn't here. Because I think I would bore everyone else. Well, you are here, so let me bore everyone.
My linear algebra is very rusty. So.
Let's get boring. He said, "Hold on, wait. He wants to get boring." I'm back.
Yeah, I'm gonna get a little boring, but I promise it's just gonna take a couple minutes. Yeah, no, I was just okay. I just wanted to comment on that spreadsheet that the flat earther made for CellNav.
Yeah.
Yeah. There was just this one line that I wasn't getting. How he was solving for the three planes, but it made sense. Like I tried to do the same that he did. So he only had the direction of the three planes and how far they were from the origin, right? So I noticed you could establish the definition of those three planes using their direction and distance from origin, which is just a dot product. If you take a dot product between a point and the direction of the plane, it should give the distance between that plane and the origin, right?
Yeah. My understanding was that so you have three vectors, which are the GPs of the stars.
Exactly. That's the same as the direction of the planes of the circles, right?
Yeah. The normal to the plane of the circles will be the same. Yeah.
Exactly. So if you put the base of those vectors at the origin of the coordinate system, they just point at where the planes are, right?
Yes, that's right. Yes.
Exactly.
Yeah.
So, and because they're unit vectors, what you can do is you take any point in space and take the dot product between that point and that vector. If that's going to give you the distance of that point along that normal. So if that distance matches the distance of the plane, then that point falls into the plane. So you can define the plane as a dot product between a vector and that normal, and that should equal the plane distance. And that's how you define the plane of that. You define the plane of the circle. Okay, so I got to that part, and I was like, okay, how do I now solve for the intersection of three planes? So I used the definition 3 times, one for each plane. And I noticed the three definitions together were exactly the same as multiplying a matrix by a vector.
Yeah.
And what I was the vector I was multiplying would be the solution for the three planes intersection. So I just had to find a way to undo the transformation of the matrix, and that's simply the inversion of the matrix. So you invert the matrix, you multiply by the vector, you undo the transformation, you get back to the original vector. That's where the three planes intersect.
Yep.
So yeah, very
Yeah,
nice.
yeah.
I found that just beautiful solution, and I was impressed that Flat Earther did that. But of course
No, he didn't.
He just
If
used
you ask
ChatGPT.
any of, and I didn't either. I vaguely understood what was going on, but I needed some assistance to remind me. But the description that I got when I was talking to Gemini about it to help me work through it was that the dot product equals the cos of the angle. So you get it's the other way to look at it. You're looking at
Just for normal vectors, though.
But the other way to look at it is that you're looking at the intersection of cones as well. That's the other way that the
Right.
angle.
Okay, yeah. I guess there's more than one way to interpret it. But I was interpreting the cosine as
a flat plane solution.
Right. I was interpreting the cosine of the angle as the distance between the plane and the origin. That's how I solved it. Because like if you think of that, if you put the plane tangent to the GP, it's going to be one distance from the center, right? Because it's going to be right at the surface. Now, if you now put that plane inside of Earth, going through the Earth, it now makes a circle. That circle, that's the circle of equal altitude. So the cosine of the angle, it gives you the distance between that plane and the origin.
Yep.
And that's how I solved for the three intersections, by interpreting like that. I don't like to just trust that this should work. If I don't understand intuitively, I don't bother understanding at all. That's why I try to get to the conclusion instead of looking for it.
Hey, Bacon, you and I were. Sorry, I was going to change the subject. Go ahead.
No, you're right. I was just going to say that it's a solution that I hadn't looking in the CellNav your Discord, Bacon. It's not one that I'd seen discussed in that sense before either. It was kind of unusual in that respect. People have got a lot of solutions to find those intersections, but I'd never seen one that was just straight vector algebra.
I think there's a guy called Texagenos, I think. He does not exactly like that, but he does solve for the intersection between the three planes. But I think he doesn't use the matrix inversion. I think he solved kind of like by hand the system of equations. I'm not sure what he did. But using the matrix inversion, I didn't see that coming, and when I tried to solve it, I got to the same thing. So that was very cool. So John, you want to say something?
Oh, I was just going to mention you and I had forgot. I meant to mention this earlier. We were talking about Null Island yesterday. The 0 degree longitude, 0 degree latitude place just off the coast of Africa. And it's interesting. So I went to Google Earth. I wanted to know if it knew about Null Island, and it didn't seem to know about it. But I went there, and then of course you've got the yellow lines for the equator and the prime meridian. But I ended up going down to try to get a picture of those things above the surface. Ended up accidentally going underwater in Google Earth, and there's an island there. Doesn't poke above the water, but there is an island right there, according to Google Earth.
I'm thinking that's probably a joke. I think it'd be very.
I think it is. I think it might be an actual joke that they played.
Yeah. I mean, how likely is that there's a
mound?
Exactly. Nice.
Anyway, I thought that was fun.
Yeah.
Dude, 0 degrees longitude, 0 degrees latitude.
Yeah, it's a place that people call Null Island. There's no island there. But if you go underwater in Google Earth, you see there's a big seamound that they're indicating there that I suspect isn't there at all. I think they just built it there for a joke.
Yeah.
Oh, I see what you're saying.
It's sort of an Easter egg, I guess.
You're saying it's on the prime meridian?
Exactly.
It's right at the intersection. Yeah. Right. Yeah. 0, 0.
Yeah. Just making sure I'm picturing this right. That's funny. Null Island. That's where Epstein is.
I was looking for a name because I was writing a document trying to explain how celestial navigation works, and there is a null island for the sky. It's called the first point of Aries. So where the sky meridian meets the celestial equator, It's called the first point of area. So there's a name for that point in the sky, and I wanted to make an analogy for Earth, but I couldn't. It was getting very verbose to say the intersection between the Greenwich line and the equator. Like it's a very long term to keep repeating. So I tried to find if there was a name, and then I think I actually asked that on a community of navigators, and then they answered that some people call no island. That's how I came to know this. It's not very popular, but yeah, you can Google it. It's a thing.
You ever try to look at Antarctica on Google Earth and how stupid that looks?
I think so. I think I've seen some regions of Antarctica being like less, like more blurred or
Every flat earther has seen that. Just so you know.
He never gives up.
Let me post the picture.
All right.
It's not really much to say besides the fact that it looks dumb. There it is.
You guys ever used Google Earth to try to construct a spherical triangle? You do it. You connect 3 points into a polygon, into triangle. Of course, it's so it'll kind of show you the great circle from point 1 to point 2, and then from point 2 to point 3. But then when you try to close the triangle,
they curve.
It goes all bonkers. Yeah, and
I've seen that.
I have a friend at Google who I have said many times, you need to bring this to your attention. I mean, I understand what's kind of going on. It gets hard, especially if the thing is anywhere near the pole. There's some real
I don't understand why that goes wrong.
Yeah, I don't really understand why it goes wrong, but I think I can see how it could. But it clearly can be fixed, and they just haven't.
Yeah, I mean, it's a very simple thing. Sorry, go ahead.
Yeah, so in Google Earth Desktop, you can fix it because what happens is that so when you're doing the initial polygon drawing, it's just doing a quick fix. But when you close it, it changes the line segments that's showing on the map, and it turns them into rhumb lines instead of great circles.
That's what is that what it is? Because I thought it might be.
But why? But why?
I think it's for I don't know exactly why, but in Google Earth Desktop, there's a checkbox you can change to make it use great circles, and it works correctly there.
Oh, so really? It's on purpose. So it's on purpose.
Yes.
Oh, cool. Thanks, Daz. I'm going to try.
Yeah.
It's on purpose. They just left the worst default value.
Yeah, and you can get some really weird results if you close the polygon and then you move 1 point around right near the pole. You get all these weird kind of.
Yeah, I remember Brian Leakey.
Yes,
always
that's
would
when I
bring
found
that.
out when he brought it up.
Yeah, he saw that. That definitely has to be the flat Earth evidence.
Yeah.
Anything that is just unexpected has to be some flat Earth evidence.
So where do you make the switch?
I'm not sure. I haven't actually done it in the desktop version, but there's somewhere. I'll have a look for you. I think I've got it on my PC.
Yeah, why they left that as the default on Google Earth?
That's a weird default. Yeah.
Yeah, I guess not many people use it, so maybe I don't know. But yeah, John, you think you can solve for you know what a line of position is, right?
Say again. What line of position?
Yeah.
I don't know what that means.
All right. So let's say there's a coordinate, and there is a distance to that coordinate, right? If you know your distance to a certain coordinate, there's just a set of positions you could be in. That's a circle around that position, right?
Right.
Okay. Now, but if you have an azimuth to that position, that doesn't give you a circle. That gives you another thing. I had no idea how to find that line.
So I guess I'm not sure. So give me a specific. I guess I'm not sure what you mean by having an azimuth. So the distance to a place, and know the azimuth.
No, only okay. So let's say there's a lighthouse, and I know I'm a mile to it. So if I draw a circle around the lighthouse on the map, that circle is my line of position. But if I know, for
Okay.
example, that the lighthouse is 45 degrees northeast, so I go to the lighthouse and I draw a line that goes 45 degrees southwest, and that's my line of position. So, but at short distances that works. You just flip the direction of the azimuth. But at thousands of miles of scale, that doesn't work.
Oh, right. Right. The bearing is different at the endpoints.
Well,
Right.
that's why when you're using a line of position, you start with an assumed or a dead reckoning coordinate. Now, if your dead reckoning coordinate, is within, some few dozen miles or whatever, and the GP is 2,000 miles away, that azimuth is not going to change much. So you calculate by Haversine from your dead reckoning to the GP, and
Yeah, I
that'll give
know.
you a good enough azimuth.
Yeah, no, I'm aware, but we're working with distances. So the line of positions we have are circles. That's fine. But I don't want to work with a dead reckoning. I want to have a line of position entirely, the full line.
Well,
Based
then
on
you but then you have to have solved for a position first before you can get an azimuth.
No, of course, in celestial navigation, of course. But let's say I'm not doing celestial navigation. I just have an azimuth to a star, and I want to know the full line of position that matches the azimuth to that star.
Well, if you have a way to measure the azimuth and the zenith angle, yeah, I think as you've shown, you can go from the GP, and of course the azimuth from your location to GP is not 180 degrees different from the GP to you, as I'm sure you're aware.
I think I've not explained myself correctly. Maybe
Dude, every
let me
server
illustrate
sucks
that.
right now, man. Y'all gotta make it interesting. Everywhere else sucks today. Come on, y'all gotta start disagreeing or something.
Okay, in a bit. Okay, I was about to disagree with Shubio.
All right, good.
Okay, so let me see. You see my screen? I don't think anybody's seeing my screen.
So why do you think Shubio is wrong?
I see your screen.
All right, so I have one line of position here. It's defined by latitude and longitude. That's the GP, and this radius, that's the distance, right? So this diff is just like my margin of error. So I could be half a degree wrong. So that gives the thickness of this line. So if I pick let's say a larger, let's say 2 degrees, then it's going to be thicker. Okay. If instead of a radius I have an azimuth, then I could be anywhere on those two weird curves. Those are the line of position that matches this azimuth. And they aren't circles. They are very weird lines. So let me put like 45 degrees, for example. Oh no, that's not a good example. So that's like a 30 degree.
Wow, it's a baseball team.
Yeah. And yeah, I have no idea. Like I'm plotting here because for each pixel on the screen, I'm solving for the coordinates. I'm calculating what's the actual azimuth at that pixel, and seeing if that matches what's here within the tolerance. If it is,
that's great.
Can you plot the GP?
Yes, I'll just copy this line here and make it a radius instead, and say the radius is 0.
So then you know where you are.
I'm looking for the GP.
Oh, the GP is almost at the it's almost at the north. Let me pick a different. Oh no, it's not the north. Okay, that's the GP. That white dot, that's the GP.
And now, so now make the radius something, not 0.
Oh, which radius?
So you got the GP by making the radius 0, right?
Yeah, so if I put 10,
so make it not 0. Yeah. So with both of those, you know where you are.
No, that's the GP of the star I'm measuring to.
But I mean, if you know the azimuth and the elevation of the star, so that you know
then
it's GP,
then I'll be right here. But that's not what I'm trying to
Yeah.
find. I'm trying to find how do I plot the azimuth line.
What's the formula for it? Is that what you mean?
Yes, exactly. I want to.
I see. Oh, right.
if I want to get a set of points along a circle of equal altitude, that's easy. But if I want to get a set of points that are on the azimuth
Oh,
line,
interesting. Yeah, nice.
I have no idea how to do that. And I tried.
Well, because keep in mind, as you're going away from the GP, even if you're going in a straight piece of great circle, it's just a straight line away from the GP, that azimuth is continuously changing.
Exactly.
Yeah, that's what he's saying. Yeah.
Well, yeah, but that's the rule of thumb on the Earth. A line of constant azimuth is a curve, and a curve is a line of constant azimuth.
Well, what do you mean by a curve is a line of constant azimuth? Not all curves.
Well, as you go along the portion of great circle, the azimuth is instantaneous along that curve.
Well, it changes along the curve, in other words. Right? Along a great circle, the azimuth will be different. Yeah, no, but that's right. I mean, the question is how you should be able to, it does seem, I mean, it's a complicated trigonometric relation you're trying to solve.
Well, are you
So I
plotting?
can
Are you
see how it'd be
plotting
difficult.
Are you plotting a constant azimuth?
Yeah, that blue line is a curve of constant
Well, a
azimuth.
constant azimuth is not a straight line, or not is
Well,
not
you can
constant
see
azimuth
that.
is not a portion. A constant azimuth is not a great circle.
Right, that's clear from the picture that
That's
he's
why it's
showing.
difficult. Yeah.
Yeah, it's the old loxodrome orthodrome syndrome.
Oh, what's the loxodrome?
A loxodrome, well, you have great circle and rum line, loxodrome, orthodrome. A rum line is a loxodrome.
Rum line? Oh, okay. I didn't know that word. Yeah.
And a great circle is an orthodrome.
Oh, okay.
If you got to get hoity-toity about it.
Yeah, I was talking to Bacon a little bit about that because it's interesting. I mean, that ancient navigation made really good use of rum lines because they're easy. They're pretty damn close to great circles if you're not going very far. And
also if you're like transiting the Atlantic and you're
perfect.
south of the 70th parallel, and that's why the Mercator map was just fine because if you're in a sailing ship, you're not going to split hairs. Just hold that constant azimuth because really, you're at the vagaries of the wind. But
and this is why Heffron was having some trouble with his theodolite, right? That the azimuth.
Heffron's got a lot more. Heffron's got a lot more trouble than that.
So, is there an update today? I thought Mike was, or I thought Alan was suggesting there was going to be one.
You look at this now. Like, if
That's
I put
amazing,
it like,
yeah.
if I put like under 45, let's say 40, 42, they start getting like I have two lines going in this way. But if I put larger than 45, like 50, now they connect like this instead of like that.
Yeah,
like this.
That's very pretty.
Yeah, and at 45 they kind of make it this weird X. I don't think this is solvable analytically. I don't think this is analytically solvable.
Yeah, that broken symmetry thing, the reconnection is weird.
Yeah, because if you have if you're somewhere on Earth and the GP is 2,000 miles away from you, the azimuth from you to the GP is not 180 degrees opposed from the GP to you.
I made that mistake when I was trying to do triangles using Google Earth in the US, just triangles between cities in the US. And first thing I did was I would just take the bearing at either end and assume that it was, applicable at either end. And then I started getting crazy results, and it took me a little while to realize that was the mistake I was making.
And the geodetic inverse utility I use is at National Geodetic, and you key in a pair of latitude longitudes, and it gives you forward azimuth and back azimuth. And yeah, they're not 180 degrees opposed. And if you're dealing with multiple 1,000-mile long lines, yeah, they are grossly different.
Right.
Oh, have you guys ever seen how the Great Circle Root formula is derived?
Well, I know the Haversine approximates it, but if you get into the full Monty like Vincenti, yeah, it's pretty high order.
No. Yeah, no, I'm talking about Haversine. Not exactly Haversine, because like the Great Circle Root formula and Haversine, they are identical. They have for the same inputs, they have the same outputs. But there are different formulations. The Great Circle Root is a little simpler. And the way you derive that is very, very neat, I found. Anyway, I just wonder if you've ever seen that. Like, I've derived by accident. I was when I needed the Great Circle Root distance formula, I created my own version, which was pretty bad. It was a very long formula, and I used that for a while, and I realized I could simplify it. When I simplified it, what came out of that simplification was the Great Circle Root formula.
Now here's a formulary, a library of formulae that is you might find some useful. That's been around for a long time.
Oh, that's against my religion. My religion says I can only use formulas that I can derive.
You have a really strong case of not invented here syndrome, I think, Bacon. You know that
Oh,
one?
what? No, what's that?
Well, in academia, there's this whole thing called not invented here. If everybody wants to do whatever they do their way, somebody else has figured out a way to do it, we don't care. That wasn't invented here, right?
Right. Yeah. Well, I think I kind of
But it's
developed
good. I
that
mean, I
because of
like
flat
it.
earthers.
I'm kind of like you. I think the difference is I think, okay, I should try deriving the Great Circle formula. I say, no, I don't want to,
Right.
but I think
Well,
so. I think it's really impressive that you actually follow through and do all those things.
can I show you how the derivation goes? At least how it went for me. If
it doesn't take long, I have to get somewhere before the hardware stores close here at 5. So.
Okay, I'll try to make it as short as I can. So this is Earth. I'm going to use like an XYZ coordinate system here. Sort of like ECF. You know ECF, right?
I don't know what that means. ECF?
ECEF, the coordinate system GPS uses.
Earth-centered, Earth-fixed, rectangular.
Oh, okay.
So basically, this is the prime meridian, and this is the x-axis, this is the y-axis, and this is the z-axis, right? So you pick a point at the prime meridian to be your point A, for example, and another random point to be your point B. I'm picking the position at the prime meridian because the prime meridian is arbitrary.
Yeah. Yeah.
So So all you need is the difference between the longitude of A and longitude of B. You just pick whatever latitude A is to be your prime meridian, and then you simplify everything. So now you have two vectors, one that is here at A and one that is there at B. Probably, it's easy to work out what those two vectors are. Like the x here is the cosine.
Well, you're solving a spherical triangle.
No, because one point is inside of the Earth, and I'm using Euclidean geometry here. But essentially, I want to find this angle here, right? The angle is going to be equivalent to the distance here. So as I mentioned, you can take the dot product between two vectors, and that's the same thing as projecting one onto the other. So for example, if you take the dot product to A and B, you project A into B, so you get the distance between this point here and the origin. So the dot product gives you exactly this distance here. And because this is a 90-degree angle, you can find this angle here from the cosine of this distance. Sorry, this distance is the cosine of this angle. So if you use the inverse function, like the inverse cosine of the dot product between A and B,
Yeah, right.
you get the angle, which is also the distance in like radians. So you just have to multiply this by the radius to get the distance in a linear function. And the nice thing is, because A is at the prime meridian, it doesn't have a y value, so AY is 0. So when you take the dot product between A and B, you have AX times BX, and AI times BY goes away because AY is 0. So plus
AZBZ.
Exactly, AZBZ. And so now you just have to work out X and Z, and that's pretty simple. So the X of A, that's just the cosine of the latitude. And then BX is the cosine of the difference here in latitude. We usually call that local hour angle. And the sine of the longitude of B. So
Right. So I see how you get the angle and everything, but now you want to get the actual formula for the path, right? How
exactly.
how latitude,
Exactly.
longitude. Yeah.
Yeah. So it's the other way around. So it's the cosine of the local hour angle times this the sine of the cosine of the declination. So declination is the latitude of B, because usually B is the GP of a star. So we call the latitude of B just declination, so we don't get confused with our own latitude, which is the latitude of A. So declination here is simply the latitude of B. So that's for the first, for the X value. This is the X of A, and this is the X of B. And then the Y is just the sine of the latitude times the sine of the declination, because this is the Z of A. A simply goes up here as the sine of the latitude. And same goes for B, so it's just the sine of the declination. Now, if you look at the great circle root formula, is exactly this, the arc cosine of this. That's the great circle root formula. Times R.
Okay, so I guess I missed something in there.
What?
So let's see. So what is the variable paren? So you're saying, so to get the path, you have to know what latitude to be at as a function of longitude along that path, say. Is that what you're doing? The latitude is a function of longitude going from A to B?
What?
Well, I thought you were getting the formula for the path. I see how you got the angle.
The great circle root formula is the distance between A and B.
Oh, is that what? Oh, that's all you wanted was the distance?
Exactly.
Oh, okay. I thought you were actually getting a formula for the path.
Oh, no. The path.
Okay.
I could. Yeah. It's you can do the formula for the path.
It's probably only a few more steps, but yeah.
Yeah, it's one of the Havasine variants, isn't it?
Yeah,
you know,
exactly.
I have never used Haversine, but
it's okay. I say it's about 5 parts in 1,000 accurate most scenarios, but the trouble is when you've got long distances on vastly opposing positions on the sphere, it falls over.
Yeah, but in celestial navigation, you don't wanna use any formulas for distance that account for the eccentricity. You do wanna treat Earth as a sphere, not as an ellipsoid in celestial navigation.
It's Havasine falls over for antipodal points, not because of eccentricity. The mass falls over because there's a trigonometric function that has an asymptotic nature, which means if you've got like 2 points opposite side of the world, it doesn't fare well.
Yeah, this if you take the dot product between A and B and they are antipodal, you get 0.
Yeah.
And our cosine of 0, that is
That's why Vincenti's is used in it for most, in preference to it.
Oh no! No. This does work. This does work for antipodal points, because dot product between A and B when they're antipodal is going to be -1, and our cosine of -1 is 180 degrees. So that's going to work for antipodal points too.
Yeah, there's an aspect of it that falls over when they're vastly within. I think it was in the
I don't
near
think this
anti-proton.
one. I don't think this one has any problems.
Okay.
Maybe Haversign does. I don't think this one does. Oh, by the way, yeah, you can't. I mean, you can, but if you used formulas for distance in celestial navigation that account for the eccentricity, you would get worse results. I thought maybe I would get a Y, but never mind.
Well, I mean, yeah. All right. I mean, at the end of the day, the eccentricity, what, 12 kilometers over the radius? I mean,
Well, it's not because it's insignificant. It's for different reasons.
okay.
Like in celestial navigation, we like it's related to how we determine latitude. Like we use geodetic latitude, not geocentric latitude. And the geodetic latitude is the one that matches. Like if you assume Earth is a sphere on an ellipsoid, you're gonna get geodetic latitude. So because we use geodetic latitude, you want to assume a sphere when you're doing celestial navigation. It's a bit complicated to explain, but
no.
Yeah. Damn, I killed a VC. I was expecting showing derivations of formulas.
You might have lost a few flat earthers in the process.
What's that?
I say you might have lost a few flat earthers in the process, or they may be just checking their charts to find out exactly which inflection to use on. Have you considered nuh-uh?
Right.
But yeah, I honestly came in when somebody was talking about something else, and I heard you talking about this, and then I got a phone call, so I missed part of your explanation. But I think a lot of the people that do say nah or variations on that would do well to spend some time looking at the maths involved in making these calculations. And I think, like, didn't MC Toon recently have a show where he like went over somebody's attempt at his challenge to do celestial navigation? Like,
Yeah, there was a recent video from.
Yeah, I was listening to some of that. I don't think I made it through the whole thing, but you know, the gist of it was anything they got right, they got by using the globe, because nothing on the flat Earth would actually work. And the flat Earth math is so easy. If it was a flat Earth, like you almost don't need to know anything.
Right.
The complexity of mapping it all out on a spherical object is why it's a little bit complicated. But honestly, like if it was a flat Earth, you'd know right away because the math would be so simple.
Yeah,
and it doesn't
definitely.
work because none of the angles make any sense. Like that should be self-evident. At least I think it should. But
yeah, it's the same reason if they say they don't have a map. Well, if the Earth was flat, that'd be easy. It'd just be one scale, and you could do the whole Earth on instead of as we have with map sheets that are broken into zones because projections are only really applicable to a given area.
Yeah, why are flight charts, like paper flight charts, why are they such small sections of the world? Because they start to get really, really inaccurate.
Any projection that is used to an area too large, starts that's why they limit it to where scale factors are not appreciable. They're like 1 in 50,000 scale factors. But
you're not going to be like way off.
I pull I pulled up a map of Australia in Mercator, in Lambert, and azimuth equidistant, and they look identical. But it's just
Australia.
just limited to Australia.
And Australia is about the same as the contiguous USA in terms of landmass, I think.
Yeah,
right?
it's still pretty fucking big. Yeah.
It's big, but yeah. Yeah.
This spreadsheet I'm sharing, this is supposed to be a solution for Mectune. Oh, I'm a feather fan. Okay, MC Tune. Yeah. $10,000 challenge. The guy who shared this thinks this is like a flat Earth proof of celestial navigation. So I went to the spreadsheet, checking calculation by calculation, and he does use planar math, and then he completely discards it and starts from scratch again using exactly the same formulas that I use for the globe.
That seems a little bit problematic. It's certainly inconvenient to back up the flat Earth.
Yeah.
But yeah, I don't know. I like the fact that people are willing to have conversations. Like when this place has got good conversations going in it, whether they're from people that are learned on the subject or not, I think people can learn something, or at least understand why we ask for someone to say, "Hey, how did you do this?" Like, and there now you've gone and you've said, "Hey, this is how this is done." I don't know to what level of detail you went because I missed a chunk of it there, but you know, like if somebody goes on, It's Earth is Life has like this broadcast, right? You go there and watch that on the YouTube channel or listen to it. You might learn something, or at least learn what you should look into. And if they have a better solution, they could take that and say, no, like you got this all completely wrong. This is the way you should do it, and that's what proves the flat Earth. And then they get like their shorts in a knot when somebody asks them to do that. They just like, I don't know. It's weird how they won't bring their own math and show like how it's done.
Well, sometimes they do, and it turns out they're using our math, or they're using their math, but it won't work.
Or there's just something else they don't get. I mean, there was quite a big hullabaloo with, and this does get back into math with, what was that guy's name again? I know Alan and Shane were involved, but so was, what was Buddy's name there? The guy who was like a computer doctor or something. They did that celestial theodolite thing, like that. They took some measurements and brought something and said, hey, look, we got this. We figured it out. And I don't think they got anything, but I do applaud the effort to try and actually bring something. They should get.
I don't. No, I don't. That's Dr. Heffron, and what they're doing is so juvenile. It's ridiculous. It's absolutely horrific. Considering he calls himself Dr. Heffron, he can't possibly have, be that poor in math.
You'd think not. Again, if he's a doctor in computer science, he certainly would have great mathematical background, I would think.
Well, what he does is they come up with a flat Earth elevation prediction for the mountain ridge. And then they go to Stellarium and they do whatever they need to do to Stellarium until they get that angle to show up. They'll alter the times, they'll add some voodoo until they can see that number show up. They'll toggle refraction on and off. They use the coordinate of the observer and and they use the same coordinate of the observer at the mountain. And it's like, where do you get up? There's only one observer. They'll alter times because, the azimuth is wrong in Stellarium, so they alter the times. And they go, well, no, wait. All you have is time. So every time I've used Stellarium as a QC tool for my star measurements, I agree within, a few arc seconds. But against my measurement, and which proves my latitude, longitude, which proves my timing, which proves my instrument, and all's right with the world.
Well, so then it sounds like what they've done is disingenuous from the start.
Oh yeah, yeah.
Or we have to assume somebody got a PhD is intellectually deficient in either intellectual honesty or capacity.
It's a complete snow job, without doubt. They have dazzled. They are trying to dazzle with bullshit.
Well, and I guess I still stand by like the fact that they actually brought something along, but I'm not surprised that it's bullshit. And I believe I actually called Alan out on it being bullshit when I read through some of what was in there, because he was upset with Rob on a video Rob made about it, Professor Parks. I guess perhaps I'm overly familiar with Rob, but you know, I tend to go first names with people. But he made a little video like saying, hey, like, you know, you've come to play here and you've missed this, and this, and you're not getting it. And I think Ruhif did a really good video explaining where they went wrong, and there was somebody else did one too, that I thought was really good at pointing out about like how the refraction works. It was I Can Science That, I think, right? I think that's right. And regardless, once they've been pointed out like what some difficulties are, instead of having another look, they're pushing back and saying, no, you don't understand what we've done here. And I think that's what I was pushing back on.
I sent you a message back, Shoebill. I really liked that video. I don't know if you got it or not, though.
I lost the audio in there. What's
You mean that mine collapse? You mean the mine collapse?
Yeah.
Yeah, when I saw that, it was like I thought sure there was a driver sitting on that tractor.
No, the driver's the one that's talking, and probably somebody there with him. What they've done, they've saw the dribbling rock and they've hopped off and run back out of the way. But that's what I was saying when I worked in the coal mines. It was you had to crawl, and when stuff like that started happening, you couldn't run. You know, you could just hope that you saw it in time to get out of the way. And I've seen that exact thing that they showed there more times than I can count.
I can't see what you're talking about, but it sounds terrifying.
So when I saw that,
I'll post it in the chat.
When I saw that, I immediately thought of you.
I think coal mine's one of the types of mines I've never been to, but I've never actually worked in a mine. I just bring stuff to mines and away from mines. In my trucking business life, but we go to a lot of different mines. They have some amazing things they do, but I can only imagine like how scary it must be to be trapped in such a confined space. Something goes wrong. Is this the one you're talking about? Is that the one that was in the news last week? There was a massive mine collapse somewhere. I just don't remember all the details. I had a crazy week.
Hey, Daza, I see you sometimes use the bot to get some random fixes, right? You're using that to challenge any flat earther?
Yeah, when I was dealing with I Win You Lose about his McToon challenge, I thought I'd just grab a few thingos to see if he could solve them, and he got them right because his solution was
correct.
Yeah, solving for the globes.
Yeah, and it's funny that he first does some calculation that makes sense on the flat Earth. He makes like the A plotting, almost because he when he's using the distance from the North Pole, instead of doing 90 degrees minus the declination, he just uses the declination as it is, making the equator a point and the North Pole a circle, and and all the southern positions negative. Except for that, he does do the right thing for the EMAP, but then he doesn't use that at all for the rest of the calculations. He just starts from scratch.
That's right. Yeah, that's what my conversation with him was hinging around, was that, I realized that there was a complete disconnect between the whole green model and the map and then the final solution, that there was just assuming that all of the stuff before made everything behave exactly as though you're on a sphere with a celestial sphere.
Yeah. And even ChatGPT was very clever to recommend the stereographic projection, because you could, in theory, use the stereographic projections to plot the circles and get the intersection, because the circles are still circular in the stereographic projection. However, that's just not what he's doing. He's not using any math related to the stereographic projection there.
No.
Posted it in the chat for you, Al Trucker. That video, if you wanted to watch it too.
Oh, okay. I'll check it out. I'll have to check it out when I'm not driving. But yeah, that sounds like.
Go ahead, guys.
That sounds like something mind blowing. Pardon the pun. That wasn't intentional.
Y'all can continue with your conversation. I was just telling him that real quick.
Wow. Hey, I don't even know if we had a conversation going anywhere. I thought my audio was clipping in and out because I was getting the old, the ding when you enter the channel. So I thought maybe I'd left, that my connection had gone in and out. But I think maybe people were coming and going. I really can't tell the difference from where I sit. I don't know who's talking. I recognize some people's voices and not others. So what is it, Monday? It's not a big night for flat Earth debunkers, is it, on a Monday? It'd be interesting to see some people take on some of these challenges and do the kind of the step-by-step videos that you see from the people like Ruhif and I Can Science That, and there's some other good creators that do that. But making if a flat earther could actually educate us on where we get it wrong, that would be really cool. I'd like to see that.
Oh, in his in the I win you lose spreadsheet, there's some questions and answers in the bottom. The first one says, does its spreadsheet secretly uses globe geometry? And it answers, no. Ground points are plotted on flat XY plane. Yes, and then they are discarded. There is another question here. Will a globe intercept resolver give the same fix? And it says no.
All right. This is the one. Is this the one that the guy brought to Toon's challenge, or was it
Yeah.
Oh, okay. All right. That's the one that I was talking about earlier. Okay, cool. I think I should look into this one a little bit more, but I've been so much on my plate between work and home responsibilities. I haven't had a chance to do anything other than listen while I'm driving. So the visuals and the data are kind of out of my field of view. So I have to try and imagine how things are going together. But I've driven around the globe to check that we're on one, so I know what's going on, but I also think a lot of this stuff can be pretty interesting, especially if they're being deceptive. It's interesting that they'd have to be. I would think if we're unequivocally on a flat and not a globe, it would all just work out without any deception.
that's right. Yeah, the interesting thing I find about when you loses ChatGPT is when you go into it. When it gives you a link to the chat. If you ask it whether or not this can possibly represent physical reality, it'll tell you no, and it'll basically tell you anything. Depending on how you phrase your question, it will answer exactly as you expect it to. So if he asks it about the approach that he's taking with it, he gets answers that support him. If I ask it whether or not this is realistic, whether this is the same as spherical solution, whether or not it solves for all people in all places at once, and things like that, it tells me no, it can't. But then he's able to ask it different questions that support his outcome, and it's classic LLM behavior, I think.
Yeah,
I
it's
just-
do that though.
I just found something very weird on his spreadsheet. Let me share this. If you look, there's a column called H corrected, and it's converting the. Let me see, D7. Yeah, so there's these columns have the sextant heights, degrees and minutes. So of course you just divide the minutes by 60 and add the degrees. And he does that, but he also does some weird things that don't make sense here. Like he's doing minus 0.3 divided by 60, minus 248 divided by 69. This is all just a single constant. Why is he doing this separately? Those are not variables. Why he's doing, and he does the same for the three angles. Like the three angles are subtracting the same constant. It doesn't make sense. What is this?
Wow.
Is this supposed to be deep correction or something like that? I don't know. It takes out 3 arc minutes, then 2.48 arc minutes, then 9 arc minutes. Why? No idea.
Does he show the dip correction on the spreadsheet as well, or
he shows what?
Or does he show taking a dip correction and putting that in from his height? Because the dip correction gives you that's in a table as well, I think, right? But you can measure what it is, and then the table helps you fix it, if I remember correctly. But I've never done it. I've read up on it a little bit and watched a few videos, but like I remember it's a thing you got to worry about.
Yeah. It's a minor correction if you don't. But Toon's challenge, I think he didn't need it any. I think they were taking
I think he was giving them like such a large.
Oh yeah, 2 meters. Just 2 meters.
Yeah, you wouldn't have to. He's not asking somebody to hit the head of a pin here. He's asking them to hit like
20 nautical miles.
20 nautical. Yeah, that's pretty big. Yeah, I would think
Yeah, you don't need to account for refraction. You don't need to account for...
Yeah, unless you're at some massive height, it wouldn't matter. And was this person that did this like on some sort of a vessel at sea, or did they just like walk out into their garden, or like what did they do here?
The first step of the challenge, the sightings from the first step of the challenge, come from a YouTube video.
Okay.
So everybody that found the video knows the answer because of obviously the video shows how to solve it and gives you the answer. That's how Brian Leakey found the answer first.
Yeah.
He found the
Brian
video.
Leakey,
Yeah, but of course the challenge is not just to solve this set of readings; it's to solve all sets of readings. So if you solve this, then he's going to give you a new one, and the new one is going to be.
Yeah, that would be the key, right? Is that your method should work no matter where you are.
Exactly. And it's the smart part from Toon's side was to not establish the second set of sites. So he can look at your method. Maybe you made a method that works for this particular site, and maybe for some others. So he can easily find one where your method doesn't work. If it doesn't work everywhere.
Yeah, if it doesn't work, but if you use correct methodology,
then it works everywhere.
Try to test it. Like the very fact that prior to GPS navigation, although some boats did run aground and accidents happen and this, that, and the other thing, and they might have been more common per shipping mile. I have no idea, but ships made it to port relatively unscathed for centuries. So they knew what they were doing, and the fact that happened is a pretty good proof that celestial navigation is a damn good way to get around.
Right.
So, I realize ships are far more complex nowadays. There was somebody, I don't remember if it was on this channel or another one, but there was Tiny Captain was on, but there was also someone who claimed, and I don't think Tiny Captain was around, but then he came back a couple of weeks later and we told him about it, and he listened to what was said. But the person claimed that they knew somebody that set up equipment in the helms of complex ships, and that none of the ships were set up to work on a globe, and it was all based on flat Earth navigation. And they were not the expert party in this. They were just recounting what the expert party said. And I was just like, that is just, it's got to be hot nonsense. But it's interesting what people will say, like third and fourth hand accounts, and then take that as like far more likely to be accurate than like hearing from someone like Tiny Captain, who is a ship's captain and has been all over the globe moving ships around and knows the systems on multiple ships, because like his specific job is picking up ships and getting them to places, not being on one ship like all day every day is a regular job. So he's like a ship delivery captain or something. I'm sure there's a better word for it than that, but he's done some cool shit. And the fact that he gets his shit where it goes in the correct number of days and all that kind of stuff is another good proof. But even like the navigation I do across Canada, like, why is Canada the right size every fucking time I do it?
Yeah.
And I would bet Australian lorry drivers, what do they call them down there? Truckies. Australian truckies would also find that their navigation works perfectly on Australia as well. That whole sort of continent probably is the right size. It probably works out every fucking time.
Yeah, I've driven across Australia and from top to bottom in a couple of locations, and I can guarantee you that the miles match the map.
Weird, eh?
Yeah.
Who is that? Is that Ruhif?
No, a lot of people say that. It's Dazza.
Oh, it's okay. Sorry.
Yeah, there's
Sorry,
more than one Australian.
I know there's 3 or 4 of them at least.
Yeah, there's eggshells. There's eggshells.
We have a few Canadians up here too, so like I guess we need to
only
balance
one
it out
Brazilian.
on the bottom. There's only one Brazilian?
Yeah, unfortunately, I'm alone in this club.
We got a few more.
Yeah. I mean, I always hear that there's 7 million flat earthers, or 7% of the Brazilians are flat earthers, but I can't find any.
7%?
Something like that, yeah.
Okay, but you're not among them, obviously.
Nope, but
you
not
understand
able.
You understand too much about everything. Yeah, that's not possible. Okay, sorry for misidentifying the Australians. I can't see anybody's name. I'm just listening. So if I hear an Australian accent, I'm probably like gonna just say, "Hey, that must be Ruhif," because there's only 5 Australians anyway, right?
Yeah, and we're all paid shills because Australia doesn't really exist. So.
That's right. That's right. Tell me, have you met Jillaroo Jess? Because I'm assuming there's only with only 5 people there, you've run into her, right?
That's right. Well, I come from a small country town in Australia, and yeah, it's pretty hard not to meet somebody that's not a relative or a friend of a relative. It's very small.
Yeah, we have stuff like that here too, and people also assume that I know their friend in Canada here because there's so few of us. relative to our size. I think it's just Canada have that in common. A massive land mass with like very few people. But we're so spread out, we don't know any of the others. But yeah, my wife grew up in a pretty small place, and it's amazing. Like as our kids went through school, like even though we live in a town over from the town she grew up in, but it's so many people from all the same families. Like she's like, oh yeah, that kid's mother I went to school with, or that kid's mother's brother was in my class, or that kind of like that's kind of a small town we live in. But I grew up in a big city and then moved to the country where I belong, because I was a displaced country. I was a country kid that didn't belong in the city, but ended up growing up there anyway. Totally fucked up my whole life. It's very quiet in here with no flat earthers coming in to tell us we're wrong about everything.
Yeah.
Yeah, they're all getting ready for the theodolite update, which is about to start in geos. So.
Oh, there's a theodolite update.
Yeah, number 18.
Which theodolite?
The celestial theodolite.
Oh, that's that. I thought maybe they were getting new software on their like, I don't know, like what's a good brand of theodolite? Does Stabilia still make them? I know Leica makes the optics for a lot of like surveying tools. I haven't been around this shit in a while. I don't really pay that much attention to what goes on in it anymore. Stabilia used to make a lot of really cool stuff for surveying and like layout, construction site layout. When I worked in construction, we saw a lot of that shit. And a lot of stuff from Leica and a lot of stuff from, oh fuck, there's another brand too. And the equipment we used on site, like once we knew what everything was, we gravitated towards Hilti because the Liechtensteinians have like a stranglehold on precision laser implements that can take getting knocked around on a construction site. But they're not surveying instruments. They just once you've had the survey done, they just help you keep the grade. Another brand too that people like. I'm blanking on what it is. I've never met anybody from Liechtenstein. I wonder if there's any flat earthers there.
Yeah, I'm gonna go make some dinner. You guys have a good one.
You making dinner?
Yeah, I'll make some dinner. So,
What are we having?
Good night.
What are we having? How long is it gonna take me to get down there? I guess I gotta cross the Darien Gap. That might take me an extra hour or two.
I think I only have stuff to make spaghetti.
It's my favorite meal. It's my favorite meal. I'll be right over.
All right.
I make a left here to get to Brazil.
Yeah.
I don't know. I can get home in about half an hour, but I got to stop for fuel. So I guess probably I'll eat whatever my family's having. But that sounds really good.
Yeah. Oh, Barry's here. Let me. He just asked a question on the chat, and I was about to leave, but
Okay.
I can stay a little longer to explain. You're on, Barrow. You can hear me.
I can hear you. I don't know if the other guy can hear you though.
Yeah, maybe he's busy or something. Because he said bacon, but he didn't tag me. So if I wasn't reading the chat, I'll have missed it.
Yeah. 'Cause people, I do that too. I respond to voice chat. Like if I'm at home, my wife would kill me if I started shouting at all of you people here. Because I'm really loud. I don't know if you've noticed. It might not be. Like, you can turn the volume down on your computer, so maybe you don't notice.
Yeah, my girl doesn't usually like when I'm debating flat earthers on Discord.
Yeah.
I don't
Why
think
are you
you
doing
know.
that?
Yeah.
It's a useless enterprise, but it's entertaining.
It is. Well, at least it's somewhat of addicting.
You know what? It's great though because it's since listening to this stuff, I've reignited my passion for science. So I've always worked with science, like in all of my business endeavors. Science has been a big part of it. People don't usually think of it that way, but engineering and material science are like key parts of what I did for my career. And I just ran a business like making sure things got built properly, and building things properly means using the right thing in the right place at the right time and knowing what's going to work and what isn't. And that was my job for a long time. So I, a lot of that is by experience and knowledge and stuff handed down, but it's also, there's science behind it. There's a reason why you can't put certain things together and expect them to last very long. And people have learned by, trying it and failing, but also, there's ways to mitigate that. So like you learn that and you do it and you find out why, what is the problem? And then the mitigation will actually work because you solved the problem. So that was an interesting part of my job, and I always found it interesting, but I didn't really get to think about it too much. But now that I've retired and become a truck driver and I can just think about things all day and dodge BMW drivers, it's just amazing. I have a good time.
Yeah.
And flat earthers, when they say, why do you say that is true? It gives you the chance to think. It's like, well, why do I say this is true? Well, I say it's true because, and then I check the thing I already know in my brain because I learned it, or is it something that I should double check? Why we know this as humanity, or why maybe I shouldn't believe what people tell me about it? And in almost all cases, I find out that we have really well-founded reasons to believe things, or I just, remember to myself exactly why it is that something is known to be a certain way. But I think it's a good thing to challenge what you know. But I also think, like, when I was educated, we weren't just told this is the way it is, write it down and remember it. We were told, what do you think is going to happen when, like, as far as science, what do you think is going to happen if we do this? And we'd guess, and the more experiments we did, the more we knew what might happen. And we tried a bunch of stuff. We measured a bunch of stuff. We did measurements, observations, predictions. We did hypotheses. It was all at a high school level for me, but, we actually tried things and wrote down what we tried and got results. And then when we wrote down what the math told us about stuff, like what's the acceleration due to gravity on Earth, we got 9.81 meters per second squared, strangely enough. This is one example, right? But they say, like, you've just been told this. Well, no, like, I wasn't just told this. I was told that we should think about how we could figure something out, and then we tried a bunch of stuff. And it turned out that what is the accepted value is what we found it to be. But we weren't told what the accepted value was before we did the experiments. Some of us already knew what it was, of course, but no one said, hey, it's going to be 9.8. It's just do the experiment, measure it, and figure out what you get. And if you got something like way off. We did the experiment so many times. So if you got a number that was way off, you're like, oh, well, we must have, like, somebody must have knocked something over. Somebody must have, like, not let the ticker tape run. Because that was one of the things we did, was we did a weight fall and run a ticker tape to check the, like, you had a thing that would tap the ticker tape with, like, a carbon paper, and that would tell you, when you measure the distance between each one, it made an imprint every so many fractions of a second, and you knew what its frequency was, and you tested that frequency, and by knowing that, you could then see how fast it was accelerating, because of course as it went down, the distance between the dots got bigger because it was moving faster. It was a really simple experiment to test the acceleration due to gravity, and it was done like in a high school classroom.
Yeah. Yeah, I did some stuff like that on college too.
Yeah, like it's
pretty cool.
It is cool, and it also flies in the face of what they tell us about, like, how, you know, we get all this stuff handed to us. Not at the school I went to, and if that is handed to people at other schools, like, I could only weep for the terrible education people are getting. I think, like, you said you're from, is it Brazil?
Yeah.
Yeah, so Brazil is like a pretty modern, smart country full of like it's like, you know, it's, people may think of it because it's in South America, they may think little of it, but it's a hugely well developed, like, country with, like, massive cities and great, like, really well educated people and technologically advanced society. Like, people tend to, like, in the Western world, the quote unquote Western world, by which I mean like English speaking Western world, countries like yours get ignored, but, you know, the Brazilians are pretty smart people, and I think they educate their youth well. I think that's, like, that would not surprise me that they're getting a good education. I wonder if that's true everywhere, but I'm really lucky to have been born into a country where, like, education's fairly valued. They educate you up until the age of about 18, 19, and then you got to start paying for education, which I think is something we should reevaluate. And my kids are now getting old enough to be looking at, like, what we call post-secondary education, and that you have to pay for it. I understand in some countries, in some areas, they give you tax dollars towards getting educated, no matter who you are, which I think is maybe a better way to handle it.
Right.
Like, well-educated people are extremely productive and helpful and make great members of society, generally speaking. And they don't buy bullshit too, which is, I guess bullshitters don't like it, but bullshitters be damned. That's what I say. My boss has a cattle farm. If I want bullshit, I can go get some there, but it smells like shit, and it's, like, not really helpful. I think I'm almost at a place to get some fuel. At least we're not being very good at entertaining people on Earth as life, are we? to run get fuel.
Hey, Beryl, can you hear me? Beryl? Beryl Ryder? If you're saying something, your microphone is turned off.
Hello? Hello?